Cloud computing is like having your digital assistant. It's a technology that enables you to access data, applications, and services over the internet anytime, anywhere. In a world where everything is becoming digital, cloud computing is the engine that keeps it all running smoothly, offering convenience and flexibility like never before. In this digital world, cloud architects are the masterminds who make it all possible. They design and manage the infrastructure that supports the cloud, ensuring its reliability and security. On that note, hello everyone and welcome to this session on the Cloud Architect full course. Join us on an exciting journey as we explore the Cloud Architect full course and gain essential knowledge for a successful career as a cloud architect. But before we get started, let's take a moment to outline the agenda for today's session. First, we will begin with a brief introduction to cloud computing, followed by an overview of AWS. Moving ahead, we will explore how to become a cloud architect, discussing the high demand for cloud architecture, job trends, necessary skills, as well as the roles and responsibilities. Progressing further, we will cover the AWS instances and AWS networking fundamentals. We will explore Amazon VPC and its functionalities. As we progress, we will explore AWS services like AWS Lambda for serverless computing, AWS EMR for big data processing, and cloud storage on AWS. Additionally, we will introduce you to another AWS services including AWS S3, AWS CloudFormation, AWS API, Gateway, and Amazon SES. Furthermore, we will explore AWS IoT, examining its operations and features. Next, we will discuss Amazon Redshift and AWS Kinesis. Following this, we will advance to more in-depth topics such as containers on AWS, Dockers on AWS, Kubernetes on AWS, and a comparison of AWS versus Azure. As we conclude this course, we will provide insights into top 10 companies to work for as a cloud architect and provide essential AWS interview questions and answers to help you succeed in cloud-related interviews. But before we begin, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, visit the Edureka website for cloud training and certification courses, the link to which is in the description box below.
What is cloud computing? Everything nowadays is moved to the cloud, running on the cloud, accessed from the cloud, or maybe stored in the cloud. So what exactly is the cloud? Simply put, cloud computing, often referred to as the cloud, is a service that allows people to use online services that are generally available through any device with an internet connection. This means that the user does not need to be at a certain location in order to access certain data. From computing and analytics to secure and safe data storage and networking resources, everything can be delivered within no time thanks to the cloud. The goal of cloud computing is to deliver these services over the internet in order to offer faster innovation, flexible resources, and economies of scale. Have you ever realized that you probably have been using different cloud-based applications every day? Whenever you share an important file over OneDrive with your colleague through the web or use a mobile app, download a picture, binge watch a Netflix show, or play an online video game, it all happens on the go. The best part? It saves you a lot of money and time. You don't have to buy any machinery or install any kind of software. Everything will be handled by the cloud platform which is running these applications, whether it's Google, Microsoft, or Amazon. Many such tech giants have already switched from traditional computer hardware to more advanced cloud architecture. Not just that, these companies are also the most popular cloud service providers in the market today. As more and more companies undergo strategic digital transformations designed to utilize the power of the cloud, they need more IT professionals and leaders with the expertise to extract the best business results out of their investments.
So what exactly is AWS? Well, AWS is Amazon Web Services and it is one of the best cloud service providers in the market. So when I say cloud service provider, we need to understand what cloud is first. So let me throw some light on this topic. First, let me give you a scenario that existed before cloud came into existence. In order to host a website, I had to buy a stack of servers. and that was very costly. Second thing, upscaling and downscaling was a huge problem because I wasn't certain as in how much space I would be needing. And that meant wastage of resources or under or overutilization of resources. Thirdly, maintaining these servers was a huge pain. So these were all the problems that came into existence. Now cloud helped you solve all these problems. How? Well, what organizations did was some of them they went ahead and they bought some space online and they made arrangements for your databases, your services, compute services, and all those things. And businesses could go ahead and rent those services. That meant you could use or rent services which was needed, and you paid only for those services. You could easily upscale and downscale here. So all your issues were taken care of. And when you talk about cloud services, the first thing that should come to your mind is AWS. Why? Because it is the best in the market. Let's try to understand a little more about AWS. Well, it is a complete software suite or a cloud service provider which is highly secure. It provides you with various compute, storage, database, and n number of other services, which we would be discussing in further slides as well. And when you talk about the market, it is the best, and it has various reasons to be the best in the market. One being its flexibility, its scalability, and its pricing. Other reasons being its compute capacity. Now, why is it so important, the compute capacity? Well, if you talk about the compute capacity, you need to understand one thing. If you take all the other cloud service providers in the market and you combine their compute capacity, that is, you leave out AWS and you take all others into consideration, the space would be somewhere equal to say X. And if you compare it with AWS, it is 6X. So AWS has more compute capacity, which is 6 times more than all the other service providers that are there in the market. So that is a huge amount. So these are the reasons that make AWS one of the best in the market. And let's try to find out what are the other reasons about AWS that make it so good. What are the services, features, and its uses basically. So I would be discussing some use cases now. If you're talking about a manufacturing organization, now their main focus is to manufacture goods, but most of the businesses they focus so much on various other services or practices that need to be taken care of that they cannot focus on the manufacturing goal. Now this is where AWS steps in. It takes care of all the IT infrastructure and management. That means businesses are free to focus on manufacturing and they can actually go ahead and expand a lot. Architecture consulting. Now their main concern is prototyping and rendering. AWS takes care of both the issues. It lets you have automated or speed up rendering as far as prototyping is concerned. And that is why architectural business benefit a lot when you talk about using AWS or any cloud provider, but AWS being the best in the market, again, their services are the best. Media company. Now, as far as a media company goes, their main concern is generating content and the place to dump it or to store it. Again, AWS takes care of all these situations or both these situations. Large enterprises. When you talk about large enterprises, their reach is worldwide. So they have to reach their customers and their employees globally or across different places. So AWS gives you that option because it has a global architecture and your reach can be very wide as far as these points are concerned. Okay, if you talk about real life examples, to give you an example, we have Quora, which is an online answering platform if you all are aware about it, and that is like used all across the world. Amazon itself, we know that it is one of the biggest e-markets as far as shopping is concerned, and again it is taken care by Amazon Web Services. Other examples would be Netflix, which we all love. I'm sure that we all watch online series, and what better place to do it than we have our Netflix, right? Now, advantages of AWS. As I've mentioned, I won't say advantages exactly, I would say features as well. Flexibility. Now, as far as AWS is concerned, it is highly flexible. Now, there are various reasons to support it. And one of the major reasons is it's very cost effective. Let us try to understand these 2 points together rather. Now, when you talk about flexibility, the first concern you should have is you are dealing with big organizations. They have a lot of data that needs to be managed, deployed, and taken care of. Now, when you talk about a cloud provider, if it is flexible, all these things are taken care of. The second thing is it is highly cost effective. Now, when I say cost effective, AWS takes care of almost every aspect. If you're a beginner or a learner, they have something called as a free tier. That means you have sufficient resources to use for free, and that too for one long year. So you would have sufficient hands-on without paying anything. Plus, it has something called as pay-as-you-go model. Now, when I say pay-as-you-go model, what it does is it charges you only for the services which you're using and only for the time being you're using them. Again, that lets you scale up nicely, and hence you end up paying very less. Since you are paying very less, and since you have so many options when you are actually buying its services, what that does is that gives you a lot of flexibility. Scalability. Again, the first 2 points are related to this point. Now, how is that? Now, when I say scalability, what happens is, as I've mentioned, it is very affordable. So you're paying on hourly basis. If you're using a particular service for 1 hour, you'll be paying it only for 1 hour. That is how flexible it is. And what that does is that gives you a freedom to scale up and even scale down. Since it is easy to scale up, it is always advisable that you start with less and then scale as per your needs. Plus, there are quite a few services that are there which can be automatically scheduled. Now, what that means is you'd be using them only when there is an uptime, and in downtime, you can miss those get automatically shut down. So you do not have to worry about that as well. So when you talk about scalability, scaling up and down is very easy as far as AWS goes. Security. Again, now security has been a topic of debate when you talk about cloud services, especially. But AWS puts all those questions to rest. It has great security mechanism. Plus, it provides you with various compliance programs that again help you take care of security. And when you talk about real-time security, even that is taken care of. You can take care of all the suspicious activities that are there, and not you. AWS takes care of all those things, and you're let free to focus on your business rather. So these are the advantages which I feel that AWS adds value to. And apart from that, there are quite a few other points, like we have automated scheduling, which I just mentioned. You have various integrated APIs. Now these APIs, they're available in different programming languages, and that makes it architecturally very strong to switch from one programming language to another. So these are some of the features I feel that make AWS a wonderful, wonderful service provider in the market. So let's move further and try to understand other things as far as AWS is concerned. It's global architecture. When you talk about AWS, as I've mentioned, it is the best service provider in the market. So what makes AWS this popular? One of the reasons is its architecture. Now, when I talk about its architecture, it is very widely spread and it covers almost every area that needs to be covered. So let's try to understand how it works exactly. Well, if you talk about AWS architecture, now the architecture is divided into two major parts, that is regions and availability zones. Now, when you talk about the regions and availability zones, regions are nothing but different locations across the world where they have their various data centers put up. Now, as far as one region goes, it might have more than one data center. And these data centers are known as availability zone. You being a consumer or an individual, you can actually access these services by sitting anywhere in the world. To give you an example, if I'm sitting in some part of the world, say for example, I'm in Japan right now, I can actually have access to the services or data centers that are there in US right now. So that is how it works. You can choose your region and accordingly you can pick your availability zones and use those. So you do not have to worry about anything. To throw some more light on it, you can take a look at this small map, which is the global map, and it shows the different places which has its regions and availability zones. Now, as far as this map goes, I believe it's fairly old and it has been upgraded in recent times because AWS is putting in a lot of efforts to have more data centers or more availability zones as far as their wide reach is concerned. And we can expect some in China as well. So yes, they are actually reaching far and wide. So when you talk about these regions and availability zones, if you take a look at this map, what you can see is you have your region, which is in orange color, and the number that is inside it is the number of availability zones that there has to be. Now, to give you an example, we have Sao Paulo, which says that it has 3 availability zones. So that is how it is. And the ones that are in the green are the ones which are coming soon, or the regions that are in progress. And some of these have actually gone ahead and already started or have been made available to people. So yes, this is how the architecture works, and this is how the AWS architecture looks like. Okay, so let's move further and take a look at the next concept. Domains of AWS. Now, when you talk about its domains, the first domain that we are going to discuss is compute. And when you talk about compute, the first thing that should come to your mind is EC2. Now, when I say EC2, it is Elastic Cloud Compute. And what it does is it lets you have a resizable compute capacity. It's more of a raw server where you can host your websites, and it is a clean slate. Now, what do I mean by this? Say, for example, you go ahead and buy a laptop. It is a clean device where you can have your own OS. You can choose which OS you want and all those things. Accordingly, your EC2 is again a clean slate and you can do so many things with it. Now next you have Elastic Beanstalk, which lets you deploy your various applications on AWS, and the only thing you need to know about this thing is you do not have to worry about the underlying architecture. Now it is very similar to your EC2, and the only difference between the two is as far as your Elastic Beanstalk is concerned, you can think of it as something that has predefined libraries, whereas your EC2 is a clean slate. Now when I say predefined libraries, say for example you want to use Java. As far as EC2 goes, now this is just an example, don't take it literally. You'll have to say for example install everything from the beginning and start fresh. But as far as your Elastic Beanstalk is concerned, it has this predefined libraries and you can just go ahead and use those because there's an underlying architecture which is defined. Let me say it again. I just gave you an example. Don't take these sentences literally. So next we have migration. When you talk about migration, you need to understand one thing. AWS has a global architecture and there would be a requirement for migration. And what AWS does is it lets you have physical migration as well. That means you can physically move your data to the data center which you desire. Now, why do we need to do that? Say for example, I'm sending an email to somebody. I can do that through internet. But imagine if I have to give somebody a movie. So instead of sending it online, I can actually go ahead and give it to someone if that person is reachable for me. And that way it would be more better for me. My data remains secure and so many other things. So same is with data migration as well. And when you talk about AWS, it has something called as Snowball, which actually lets you move this data physically. Now it's a storage service and it actually helps you in migration a lot. Security and compliance. Now, when you talk about security, we have various services like I have IAM, we have KMS. Now, when I say IAM, it is nothing but your identification and authentication management tool. We have KMS, which lets you actually go ahead and create your own public and private keys, and that helps you keep your system secure. Now, there are quite a few other services as well, but I would be mentioning one or two services from each domain because as we move further in future sessions, we would be discussing each of these services in detail. And that is when I would be throwing a lot more light on these topics. For now, I would be giving you one or two examples, and because I want you all to understand these to some extent. Getting into details of all these things would be too heavy for you people because there are quite a few domains and quite a few services that we need to cover. And as we move further, definitely we would be covering all those services in detail. Then we have storage. Now, when I talk about storage, again, AWS has quite a few services to offer to you. We have something called as your S3. Now, S3, it works as a bucket object kind of a thing. Your storage place is called as a bucket and your object which you store in are nothing but your files. Now, these objects have to be stored in their root files, which act as the buckets basically. And then we have something called as your CloudFront, which is nothing but your content delivery network. We have something called as Glacier. Now, when you talk about Glacier, you can think of it as a place where you can store archives because it is highly affordable. Next, we have networking. Now, when you talk about networking, we have services like VPC, Direct Connect, Route 53, which is a DNS. Now, when I say VPC, it is a virtual network which actually lets you move or launch your resources. That is your AWS resources basically. When you talk about Direct Connect, you can think of it as a leased internet connection which can be used within AWS. Next on this list, we have something called as messaging. Yes, AWS assures secured messaging, and there are quite a few applications to take care of that as well. Now we have something called as CloudTrail, we have OpsWorks. All these things, they help you in messaging or communicating with other parties basically. Databases. Now storage and databases are similar, but you have to understand one difference. When you talk about your storage, that is where you store your executable files. So that is the difference between the two. And when you talk about databases, we have something called as your Aurora, which is something which is very SQL-like and it lets you perform various SQL options at a very faster rate. And what Amazon claims is it is 5 times faster than what SQL is. So yes, when you talk about Aurora, again, a great service to have. We also have something called as DynamoDB, which is a non-relational DBMS. And when you talk about non-relational DBMS, I won't be discussing that, but this helps you in dealing with various unstructured data sources as well. Next on this list, we have the last domain, that is the management tools. Now, when you talk about management tools, we have something called as CloudWatch, which is a monitoring tool. and it lets you set alarms and all those things. Hopefully today when we are done with the demo part, you'd be having at least one part of your CloudWatch covered, because we would be creating alarms using CloudWatch today. So stay tuned for that as well. So this was about AWS and its basics, as in the points which we just discussed. That is what it is, its uses, its advantages, its domain, its global architecture. So yes, guys, what I've done is I've gone ahead and I've switched into my AWS account. The first thing you need to understand is what AWS does is it offers you a free tier. Now, while I was talking about these things, I just rushed through it because I knew that I was going to give you a demo on these things. So, and I wanted to discuss this thing in detail. Now, when you talk about AWS, if you're a beginner, this is where you start. Now, what AWS does is it provides you with its free tier, which is accessible to you for 12 months. And there are quite a few services which we just discussed, which are available to you for free. And when I say free, there's certain limitations on it, as in these many hours is what you can use it for, and this is the amount of memory or storage you can use in total, and all those things, and its capacity and everything. Based on that, you have different instances which you can create and all those things. Now, what AWS does is it gives you these services for free, and as long as you stay in the limits that AWS has set, you won't be charged anything. And trust me, when it is for learning purposes, that is more than enough. And let's quickly go ahead and take a look at these services first, and then there are a few other points which I would like to discuss as well. But firstly, the free tier services. Now, see, this is what it has to offer to you. 12 months of free and always free products. When you talk about EC2, which is one of its most popular compute services, 750 hours, and that is per month. Next, you have Amazon Quick Site, which gives you 1 GB of spice capacity. Now, I won't get into the details of these things, as in what spice capacity is and all those things. When you have time, I would suggest that you go ahead and explore these things, as in what do these things do. Today, we are going to focus more on the EC2 part. So for now, let's quickly take a look at these one by one first. Amazon RDS, which gives you 750 hours of your T2 micro instance. Amazon S3, which is a storage, which again gives you 5 GB of standard storage, and AWS Lambda, 1 million free requests per month. So there are some of the videos here actually which would introduce you to these things that would help you get started with how to creating an account and all those things. And this is the other important point which I would like to mention. When you do create an AWS account, the first thing you need to consider is they'd be asking you for your credit card details. So how does the login process work? Firstly, you go there, you give in your email ID and your basic details, as in why do you want to use it and all those things. Next, what it would do is just to verify your account, it would ask you for your credit card details. Even the debit card details work. I've actually tried those. So you can go ahead and give your credit card or debit card details. And when you do that, what it does is it subtracts a very small amount from your account. I did this in India and I know that I was charged 2 rupees, which is fairly less. And that was again refunded back to me in 2 to 3 working days. The only reason they cut those 2 rupees was just for the verification purpose that my account is up and running and I am a legitimate user. Now, as long as you stay in the limits, you won't be charged anything. But if you do cross those limits, you'll be charged. Now, you might be worried, as in, what if I do cross the limit? Would I be charged? Yes, you would be. But the fact is, you actually won't go beyond it. And even if you do, you'll be notified saying that you are going about the limit or above the limit. Even when your free subscription ends, you're notified saying that, do you want to enter your billing details and do you want to start billing? And if you say yes, only then you'd be charged for the subsequent months. And that is a very stringent process. You don't have to worry about it. That is, you won't be losing out on any money as long as you follow these rules. So if you do not have an account, my suggestion would be you go ahead, you log into AWS and create your free tier account, which is a very easy and 2 to 3 step process.
Who is a cloud architect? A cloud architect is simply an IT specialist who develops a company's computing strategy. Now, this strategy incorporates cloud adoption plans, cloud application design, as well as cloud management and monitoring. Even when you build a house, you consider factors such as the layout, design, number of rooms, the budget, etc., right? So in short, cloud architects are professionals who are responsible for creating blueprints of application designs. Now, obviously, these professionals must possess some advanced technical skills and experience in designing applications and systems. Additional responsibilities include support for application architecture and deployment in cloud environments. Also, Fortune 500 companies like Netflix, Tinder, they work completely on cloud. So the cloud architect would be involved in deciding the kind of servers and databases they need, how agile they would be, etc. All of these factors are some responsibilities of a cloud architect. I hope who is a cloud architect very clear to you. They're simply professionals who are responsible for creating blueprints of application designs. Okay. Now, moving on, the next question that arises is how to become a cloud architect. While specifics will depend on the cloud in question, knowing popular languages like Python, Java, Perl, C Sharp will definitely cover your basis for cloud infrastructure and cloud native applications. It is also important to know Go, which is the language Docker and Kubernetes are written in. People who are good in operating system, especially Linux, is definitely an added advantage to them because most of the cloud servers support Linux based operating systems. It is also preferred primarily because it is an open source platform. Also, some of them skill themselves in cloud architecture right after they graduate from streams like computer science and engineering or electronics and communications engineering. And obviously, one of the main requirements would be someone from an IT background so they can work towards becoming a cloud engineer or a cloud architect. In fact, anyone with an engineering background can take the requisite training on one specialty and eventually master in it. Now, these are some of the factors and requirements that will help you become a cloud architect. Moving on, let's talk about why cloud is in great demand. So, there are many reasons to this, but I'll just discuss the main ones. The first one is storage and processing. There are various aspects that cloud computing brings along with it, and one of it is the storage and processing. You can have unlimited storage for data on cloud. Also, unlimited processing can be achieved on a cloud environment. This completely eliminates the disadvantages the traditional servers caused in the past. That is, they were very slow and they had limited resources, etc. The next reason why cloud is in such great demand is because of its low cost. Moving to cloud computing may reduce the cost of managing and maintaining your IT systems. Rather than purchasing expensive systems and equipment for your business, you can reduce your costs by using the resources of your cloud computing service provider. You may be able to reduce your operating costs because the cost of system upgrades, new hardware and software may be included in your contract. Also, you might no longer need to pay wages for expert staff. And also, your energy consumption costs may be reduced because there are fewer time delays. So, these are some reasons why your operating costs may reduce if you switch to cloud. The next reason is because of streamlined collaboration. So, cloud applications enhance collaboration by authorizing diverse groups of people virtually meet and exchange information with the help of shared storage. Such capability helps in improving the customer service and product development and also eventually reduce the marketing time. Collaboration in a cloud environment gives your business the ability to communicate and share more easily outside of the traditional methods. Now, if you're working on a project across different locations, you could simply use cloud computing to give employees, contractors, and other third parties access to the same files that you're working on, right? You could also choose a cloud computing model that makes it easy for you to share your records with your advisors. Example, a quick and secure way to share accounting records with your accountant or financial advisor. So this is another reason why cloud is in such a great demand. The next reason is control. You have complete control over sensitive data, which is vital to your company. You never know what can happen if a document gets into wrong hands, even if it's just the hands of an untrained employee. Cloud enables you complete visibility and control over your data. You can easily decide which users have what level of access to what data. This gives you control, but it also streamlines work since staff will easily know what documents are assigned to them. It will also increase and ease collaboration. Now, since one version of the document can be worked on by different people, there is no need to have copies of the same document in circulation. The other reason why cloud is in such a great demand is because of scalability and flexibility. I'm sure you must all agree that different companies have different IT needs. A large enterprise of more than 1,000 plus employees won't have the same IT requirements as a startup. Now, using cloud is a great solution because it enables enterprise to efficiently and quickly scale up or down their IT departments according to their business demands. Cloud-based solutions are ideal for businesses with growing or fluctuating bandwidth demands. Now, if your business demands increase, you can easily increase your cloud capacity without having to invest in physical infrastructure. This level of agility can give businesses using cloud computing a real advantage over competitors. The scalability minimizes the risks associated with in-house operational issues and maintenance. You have high performance resources at your disposal with professional solutions and zero upfront investment. Scalability is probably the greatest advantage of cloud. The last reason is because of its data integrity and security. Cloud computing offers great security when any sensitive data has been lost. As the data is stored in the system, it can be easily accessed even if something happens to your computer. You can even remotely wipe out data from the lost machines for avoiding it getting into the wrong hands. Now, one of the major concerns of every business, regardless of size and industry, is definitely the security of its data. Data breaches and other cybercrimes can devastate a company's revenue, customer loyalty, and brand positioning. Nowadays, cloud offers many advanced security features that guarantee that data is securely stored and handled. Cloud storage providers implement baseline protections for their platforms and the data they process, such as authentication, access control, and encryption. From there, most enterprises supplement these protections with added security measures of their own to bolster cloud data protection and eventually tighten access to sensitive information in the cloud. Now that we know why is cloud in such a great demand, let's move on to the next part of today's session and understand some of the cloud architect job trends. I hope the last three topics were clear to you guys. The first one was who is a cloud architect, and the next one was how to become a cloud architect. What are the requirements and the skills that you need to have to become one? So it's important to understand also why cloud is in such a great demand. Now, moving on, let us talk about the cloud architect job trend roles. Okay, now we all know that there is an exponential growth in the cloud computing industry. So it is no surprise that the demand for cloud computing, intellect, and skills is also increasing with no slowing down in the foreseeable future. According to Gartner, Talent Neuron, and online real-time labor market insight portal, there are about 50,000 cloud computing positions available in the United States from 3,700 employers and 1 lakh, more than 1 lakh positions open worldwide. So that's a lot of job roles that are available in the United States, right? Also, 86% of enterprises now have more than a quarter of their IT infrastructure running in cloud environments. That is, a full 7% of IT infrastructure is completely involved in cloud now. Rapid adoption also means that companies need employees and candidates with the right skill set in order to drive the future of multi-cloud services and infrastructure. Also, it is said that the worldwide public cloud services market will hit about $331.2 billion by 2022. And also, 26% of enterprises spend more than $6 million a year on public cloud, while 52% spend more than $1.2 million annually. That's a great amount, right? Now, by the stats that I just mentioned, we obviously clearly know that cloud is in such a great demand. There's so much of opportunity available in the field of cloud computing. Moving on, let's talk about the skills required by cloud architect. Firstly, I'll be talking about the technical skills, and then we'll move on and talk about the non-technical skills. Now, did you know that as an interconnected world, we create 2.5 quintillion bytes of data every single day? So companies are obviously very eager to draw insights from this information, fueling the demand for professionals with the skills to manage, store, and access data. Now, as these databases are mostly hosted on cloud platforms, this is definitely the perfect time to invest in learning a database querying language and an associated database platform. The de facto standard database language to learn is structured query language. If you also want to develop your skills a little more, you could definitely consider learning MySQL or Hadoop. Now, the developers have the ability to build, deploy, and manage applications quickly, which scale to unlock the full capabilities of the cloud. In the last couple of years, we have seen programming languages like Python, Perl, and Ruby rise to prominence in the cloud ecosystem. Traditional languages like PHP, Java, and .NET continue to be popular, but definitely Python is a great starting point if you're looking to build your cloud programming skills, because it is a high-level language and it is definitely easy to learn. It also lets you create, analyze, and organize large chunks of data with complete ease. Also, XML with Java programming will help you with data description. On the other hand, .NET is a must-have framework, especially for Azure developers. Now, the demand for cloud professionals with skills in Linux are extremely high right now. There are more than 25% of servers that power Azure, which are Linux-based, and this percentage is only set to grow since Microsoft will obviously continue to embrace the open source market. Businesses are on the hunt for professionals with skills to architect, design, build, administrate, and maintain Linux servers in a cloud environment. This is exactly why a good hands-on knowledge on operating systems like Linux could really help in this field. Security is becoming more of an essential cloud architect skill than ever. While more organizations are now hiring a separate cloud security architect, having a background in security contributes to end-to-end cloud security. Identity and access management is also extremely essential. More employees are accessing the cloud directly, as well as knowledge of privacy laws and regulations. Cloud security involves maintaining adequate preventive measures like knowing that the data and systems are safe, tracking current state of security, tracing and responding to unexpected events. The 𝐶omt Security Plus or CISSP are few of the certifications in the cloud computing world. So this credential is given by the IISSCC Incorporation, and the exam covers knowledge in areas like identity and access management, asset security, software development security, etc. Edureka are official partners with 𝐶omt Security Plus and offer you a chance to earn a global certification that focuses on core cybersecurity skills. Moving on, networking is another important skill required by cloud architects. Cloud architects tend to have previous experience as network administrators. Dan Kohn, Executive Director of the Cloud Native Computing Foundation, says that the most typical background is someone who's familiar with system administration, who knows how to provision individual servers, and then moves up and begins thinking in terms of fleets of servers instead. Knowledge of deploying and operating different network types, as well as working with software-defined networks in general, is a must. So cloud architects basically design ways to make sure the network is responsive to user demands by building automatic adjustment procedures, and hence the understanding of networking fundamentals and virtual networks. The next skill is understanding how data storage works. This includes knowledge of infrastructure and hardware, storage buckets, provisioning, and capacity planning, data security, etc. Now, I will discuss some of the benefits of cloud storage. The first benefit is usability and accessibility. Most of all the cloud services come with an easy-to-use user interface and provide a feature of drag and drop. For example, you can think of Google Drive from Google or iDrive from Apple. They both have a very simple interface, and you can easily upload your file on your online drive without any expert knowledge. Also, if you have a saved file in Drive using a mobile device, you can simply retrieve that file using a computer or any other device with internet connectivity. It does not matter where you are right now. If you have a good internet connection, you can access your files which is saved online somewhere on the data centers. The next benefit is security. If anything is associated with the internet, then safety definitely becomes our primary concern. And mostly the big and small businesses use cloud storage services. So before they choose a cloud service for the business, it is really important for them to pick one with a good security system. The cloud storage saves your data across the redundant servers, so even if one of your data centers gets collapsed, your data will be managed by the other data centers, which make your data safe and supervised. Nowadays, all the data that you have on cloud always have a backup, so you cannot lose anything even by mistake. So many of the cloud storage vendors keep the copies of your data at different data centers. In case if it's corrupted or lost, there is always a backup. The next advantage or benefit is it is cost efficient. By only using the cloud storage service, the business outsources the storage problem. By using online data storage, the enterprise reduces the expenses of internal resources. Now, with this technology, the company itself does not need any inner power and support to manage and store their data. The cloud storage vendor handles it all. There are also some cloud storage services which provide a lifetime access for an affordable price, which is a completely win-win situation for small businesses and individual users. The next benefit is convenience. Every cloud storage service provides the file sharing features, which helps you to share your file with other users. You can either send a file to another user or invite multiple users to view your data. Mostly all the vendors provide a cloud environment in which two users using the same cloud service can share their data, though there are only a few service vendors that offer the cross-platform file sharing features. Another advantage is automation. Cloud storage works like a hard disk on your system, and if you want to store any file in the cloud, it will not temper any ongoing task. There may be more than one user using a cloud storage service, and the current responsibility of one user will not affect the task of another, since it is all managed and automated by the cloud vendor. The next important reason is synchronization. Every storage vendor gives the sync feature. Now, with synchronization, you can simply sync the cloud storage data with any device you want. As we have already discussed before, we can access our data from any device and any part of the world, but this accessibility is done with the help of synchronization. With proper credentials, you can simply log on to your subscribed storage service with any device, and you will be immediately able to access all your data that you've been storing in your cloud storage. There is no need to copy data from one device to another. All you need is good internet connection to have access to all of your files. The last benefit is it is disaster recovery. Every business has a backup storage plan where they store all the copies of the data. If they encounter any collapse or loss of data problem, they can retrieve data from their backup plan, and that is why cloud storage is the best method to deal with this problem. Cloud storage service provides the best platform for disaster recovery data. Any business can use cloud storage as a data backup storage, so if there is any data loss, the company can simply retrieve backup data from the cloud. I hope the benefits of cloud storage is extremely clear. Can I get a yes from you all if you understood the benefits of cloud storage? Okay, great. That's two yeses. Okay, great. Let's move on and talk about the different types of cloud storage. This is extremely important too and easy to understand. So let's quickly brief up and understand what the different types of cloud storage are. The first one is a personal cloud storage. This is a local network attached storage device that lets users store data, photos, music, videos, and other files, and eventually is optimized for media streaming. So this kind of storage are a way for home users to experience the advantages of high capacity cloud-based storage without losing control of the data. Users can access content on their personal cloud storage device from multiple computers using a web browser, while mobile applications provide access from iOS and Android devices. Files can be shared without using a public cloud service. They have a separate CPU, memory, and operating system, and they can use all of this with the help of an Ethernet cord to plug into a Wi-Fi router. The most basic ones are priced around $150. Okay. Now let us understand the second type of cloud storage, that is public cloud storage. You have likely heard about Amazon Web Services, IBM Cloud, Google Cloud, Microsoft Azure. These are all examples of public cloud providers. Practically, these providers own and manage all the cloud architecture, that are hardware, software, and other infrastructure, and deliver it as a cloud service over the internet. As an analogy, using the cloud is like living in a large apartment complex. The provider is the landlord, and you and any other businesses or people using their services are the tenants. Here, shared resources enable the provider to offer lower prices. You benefit from sharing the resources of other businesses, since regulation, compliance, and infrastructure investments are likely a better quality than the typical SMB. The public cloud has several advantages. That is, they're highly scalable, they're cost effective, highly reliable, hardly any maintenance, etc. Moving on to the next type of cloud storage, that is the private cloud storage. Unlike the public cloud, the private cloud is used by only one organization. Larger enterprises with mission critical data requiring additional security are more likely to use a private cloud solution. The private cloud infrastructure can reside either on premise or within a third party vendor. Regardless, the hardware and services are dedicated. The private cloud offers numerous advantages that are similar to the public cloud storage. That is, they're highly scalable, highly efficient, they have a better security, and they're also customizable. The last type of cloud storage is the hybrid cloud storage. Like the name suggests, a hybrid cloud converges the public and private cloud solutions into a unique type of cloud storage that offers the advantages of both. Data and applications can move between public and private clouds as needed, offering increased flexibility. Most businesses can use the public cloud for certain aspects of their work, such as webmail, but might need a private cloud for storing secure data logs. A hybrid cloud solution combines both these public and private clouds to create a very unique solution. They offer many advantages, like they have greater control, they're customizable, they're cost effective, etc. Moving on, let us talk about the different cloud service providers that are available in the market today. Amazon Web Services is a cloud computing platform which provides services such as compute power, database storage, content delivery, and many other functions which will help to integrate a business. The next one is Microsoft Azure, which is also a cloud computing service which is used for building, testing, deploying, and managing an application. Google Cloud Platform, on the other hand, is one of the leading cloud computing services which is offered by Google, and it runs on the same infrastructure that Google uses for its end user products. The Google Cloud Platform is basically used for Google Search and YouTube. So the cloud service providers like AWS, Azure, and GCP offer end-to-end services like computation, storage, databases, machine learning, migration, etc. There are several services that they provide. With all of this said, let us finally address the non-technical skills that are required by cloud architects. The first one is flexibility. The cloud will continue to change, as will the skill sets needed to work with it. Staying flexible to new technologies and having the aptitude to pick them up quickly is extremely essential. The next skill required is leadership. Cloud architects are often expected to lead a team. Being able to manage multiple people, handle ideas diplomatically, delegate, and solve problems as a group is extremely essential. Candidates should cultivate leadership skills often and very early. The next skill is business acumen. Businesses is becoming a huge part in how organizations are selecting and shaping the clouds. Being a cloud architect is no longer about just administrating to the cloud. It is also about helping a company in that shaping. The last and the most important skill that is required is communication. There are many stakeholders and participants along the cloud journey, from those who pay the bill to the security team, to the technical team, to those helping to make decisions about cloud vendors. So cloud architects are encouraged to ask for a seat at the decision-making table and be prepared to communicate the design to any stakeholder. Successful cloud architects know how to communicate to audiences with little or no technical knowledge, while aligning the recommendations to business imperatives and the bottom line. Now, let's move on to the next part of the session, that is the roles and responsibilities of cloud architect. Guys, if you have any queries, please feel free to ask them along the way. I'll be more than happy to address them. Do you have any? Okay, great. Okay, let's move on. So let's discuss some of the roles and responsibilities of a cloud architect. Now, he or she must be capable of designing and deploying dynamically scalable, available, fault-tolerant, and reliable applications on the cloud. That is, they must be able to plan, design, and assist with all cloud environments. They must also understand the concepts and provide expertise on infrastructure and build and release to development teams. The cloud architect also drives the introduction of cloud infrastructure with the company's computing environment. It is the technician's responsibility to support the change and work towards the adoption and ease of use of the cloud technologies. The professional here develops new usage patterns and should also play an active role in the everyday use of cloud services. They ensure that the services keep running 24/7 and address cloud contracts in several ways. The next role is to migrate complex multi-tier applications on cloud platforms. They should be able to handle the smooth delivery of applications on different cloud platforms. The cloud architect will also provide all the necessary and assistance where the cloud services fit in best. This professionally basically puts in place a process to build and assess which applications will access cloud computing. They should also identify any comprehensive risks and come up with a risk mitigation mapping matrix to avoid them. It is also the responsibility to work in coordination with the IT security and risk departments. The architect develops a methodology to automate cloud services and must always make sure that any error will not impact the speed and agility of cloud benefits. And the last role and responsibility of cloud architect would be to implement cost control strategies to ensure maximum cost optimization. So he or she must be able to implement the costs in such a way that they can utilize maximum of their cost and eventually make profits for the business organization. Moving on, let's talk about a cloud architect's salary. That is the salary figures of a cloud architect in two different countries, that is India and the United States. So as you can see that in India, it is rupees 15 lakhs 31,634 rupees per annum. And as you can see in United States of America, it is 154,428 US dollars. That's a lot, right? So this is the average salary in both of these countries. Let's move on and talk about the last part of today's session, that is the cloud architect certification. Now, over the years in the IT sector, understanding of cloud has become a crucial part. Becoming a cloud certified professional will give your career an edge for sure. These certifications validate your cloud skills, knowledge, and expertise to the organizations. So here are some cloud certifications from different vendors that you can opt for. The first one is Microsoft Certified Solutions Expert, Cloud Platform and Infrastructure. The second one is Amazon Web Services Certified Solutions Architect. The third one is IBM Certified Cloud Solution Architect V2. The fourth one is Oracle Cloud Infrastructure Architect Associate Certification. And the last one is Edureka's Cloud Master Program. So Edureka's Cloud Masters program makes you proficient in designing, planning, and scaling cloud implementation. It includes training in Python, cloud computing, AWS architectural principles, migrating applications in cloud and DevOps. The curriculum has been determined by extensive research on more than 5,000 job descriptions across the globe. At the end of this program, you will have a thorough understanding of different cloud services, AWS Architect, Docker, Jenkins, Ansible, and many more. Being a cloud professional requires you to be a master of a multitude of skills, and this program aims at providing you an in-depth knowledge of the entire cloud computation system. As you can see on the screen, individual courses focus on specialization in one or two more specific skills. However, if you intend to become a master in cloud computation, then this is definitely the path for you to follow.
So first and foremost, guys, we would be talking about an instance. So when you talk about an instance, we have this definition here. Let's try and understand what does this definition has to say first, and then probably I would throw in some light on that. So as far as this definition goes, it says an instance is nothing but a virtual server for running applications on Amazon EC2. It can also be understood like a tiny part of a larger computer, a tiny part which has its own hardware, network connection, operating system, etc. But it is actually virtual in nature. So there are a lot of words here and a lot of stuff has been said. Let me try and simplify this particular definition for you people. So guys, when I say a virtual server running on your application, not on your application, a virtual server that basically hosts your application is what I should say. So what do I mean by this? What do I mean by a virtual instance, a virtual presence of a particular device? Well, guys, when you talk about software development, application development, what you do is you're supposed to build in applications and run those on servers, right? But at times there are a lot of constraints like the space that you use, the resources that you want to use. Say, for example, certain applications run on Windows, certain run on Mac OS, and certain run on your Ubuntu OS, right? So in that case, I cannot always go ahead and have different systems, run different operating systems on them.
and then run my applications on top of that, right? Because it is time consuming, exhaustive, and also consumes a lot of money that you invest into it. So what is the solution for that? What if I could have a single device, and on top of which I could create virtual compartments in which I could store my data differently, store my applications, run my applications differently? Wouldn't that be nice? Well, when you talk about an instance, that is what it exactly does. You can think of it as a tiny part of a computer. Well, that is what it is trying to symbolize. I mean, you have a system on top of which you can run different applications. And how it works is, if you are running an application A in part 1 and running an application B in part B of your server, these applications have a feeling that they are running individually on that system and there is no other system running on top of it. So this is what virtualization is. It creates a virtual environment for your application to run. And one such instance of this virtual environment is called as an instance. So when you talk about virtualization, it is not something that is very complicated. As you can see in the first image, you can see a man surrounded by various virtual images, something that you see in an Iron Man movie. When you talk about virtualization, it is very simple. It can be a simple computer which is shared by different people, and those people are working quite independently on that server. That is what virtualization is. That is what an instance is. In this image, the second image, each one of this individual would be using a different instance. So this is what an instance is when you talk about virtualization. So guys, let us move further and take a look at some other pointers now. We've understood what an instance is, what virtualization is, to some extent at least, guys. As far as this session goes, I believe this information is enough. If you wish to know more about virtualization, you can visit our YouTube channel and take a look at VMware tutorial. It talks about this particular topic in a lot more detail. So guys, let us move further and try to understand EC2 now. Now, EC2 is an Amazon Web Services compute service. It stands for Elastic Compute Cloud. Now, what do I mean by this? When you say an elastic cloud compute, that means basically it is a service which lets you actually go ahead and carry out computation practice. And when I say elastic, it means that it is fairly resizable and fairly reusable. Once we get into the demo part, probably you'd get a better picture. What do I mean by elasticity? Because it is highly flexible, highly scalable, it is very cost efficient, and it serves a lot of purposes. Now, these are some of the features that I just mentioned, right? Let me throw in some more light on these pointers as well. What do I mean by scalable? Now, when you talk about a cloud platform, one of its best features is it gives you high amount of scalability. That means your applications can scale up and down depending upon the data that you want to use on top of it. So if the traffic increases more, you need more performance. So your application should be able to scale to those needs, right? So that is what cloud computing provides you with. And that is what EC2 also provides you with. When I say an instance, basically what you're doing is you're launching a virtual machine. It is called as instance in terms of AWS. So this virtual machine should be scalable. That means it should scale up and scale down, both in terms of memory, storage, and even in terms of the computation that it is providing. So when you talk about EC2, it is highly scalable. Once we get into the demo part, you would see this. Now, it being scalable and it being cost efficient makes it highly flexible. So that is the third point. Let us try and understand the second point as well. What makes EC2 cost efficient? Now, when you talk about cost optimization, what EC2 does is it lets you scale up and down. I just mentioned that, right? So instead of buying n number of instances, or instead of buying n number of services, you can actually go ahead and scale this instance up and down with minimal cost changes. So you're saving money. Plus, apart from that, there are burstable instances. There are various pricing models that EC2 boasts of, using which you can actually save a lot of money. As we move further, we'll be talking about those models as well. So meanwhile, just bear with me. So EC2, well, it is a service which is a computation service, and it takes care of following pointers. I mean, it is easily resizable, it is cost efficient, it is highly scalable, and all these features make it highly flexible as well. So guys, let us move further and take a look at some other pointers as well. So what are the types of instances? Now, when you talk about EC2, it is one of the oldest AWS services. So if you talk about the type of instances that are there in the market, well, there are quite a few types of instances that you can deal with. And these are some of the popular ones. Again, once I move into the demo part, I would maybe talk about other instances, but to keep it simple, basically these instances, they have different families. I mean, you have the T series, you have the M series, the C series. Well, basically these series consist of different kind of instances that serve different purposes. To simplify this process, what AWS has done is it has gone ahead and categorized these instances into following types. The first one is your general purpose instance. Now, it is basically suited for applications that require a balance of performance and cost. That means places where you require quick responses, but it is still cost effective. I mean, say for example, the example shown here, email response systems. Now, you require a quick response and there will be n number of responses or n number of emails that would pop in, but you do not want to pay a lot of money for this kind of service. So in this case, you need cost optimization as well, and you need a quick response as well. So this is where your general purpose instances come into picture. Next on this list, you have your compute instance. Now, what are compute instances? These are for applications that require a lot of processing. Now, when you say computation, they have better computation power. That means if there is a lot of data that need quicker computation power, you can use these kind of instances. What is an example? You have your analyzing streaming data. Now, if you know what streaming data is, it is the data that continuously flows in and flows out. That means you are streaming that data. Say, for example, this session, it is being streamed, right? I mean, the information or whatever is happening here, it is going live. So in order to process this kind of data, you need systems that give you good computation power, which are very active and very good in nature. So when you talk about compute instances, they provide you with these kind of services. And that is why if you are dealing with streaming data, if you wish to analyze this kind of data, you can definitely go for compute instances. So next on this list, we have memory instances. Now, what are these instances for? Now, these are the instances that are required for applications that require more memory, or in better terms, more RAM, right? Random access memory. So these are for applications that require good computation power, again, like the previous one. But when you talk about RAM, it is something that resides in your local system, right? So you need instances which have good memory capacity. And what kind of application it serves? Well, you can think of applications that need multitasking, multiprocessing. Say, for example, I need a single system that does fetching data for me as well, process it for me as well, dashboard it for me as well, and then gives it to the end customer as well. So these kind of applications require memory instances. Moving further, guys, we have the storage instances. As the name suggests, these applications are, or these instances are for applications that require you to store huge amount of data. Say, for example, you have large size applications like your big data applications, where the amount of data is huge in number. So you'd be requiring more storage flexibility. In that case, you can opt for instances that are specifically optimized for storage kind of requirements. And then you have your GPU instances. If you know what GPU is, you would understand what it serves. That means if you are interested in graphical kind of work where you have basically heavy graphics rendering, in that case, you can opt for GPU kind of instances, which basically help you serve purposes like 3D modeling and stuff like that. So guys, this was about the different kind of instances. Now let us try and understand what are the different instance pricing models that are out there. So guys, when you talk about pricing, EC2 or AWS in general, it ensures that you can save a lot of money. But normally what people do is they are under the imagination that if you just go ahead and take in cloud, probably you'd go ahead and save a lot of money. Yes, cloud does support applications in such a way that you would spend very less amount, but it involves a lot of planning, guys. So each time you use a particular service, it is very important you understand how does that particular service work. And if you actually plan in the services in that manner, you'd actually end up saving a lot of money. So guys, let us try and understand how the pricing models work when you talk about EC2 in particular. So guys, these are some of the pricing models that EC2 has to offer to you. You have your on-demand, dedicated, on the spot, and reserved instances. Now, let me try and simplify what these instances are and what do I mean by these. Now, when you say an on-demand instance, as the name suggests, it is an instance that you demand and you get it. Now these instances are made available to you for a limited time frame. Say for example, I need a particular instance for an hourly basis. So I would be wanting to use that instance for only that duration. So to use that instance for that particular duration, what I do is I actually go ahead and demand this instance. So AWS would give me that instance, but it would work for an hour only. So my prices for that instance would be fixed on that manner. I mean, the fact that I would be using it for one instance or for an 1 hour basically. So I would be charged only for that 1 hour. And once that hour is complete, that instance, it gets terminated on its own. It's similar to renting a flat for 1 month. Suppose if I move to a new city and I'm looking something temporary. Say for example, I'm looking for a hostel or a paying guest kind of a living system, right? So in that case, what I would do is I would upfront go and tell the owner that I would be staying here for a month. You can charge me for a month only. If it is 1,000 more than normal charge, it is fine. But once the month is over, I would like to leave, right? So that kind of service or that kind of instance demand is called as on-demand instances basically. Dedicated, now guys, these instances are kind of given to a particular organization so that their security is defined better than other. Say for example, if I need to protect my data, I need my data to be privatized. Now understand this thing, AWS or the other cloud platforms are highly secure. Your data is secure no matter whether they are on dedicated instance or not. But what happens is you normally share your space with someone else, data remains private. But there are companies that deal with highly confidential data, and in that case they want that extra assurance as in, okay, I am using a space which is not shared by anyone. So in that case, you have dedicated instances which basically serve your needs like high security and basically an isolation from the other vendors as well. So that is what dedicated instances do. They are costlier, but yeah, they give you that isolation on spot. Now guys, when I say an on-spot instance, it is like bidding. Say for example, I am buying a particular share. So I have a particular budget, right? So I might have a budget of $300. So what I do is I go ahead and buy that share and I set in a cap as in, okay, to the max I can bid for $300 for this share. So if the price goes above $300, I'm not taking that share, right? So if there is a particular instance, you can bid for that instance as in, okay, this is the maximum price that I pay for this instance. So if that instance is available at that price, it is given to you. And if after a particular duration, the price of this instance can change, so it is available to you for a limited period of time. So if you are dealing with data that is volatile and you want to work on that data in real time, so you can opt for this instance, because after a while the price of this instance might change and this instance might be terminated and you might not be able to use it for a longer while. But the thing it does is it is available to you at a cheaper price and at a pricing bid that you put on it. So that is why it is more affordable. But again, it is good for volatile data only. Finally, you have the reserved instance. It is like renting an apartment on a lease for a longer period, right? I mean, suppose if I'm getting a flat on an agreemental basis where I sign an agreement for a year, that means I am reserving this flat for one complete year, right? So nobody else can come and say that, okay, you have to vacate this flat, right? So that is one benefit. And the other thing is you have a fixed set of rent. So if you're taking something for a longer duration, there's a chance that you might end up paying lesser money for that as well. Now, what happens here is when you talk about it from the instance perspective, suppose you know that you would be needing this much configuration for this duration, you can rent that particular instance for that duration and probably you end up saving a lot of money. Now, when you talk about AWS, it gives you flexibility where you can actually go ahead and upscale, downscale your instances to your needs. You can kind of terminate stuff and move to the next stuff. But if you are certain about certain things, as in, okay, I have to use this no matter what happens for a longer duration, in that case, you can opt for reserved kind of instances, and those are more affordable to you. So guys, these were different types of instances based on the pricing that is there. Now we've talked about general clusterization of instances like the general purpose, the GPU, that was based on their functioning, right? Then we learned about their pricing models as well. Now there is one more type that we need to understand, or one more classification that we need to understand. Let us try and take a look at those as well. So we are classifying instances based on their general functioning. Now what do I mean by this? Well, these are the types. Let us take a look at those one by one first. So when I say burstable instance, we've talked about general purpose instances, right? So what happens is there is a category of general purpose instances which start with a base utilization power available to you. That means if you want to utilize your CPU for a certain amount, burstable instances are good here. Let me throw in some more light as in what am I talking about exactly. Suppose I need a CPU utilization of 20% and I know that. So I can go for burstable instances. What they do is they start with a functioning of 20%. But in case if I'm dealing with data that is not constant, that might change with time. Say for example, if my website experiences more traffic, so I might need more performance, right? So in that case, what burstable instances do is they burst out of their current performance to 100% CPU utilization so that you can get more performance. Now, what happens here is you are charged a particular amount for these instances, and you have certain credits for which you can use the burstable performance. Now, if you do not use the burstable performance, those credits can be used later as well. So you are getting optimized performance as well, and you are saving some money as well in case if there is an urgent traffic that you experience. You have something called as EBS optimized. Now, when you talk about EBS optimized, now these are the applications where basically you are processing data at a higher speed. Say, for example, there is some application where the data is flowing in continuously. So I need quick response, right? So EBS backed up or EBS optimized instances, what they do is they give you high input output processing. And that is why these are good instances to opt for these situations. Cluster networking, basically they form clusters of instances. Now a particular cluster, what it does is it serves one kind of purpose. Say for example, in my application, what I want is I have different sections, and in different sections my first section requires to be processing data at a faster rate. The other one I want it to be storage optimized, so I can define different clusters of instances that serve different purposes here. And then I have the dedicated one. We've already talked about dedicated one. It is more related to the data security part. So guys, these were the different types of instances. I know I've talked about a lot of stuff. Once we get into the demo part, probably this would ease up a little more for you people. I believe you people are with me and you are following this session. So guys, now let us move further and take a look at the use case so that we can just move further and take a look at the demo part as well. For this use case, I've considered Edureka itself. Let us try and understand what could be the possible problems that can be solved by using these instances. Now, imagine that if Edureka used AWS as their cloud partner and they used the EC2 service. So what kind of problems could be solved by these instances that we just talked about? Suppose we have the first problem where you have to analyze the data of the customer. So what kind of application would you use? Can you guess that for me? I won't be looking at your answers. Let me just quickly go ahead and give you other examples as well so that we can discuss these one by one. Suppose you also have an auto response email system. Now compare these two and let me know which one would you believe would be served better by these instances that we've just talked about. So when you talk about the performance here, guys, when you talk about analysis of data, for the customer's data, it is never constant, right? At times the data is huge, at times it is less. So in this case, I would need burstable performance. So my general purpose burstable performance instances would serve me better, right? Auto response email system, I need quick response, but I do not want to invest a lot of money. EBS optimized instances with IOPS would help me better. Search engine and browsing, I believe it is fairly clear. I'm talking about browsing and search engine, two different things I want to do. I would be opting for clustered network instances, right? And confidential data, well, I would be opting for the dedicated instances here. So guys, this was a very simple use case. So let us move into the demo part and try and understand EC2 a little more, shall we? So guys, what I've done is I've gone ahead and I've signed into my AWS management console. Please forgive me guys, I have a lot of cold today and that is why my voice is little jiggly and echoing. So I hope you people are not offended by that. Moving further guys, this is the AWS management console. You can sign into AWS free tier account and probably avail these services. You can practice a lot of stuff by signing into your free tier account. How do you do that? Just go ahead and look for AWS free tier and sign in with your credit card or debit card. You won't be charged. You have these services for free for 1 complete year, and you can practice most of the services that are there. There is some free tier limit on these services, so check the upper cap as in what those limits are so that you don't get charged. So guys, this is how the console looks like. We are going to go ahead and learn about EC2 here, that is the instance service in AWS. So let's search for EC2 and you would be redirected to this page, guys. Now when you talk about EC2, there are a lot of things that you can do. You have Amazon Marketplace where you have AMIs. I will tell you what AMIs are, do not worry. You can just go ahead and launch your instances. You can attach volume to it. You can detach volume storage from these instances. And when I say AMIs, those are Amazon machine images. That means once you create an instance, you can create an image of that instance as well. That means a template of that instance as well. Suppose you have certain applications running on top of that instance, certain specific settings that you've done for those instance, and you do not want to do those settings again and again, you can create images of that instances as well. So let us see what all we can do with these instances. So let us first launch an instance. So guys, once you click on that launch instance button, you would be given n number of options to choose from. You can launch Linux instances, Ubuntu instances, Windows instances, and you can choose the EBS backed up, non-EBS backed up. So there are a lot of choices when you actually go ahead and launch these instances. You can see there's Ubuntu, Red Hat, Microsoft Windows, and there are specific instances specialized in deep learning, some of our server specification. You can see that there are quite a few instances, but ensure that if you are practicing, choose the free tier eligible one. For now, I'm going to go ahead and launch a simple Windows instance. Let's not get into the Ubuntu one because it requires a partition to sign in for that. So let us not do that. So guys, once you click on launch an instance, you can see that you are redirected to this page. Now, if you take a look at the information here, it talks a lot. Now, this instance is general purpose. We've discussed the other families, right? This is one. This one is T2 micro. There are T2, T3 micro and medium and bigger instances as well. The sizes vary, guys. The T2 micro one is free tier eligible. You have T2 nano, you have small, right? So you have medium and other large instances as well. So when you say a micro one, it has 1 vCPU and 1 GB of memory. Instance storage, it is EBS backed up. And what kind of network performance it gives you? Low to moderate. So I would say configure further. These are some configuration details, what network it is following, what subnet ID it is following. That means it falls under the cloud network, guys. That means your cloud would have a network, and under that network lies your instance so that its access policies, security policies can be managed. So let it be basic for now. Let us move further. Storage. Now guys, this is the storage. It is your root storage and 30 GB of space. You can change it if you want, say 100, but let us stick to 30 for now. And guys, you can see these are the types. You have your general purpose, you have your provisioned, magnetic. Now there is one more type of instance, guys, that is HDD kind of an instance. But guys, when you talk about root storage, you cannot attach HDD to it, right? Because root storage is something that is constant. If you wish to have HDD kind of storage, it has to be attached secondary. So if I add new volume here, you can see, and if I search for this, now it gives me an option of cold HDD, right? So that is what, guys, I mean, in order to have this kind of HDD kind of a volume, you need to use secondary storage for it. So let us cancel this for now and just go ahead and say next. You can add in tags, guys, for the simplicity of namesake. Say for example, sample today, and let's just say next. Security group, guys. Security group, what do I mean by this? Well, basically you have a set of policies, as in who gets to access, what kind of traffic do you want to your instance, what kind of traffic do you want to flow out of your instance. So you can create a security group and you can use customized as well. When you create one, this type is RDP. That means it can allow traffic from a desktop or a remote desktop app, and through which I can log into my system. I can add other rules as well. I can add TCP, HTTP kind of rules, and these are the port ranges. You can specify those. For now, I'm allowing traffic from everywhere through RDP, and I can say review and launch. Improve your security, it says, but this is a basic one, guys. You can add in more rules, as I've already mentioned. So let's not do that. Let's say launch. Generate a key pair. Now, a key pair is something that lets you log into your instance. It is a double security for your instance. You do not want your instance to be left insecure, right? So in that case, you need to generate a key pair. You can use an existing one, or you can create a new one as well. So let's just say that I want to create a new key pair. So I say create, and let us say Vishal 34121, and let's just say download. So guys, once you download this instance, what you do is Control X, cut it from here, and I'm gonna go ahead and paste this instance to the desktop, guys. And let's just say paste. Here it is. So the reason I'm doing this is because basically we would be needing this thing, guys. If you lose this key, there is no other way to access your instance. So make sure you keep it safe. And I say launch. So guys, now this process, it takes a minute or two to go ahead and launch your instance. So meanwhile, you'd have to bear with me. So what happens is, once you do actually go ahead and launch this instance, it involves a couple of steps, like basically it does some security checks, some status checks. And while these status checks happen, it takes a minute or two. And once the instance is up and ready, we can actually go ahead and take a look at this instance. So meanwhile, guys, what I'm going to do is I'm going to go ahead and take you to the EC2 part. Now there are 3 instances that are running, guys. Now this is somebody else's account, so there are quite a few other instances that are running. You can see that there must be some instance here which basically is initializing. So this is the one that we are going to use. This is the ID. Let's not remember that. We know that this is getting initialized. So guys, these are the other instances. This one is stopped. Let us take a look at this instance as well to understand as in what happens. So guys, these are the options that I have, right? So you can actually go ahead and get the password. You can create a template for your instance. What you can also do is you can start, stop. Now this instance is already stopped, so you do not have these options, that is stop, hibernate, and reboot. You can start this instance and probably you can go ahead and do that. Now when you stop an instance, if you want to actually make snapshots, you want to take snapshots, you want to create Amazon machine images out of it, what you do is you stop that instance so that you prevent any activity from happening on that instance, so that you can take an exact snap of it. So that is why you stop an instance when you wish to do these kind of operations. Once you start it again, you can make it function normally at it was functioning. If you are done using an instance, you can terminate it there and there, guys. So these are the options. Instance setting. Okay, so guys, these are the options. You can add tags to it. You can attach, replace IAM rules, that is access management policies, guys. So you have a user access management policies here. You can attach roles to it as well. You can change the instance type, guys. You can click on it and you can go ahead and do that. You can change it to higher versions as well. Now, why do you need to do this? Suppose I'm experiencing a particular traffic and my instance supports that need. But if I move further and in future I need to cater more traffic, what do I do in that case? In that case, guys, I can actually go ahead and update it to a larger version. Unlike your other applications, your on-premise infrastructure, where you have to actually go ahead and have new servers, new data on top of it. Here, what you do is you just click on this thing and it happens in a couple of seconds. Your instance gets optimized or upscaled to a better level, and that is why it is highly scalable. Guys, what you can also do is you can change termination protection. Now this is for data security. Suppose if I am using a particular instance and in that case I accidentally delete it, my data would be lost, right? So what this thing does is it changes or turns my termination protection on. That means if I have to delete this instance, I have to get into the instance, I have to change the policy and then delete it. I mean, I cannot delete it unknowingly, right? So that is why this service helps. Now, while talking about these things, guys, our instance is up and ready. Let us just launch it. I say connect. And it says download remote desktop file, the RDP path that I talked about, right? And I need to get in my password as well, guys, to log in. How do I do that? I click here. I choose the file. For that, I'm going to go to the desktop. I'm going to scroll down. There is a file called as Vishal. I open it and I decrypt it. And there you go, guys. My password is here. I can just copy it. So if this is copied, I can launch this remote desktop file. It would ask me for the password. I would say take this and okay. Do you want to log in unsecurely? Yes. And guys, a Windows instance would be launched. It is just like your Windows operating system, but it is running on my existing system, guys. There you can see personalized settings. It is setting up personalized setting for me, and in half a minute or maybe in 10 seconds, my Windows app would be up and running. So just like my Windows device, I have one more Windows device. So I can do something in this device and something else in my normal Windows device as well, guys. So this is what your instance does. It basically creates an instance, a virtual machine for you to work on. I believe by now you've understood what a virtual machine is. So guys, we are done with this part. So let us just close it for now. Let us see if there is anything else that we need to talk about. Now, if I come back here, I've mentioned that you can take snapshots, right? So these are AMIs. What AMI is, it is an image basically. So I can actually go ahead and launch an AMI for an instance that I already have. I can create an image of it. There is a volume here. So my instances are EBS backed up, right? So there is a block storage attached to it. Can I add another storage to it? Yes, I can remove the previous storage and attach a different storage to it. Say for example, this is the storage that I have with me. If I click on it and I go into actions, I can create a snapshot out of it. Once I create a snapshot out of it, I can attach it to the existing instance. So we just launched an instance, right? So if I want to replace the volume that is already attached to it, what I do is I actually go ahead and detach the volume that is already attached. So I would be stopping my instance first. Once I stop the instance, I can come to the volume. Assume that this volume is attached to some instance. So I need to detach it from here. And the snapshot that I've already created, or if I have created one, I can select that and I can attach that to the existing instance. All I have to do is I have to go ahead and create an image here. Once I create an image, it would ask me what can I do with it. It would ask me to actually go ahead and give in the region in which the instance was created. Now, my instance that I just used was created in a particular region. I'm working in Ohio region for now. What do I mean by these regions? Well, basically what happens is AWS has different data centers in different regions of the world. So you can choose the region that is convenient to you, that suits your business needs, right? So I can create instances in those particular regions. So if my instance was in particular region, I need to create a snapshot in that region and then attach that snapshot or that volume to my instance. So guys, I believe by now you've understood a lot of things. You've understood what instances are, how to launch those, how to create those, and how to make those work. So as far as this session goes, guys, I wanted to talk about these pointers. One more important point that I would like to mention here is make sure that you terminate your instances so that to avoid any charges if there are any. Now, this being a free tier account, I don't think there would be a lot of charges, but still I would request you to actually go ahead and terminate the instances even if they don't charge you a lot, because that is a good practice, because there are certain services that might charge you a lot more, guys. So I'm gonna terminate my instances, the ones that I have created today. So let's just say terminate. And in a minute or two, guys, these instances would be terminated from end to end.
What is Amazon VPC? Amazon Virtual Private Cloud is a service that lets you launch AWS resources in a logically isolated virtual network that you define, which means you will have a part of AWS cloud that can be used only by your AWS resources and can be accessed only by you or the people you permit to access. Now, these people could be your business partners, your employees, or anyone you want. You will have complete control over your virtual networking environment, which would include selecting your own IP addresses range, creating of subnets, and configuration of route tables and network gateway. I will explain all this term in some time. Now, Amazon VPC allows you to create multiple layers of security, including security groups and network access control list, which will help you control access to your Amazon EC2 instances in each subnet. You can use IPv4 and IPv6 for most resources in your virtual private cloud, which will help you ensure secure and easy access to resources and applications. Now that you have some idea about what exactly is AWS VPC, let us move on to our next topic and see how does it work. But before we get into the working part, I would like to explain the terms which I mentioned before. So if you're wondering what are subnets, these are logical subdivision of a larger network. You can launch your AWS resources into a specified subnet. And when I say AWS resources, I mean your EC2 instances and so on. There are two types of subnet, the public and the private. You use a public subnet for resources that must be connected to the internet. And with a private subnet, the resources won't be connected to the internet. Now another interesting point is IP addresses of all the subnet in a network will start with the same prefix. Next we have is a route table. Now a route table contains a set of rules called route that are used to determine where the traffic in a VPC is directed. You can explicitly associate a subnet with a particular route table, otherwise the subnet is implicitly associated with the main route table. Each route in a route table specifies the range of IP addresses where you want your traffic to go, which is the destination, and the gateway, which is the network interface or connection through which to send the traffic, which is the target. Now, as I've mentioned about public subnets and private subnet, let us see the difference between them. So in a public subnet, resources are exposed to the internet using the internet gateway. They make use of both public and private IPs and are mainly used for external facing applications like web servers where you want your information to be visible to the users. Whereas in a public subnet, resources are not exposed to the outer world and it uses only the public IPs. They are mainly used for backend applications like database and application servers. Now that you have some idea about subnet and route table, let us move on to the working of VPC and understand it. Now if your account was created after 4th of December 2013, your account comes with a default VPC that has a default subnet in each availability zone. We will see this in the demo part. Now your default VPC includes an internet gateway and has the benefits of advanced feature provided by EC2 VPC and is ready for you to use. Now if you launch your instance in a default VPC and do not specify a subnet where to launch your instance, the instance is automatically launched in your default subnet, which is a public subnet. You can also create your own VPC and configure it as you want. This is known as a non-default VPC. Now the subnets that you create in your non-default VPC and any additional subnet that you create in your default VPC are called as non-default subnets. Now you can see we have something called an internet gateway. Now an internet gateway is a gateway that allows your instances to connect to the internet. You can do this through Amazon EC2 Network Edge. Each instances that you launch in your default subnet has a private IPv4 address and a public IPv4 address, as you can see here. By default, each instance that you launch in a non-default subnet has a private IPv4 address but not a public IPv4 address unless you specifically assign it. These instances can only communicate with each other but cannot access the internet. But you can enable internet access for these instances by attaching the internet gateway to its VPC and associating an elastic IP address with the instance. Now, how can you connect your VPC to other VPC or to your on-premises network? So for this, you can create a VPC pairing connection between the two VPCs that enables you to route traffic between them privately. Now, instances in either VPC can communicate with each other as if they were in the same network. You can also create a transit gateway and use it as an interconnection between your VPC and your on-premises network. The transit gateway acts as a regional virtual router for traffic flowing between its attachment, which could include VPC, VPN connection, AWS Direct Connect gateways, and transit gateway peering connections. Now I hope you have some idea about the working of VPC. Let us move on to our next topic and see some of the use cases of VPC. With Amazon VPC, you can host a simple web application such as a blog or a simple website with additional layer of privacy and security. You can help securing the website by creating security group rule, which will allow the web servers to respond to inbound requests from the internet while simultaneously prohibiting the web servers from initiating outbound connection to the internet. Now what this means is you can control your data traffic in and out of your VPC. You can create a VPC that supports this use case by selecting VPC with a single public subnet only from the Amazon VPC console wizard. With VPC, you can also host multi-tier web application and strictly enforce access and security restriction between your web servers, application servers, and databases. You can launch web servers in a publicly accessible subnet while running your application servers and databases in a private subnet. This will ensure that your application servers and databases cannot be directly accessed from the internet. To create a VPC that supports this use case, you can select VPC with public and private subnet in the Amazon VPC console wizard. With Amazon VPC, you can also backup and recover your data after a disaster. By using Amazon VPC for disaster recovery, you will receive all the benefits of a disaster recovery site at a fraction of the cost. You can periodically backup critical data from your data center to a small number of Amazon EC2 instances with Amazon EBS volume. Or you can also import your virtual machine images to Amazon EC2. To ensure business continuity, Amazon VPC allows you to quickly launch replacement compute capacity in AWS. These were some of the use cases of using VPC. Now let us move on to our next topic and see an overview of the other networking concepts in AWS. First, let us talk about Elastic Load Balancer. Elastic Load Balancing automatically distributes your incoming traffic across multiple targets. The targets could be EC2 instances, containers, and IP address in one or more availability zones. It will monitor the health of your registered target and route traffic only to the healthy target. It scales your load balancer as your incoming traffic changes over time. You can add and remove compute resources from your load balancer as your need changes. It will not disturb the overall flow of requests to your application. Now, Elastic Load Balancing offers 4 types of load balancer. First is the classic load balancer, which provides basic load balancing across multiple Amazon EC2 instances, and it operates both at request level and the connection level. A classic load balancer is intended for applications that were built within the EC2 classic network. Second, we have application load balancer. It is best suited for load balancing of HTTP and HTTPS traffics and provides advanced request routing, which is helpful in modern application architecture, including microservices and containers. Third, we have network load balancer, which is best suitable for load balancing of TCP, UDP, TLS, where extreme performance is required. A network load balancer routes traffic to targets within Amazon VPC and is capable of handling millions of requests per second while managing ultra-low latencies. Fourth, we have the gateway load balancer. It is used to deploy, scale, and run third-party virtual networking appliances. Gateway load balancer is transparent to the source and destination of traffic, which makes it well suitable for working with third-party appliances for security, network analytics, and other use cases. This was about Elastic Load Balancer. Now let us take a look at AWS Direct Connect. AWS Direct Connect is a cloud service solution that makes it easier for you to establish a dedicated network connection from your on-premises to AWS Cloud. Using AWS Direct Connect, you can establish a private connection between AWS Cloud and your data centers or your office. You can increase the bandwidth throughput and provide a more consistent network experience than internet-based connections. AWS Direct Connect is also compatible with all the AWS services and is available in the speed starting from 50 Mbps and can be scaled up to 100 GB per second. It helps you build hybrid environment, which allows you to use the benefits of AWS and continue to utilize your existing infrastructure. Now let us move on to our next service, which is Route 53. Amazon Route 53 is a highly available and scalable cloud domain name system or DNS web service. It is designed to give developers and businesses a reliable and cost-effective way to route end users to internet applications by translating names into numerical IP addresses. This can be used for computers to connect to each other. Now Route 53 performs 3 main functions. First one is it registers your domain name. Every website needs a name, be it edureka.co or anything like facebook.com. So Route 53 lets you register a name for a website or web application known as a domain name. The second function is it routes internet traffic to the resources for your domain. So when a user opens a web browser and enters your domain name or the subdomain name in the address bar, Route 53 helps connect the browser with your website or web application. The third function is it checks the health of your resources. Route 53 sends automated requests over the internet to a resource, such as a web server, to verify if it is reachable, available, and functional. You can also choose to receive notification when a resource becomes unavailable and choose to route internet traffic away from the unhealthy resources. Now these are some of the networking services in AWS. Now let us move on to a demo part where I will teach you how you can create a VPC, your subnet, your route table, and an internet gateway. So for our demo, I've logged into my AWS console. If you do not have an AWS account yet and want to practice AWS services, I would highly recommend you to create an AWS free tier account where you can access more than 75 AWS services for free for a year. So a point to remember is your VPC will be set in this region. In my case, it is Ohio. You can see there are so many regions available here. Your VPC can be set in your selected location. Now let us start a demo. We'll search for VPC. You can just search over here, VPC. Here it is. Now when you click on your VPC, you can see there is a default VPC as I mentioned before. It will also have a default subnet inside it. So now let us create our own VPC. So we'll click on create VPC. So it will ask us to name our VPC. Let me name it demo VPC. Now when you create a VPC, you must specify a range of IPv4 address for the VPC in the CIDR block, which stands for classless inter-domain routing. We will go for the primary CIDR block, which is 10.0.0.0/16. Now mention 16 over here, which means 16 bits is reserved for my VPC network. Now we'll go with the default. I do not want any IPv6 CIDR block. Next we have tenancy. Now here you can see we have two options. One is default, the other one is dedicated. So what dedicated means is you can run your instances in your VPC on a single tenant or a dedicated hardware. So we'll just stick to default here and create our VPC. Then you'll get a message saying you have successfully created your VPC. This is your VPC ID and this is your VPC name. Now let us create a subnet. Now as I've told you in the theory session, a default subnet is created. And you see we have 3 default subnets over here. When I just scroll here, you see the 3 default subnets are created in 3 different availability zones. So each availability zone has 1 subnet in it. So now let us create a new subnet. We have to select a VPC from here. This is a VPC. Next we'll come down and we'll name our subnet. Let us name it demo subnet. Now we have to select our availability zone. We have 3 availability zones in Ohio. We'll just select one of these. Now we also have to mention our IPv4 CIDR block for our subnet. So we'll just set it to 24. So when I type 24 over here, it means 24-bit is reserved for my VPC network. Now the starting of the IP address of the subnet should be the same as the starting address of your VPC. Now after this, let us create a subnet. This might take a few seconds and you can see you have successfully created your subnet. This is your subnet ID and this is your subnet name. Next we'll create our internet gateway. We'll get back to route table in a few minutes. Now as you can see there is a default internet gateway, but we will go ahead and create our own internet gateway. So here it will ask us to name our gateway. Let's just name it demo internet gateway and just create our internet gateway. It is very simple. Now our internet gateway is created. This is our internet gateway ID, but the state is detached. Now you can go attach your VPC to your internet gateway. Just click on attach to a VPC over here and just select a VPC from here. Here is our VPC, so we'll just select it. And now attach internet gateway. So here, the state is attached. Now let us move on to the next step and create a route table. Now as I mentioned before, route table determines where the network traffic from a VPC is directed. Now these are some of the default route tables, but we'll create a new route table. So now we have to name a route table. Let us name it demo route table. And we have to attach a VPC to it. Here is a VPC. Let us create it. We'll get a message saying a following route table was created. And here is the route table ID. We'll close it. So after we create a route table, we have to associate a subnet to it. So we'll just click on route table over here. Go to subnet association. Edit subnet association. Now select a subnet. So this is a subnet, demo subnet. So we'll save it over here. After the subnet association, we have to edit the route to access the internet gateway. So we click on route, edit our routes. Now let us add another route. So the destination will give 0.0.0.00. Now this means your traffic can flow anywhere. The target will keep it as internet gateway. So we're trying to access our internet gateway. So we'll select this and then save the route. Now we get a message saying route successfully edited. We'll close it. Now with this, we have created a VPC, a subnet, a route table, and an internet gateway. Now let us see if we can launch an instance in our VPC. For that, let me go to New tab, AWS Management Console. Let me type EC2 over here. I'll go to Instances. I'll go to Launch Instances. Here, let me launch in Window instance. So I'll select Window. Now I'll select this instance and then go to Configure Instance. Now here under Network, I'll remove the default VPC network and set my network. I'll change the subnet also. And we also have to change the auto assign public IP to enable. We will enable this to create a public IP. So after this, we'll make no changes. Go to Review and Launch. Before that, let us create a security group. Let us just name it Demo Security Group. And now Review and Launch. We'll use an existing key pair and now launch our instance. Now let us click on View Instance. Now this might take a couple of minutes. While our instance is getting created, let us go back to a VPC. We go to VPC dashboard, and here you can see there are two VPC. One is a default VPC and the other one which we have created. And there are 4 subnets. 3 are defaults and 1 which we have created. There are 2 default route table and 1 which we created. There was 1 internet gateway which was default, and then we created another one. Now let us check our EC2 instance. We'll refresh it. Now you can see 2-on-2 status check is passed. So we'll click on our instance ID. Now this is our instance ID. This is a public IPv4 address, a public IPv4 address. Now when we come down and see the VPC ID over here, you can see the instance was created in our VPC ID. That is the name of our VPC, and it is also created in our subnet, which is the demo subnet. And you can also see it was set up in the availability zone you had mentioned. Now the instance can be used only by me or the people I permit. A part of AWS Virtual Cloud was given to me to run my resources.
So what exactly is AWS Lambda? According to Amazon, AWS Lambda is a serverless compute service. This means the developers don't have to worry about which AWS resource to launch or how they're going to manage them. All they have to do is just put the code on Lambda and it gets executed. It's as simple as that. This not just helps in saving time, but it also allows you to focus on the core competency, that is app building or the code itself. AWS Lambda is used to execute your backend code by automatically managing the AWS resources. When we say manage, it includes launching or terminating instances, health checkups, audio scaling, updating or patching new updates, etc. So how does Lambda actually work? The code that you want Lambda to run is known as a Lambda function. Now, as we know, a function runs only when it is called, isn't it? Here, the event source is the entity which triggers a Lambda function, and then the task is executed. Let me take an example in order to make you all understand this. Suppose you have an application for image uploading. Now, when you want to upload an image, there are a lot of tasks that are involved, such as storing the image, resizing it, applying filters, compression, etc. Now, this task of uploading an image can be defined as an event source or the trigger. This trigger is used to call the Lambda function, and then all these tasks can be executed using the Lambda function. In this example, a developer just has to define the event source and upload the code. So now, let us take another instance of the same example. In this instance, we'll be uploading images in the form of objects to an S3 bucket. This uploading of an image to an S3 bucket will become an event source or the trigger. The whole process can basically be divided into 5 steps. First, the user uploads an image or the object to a source bucket in S3, which has the notification attached to it for the Lambda function. This notification is read by S3 and it decides where to send the notification. Then, S3 sends the notification to Lambda, and this notification acts as an invoke call for the Lambda function. Execution role in Lambda can be defined as an IAM or Identity and Access Management to give access permission for the AWS resources, for this example where we've used S3 bucket. Finally, it invokes the desired Lambda function which works on the object that has to be uploaded to the S3 bucket. Now, if you were to solve this scenario traditionally along with development, you would have to have hired people for managing various tasks such as size, provision, and scale-up group of the servers, managing the operating system updates, applying security patches, and also monitoring this infrastructure for performance and availability. Now, this would have been an expensive, tedious, and a tiresome task. Therefore, the need for AWS Lambda is justified. AWS Lambda is compatible with Node.js, Python, Java, etc. All you have to do is upload your zip file, define an event source, and you're all ready to go. So by now, you would have understood what is AWS Lambda and how it actually works. Moving ahead, let us understand where to use the Lambda compute service and also a brief comparison between Lambda and other AWS compute services. So now, to understand this part of the session, consider that you were an architect and you need to design a solution for some problem. Now, as an architect, you have various AWS services that can be used to execute a task. Now, these services can be anything such as the AWS EC2, AWS Elastic Beanstalk, AWS OpsWorks, and AWS Lambda. AWS OpsWorks and AWS Elastic Beanstalk are used to deploy an application. So our use case is not to create an app, but to execute the backend code. Then why not EC2? So AWS Lambda versus AWS EC2. If you were to use the AWS EC2 service, you would have to architect everything, that is the load balancer, EBS volumes, software stacks, etc. In the AWS Lambda service, you don't have to worry about anything. All you have to do is just insert your code and the AWS will manage the rest. For example, in EC2, you would be installing the software packages on your virtual machine, which would support your code. Whereas in Lambda, you don't have to worry about any virtual machine. All you have to do is just insert the plain code and Lambda will execute this for you. Now at this point, I want you all to know something very important. If your code will be running for hours together and you expect a continuous stream of requests, you should probably go with EC2. This is because the architecture of Lambda is for a sporadic kind of workload, wherein there will be some quiet hours and some spikes in the number of requests as well. Say for example, logging the email activity for a small company. Now a small company would have more activity during the day than the night. Also, there could be days when there are less emails to be processed, and sometimes the whole world could start emailing you. In both the cases, Lambda is at your service. Considering this use case for a big social networking company, where the emails are never ending because of its huge user base, Lambda may not be an apt choice. So that was about EC2 and Lambda. I hope you guys have understood where to use Lambda and where to use EC2. Now moving on and understanding the pricing in AWS Lambda. Like most of the AWS services, AWS Lambda is also a pay-per-use service. This means you only pay for what you use. Therefore, you are charged for the number of requests that you make to the Lambda function and the duration for which your code executes. When it comes to the requests, you are charged for the number of requests that you make across all the Lambda functions. AWS Lambda counts a request each time it starts executing in response to an event source or invoke call, including a test that is invoked from the console. The duration is calculated from the moment your code starts executing till the moment it returns or terminates. Now this is rounded up to the nearest 100 milliseconds. The price depends on the amount of memory you allocate to your function. So now moving on towards the most interesting part of the session, which is the hands-on demonstration of AWS Lambda service. Now if you don't have your account in AWS Lambda and want to create your own account, please make sure to check out AWS Crash Course video of Edureka. Now, presuming that you guys already have an account and have logged into your AWS console, let's move on and take a look at how to create a Lambda function. Okay, so creating a Lambda function. Now, like I've already mentioned before, the first thing that you will have to do is open up the AWS console. Now, if you already have an AWS account, just log into your account. Else, if you're creating a new account, please make a note that AWS will provide free services for an year. And if you wish to know more about this, check out the AWS free trial services page on Amazon's official website. Now, since I already have an account, what I'm going to do is just log into my account and get started. Okay. Now, as you can see on the screen, this is the AWS Management Console. As you can see, there is a huge list of services that are provided by AWS. Now, if you just scroll down, you will notice that the Lambda service is present under the Compute section. So just click on that to move on to the Functions List page. Now this page basically shows the functions that you have created in the current AWS region. Please make a note that recently created functions might not immediately appear, and it may take a while for them to show up. So as you can see, this page has several options such as create function, filter, actions, etc. Also, if you are a returning user who has already created some Lambda functions, you will see a list of functions that you've created. Else, this list will be empty. Now, if you want to create a Lambda function, simply click on the Create Function option that is present at the right top corner of the page. Also, if you can notice, the Actions drop-down list is not clickable. This is because the actions are to be performed on the Lambda functions that are already created. So if you do not have any function, you will not be able to click on the Actions drop-down list. However, if you have some function present already, select the function and you will see that the Actions list gets enabled. And it provides three options, that is View Details, Test, and Delete. As the name suggests, the three actions will help you view the Lambda function details, test it, or delete the function if it is no longer required. Now, since we are focusing on creating a Lambda function, let me just click on the Create Function option. Okay, so this is the Create Function page. As you can see, there are three options that are present over here. The first option, that is Author from Scratch, allows you to create a Lambda function completely on your own. So if you want to create your own Lambda function, just give it a suitable name and specify the runtime you prefer. In our case, the name of the function will be Hello World. The runtime or the language that I'm going to make use of is Python. You can go ahead and select any runtime that you wish to use. Okay, so I'll just select Python 3.8. So next up, after runtime, you see something called as permissions. Now this basically refers to the function permissions. By default, Lambda will create an execution role with permissions to upload logs to the Amazon CloudWatch logs. Amazon CloudWatch logs is nothing but a monitoring and management service. It provides data and actionable insights for AWS, hybrid, and on-premises applications and infrastructure resources. When you make use of AWS CloudWatch, you can collect and access all your performance and operational data in form of logs and metrics from a single platform. However, the default role can be customized later when you wish to add triggers. Okay, so now I'll just go ahead and click on the Create Function option. Now it is going to take a few minutes to do so. Okay, so let us wait for the same. Now once the function has been created, you will see the message just as you can see on the screen, that is, successfully created the function Hello World, which is the name of the Lambda function that I just created. Now this page basically allows the user to manage the code and the configurations. Once you have provided the required code and its configurations, simply click on the Test option in order to execute the code. Now before doing that, let me walk you through this page. The first element that you see over here is the page configuration. This page has something called as the designer. Here, you can add triggers, layers, and destinations to the Lambda function that you've created. A trigger over here refers to an AWS service or a resource that is used to invoke the Lambda function. Now, if you want to connect your function to a trigger, click on this Add Trigger option. As you can see, there is a drop-down list over here with a huge list of triggers that you can choose from. Choose a service from the list. You can choose a service from the list to see the available options. Now for the first part of this demonstration, I'll not be using any of these. So I'll just click on Cancel and I'll get back to the previous page. So the next thing that you see right in the middle of the screen are two options. That is, the function that you've just created, which in my case is Hello World, and layers. By default, the function is selected, and when you scroll down the page, you'll be able to see the code editor and a sample code that has been generated automatically for my function. So now, this is a very simple function. It is called as the Lambda handler, which simply returns a message saying hello from Lambda. The code editor in AWS Lambda console enables you to write, test, and view the execution results of the Lambda function code. For the purpose of this tutorial, let me just change it to hello from Edureka and then I'll just save it. Okay, now let's scroll back up and select the layers option. So layers are resources that contain libraries, a custom runtime, or other such dependencies. You can create layers to separate your function code from its dependencies. Now by default, as you can see, no layer has been added. To add a layer, all you have to do is click on layers and then choose Add a Layer option. To include libraries in a layer, place them in the directory structure that corresponds to your programming language. Now, since we have a very simple function, I'll not need any extra layer for it. But for the sake of showing you guys, let me just click on Add a Layer option. Okay, so as you can see, there is a drop-down list present over here as well. When you click on this, you'll be able to see that by default, there are two layers present over here. One is for Perl, and the other one includes SciPy library for Python 3.8. Also, there are two other options that are present over here. One is custom layers and the other is specify an ARN. In the custom layer option, you will see any of the previously used or created layers. Since I've not used any, my list is blank. The next option is to use an ARN. ARN stands for Amazon Resource Name. Entering an ARN will enable you to use a layer that is shared by another account or a layer that does not match your function's runtime. The format in which you should specify an ARN is shown in the text bar itself. Okay, so now let's get back to our previous page. Okay, so I'll just click on Cancel. Now towards the right side of this page is something called as destinations. Destinations are AWS resources that receive a record of an invocation after success or failure. Now you can configure Lambda to send invocation records when your function is invoked asynchronously or if your function processes records from a stream. To add a destination, choose Add Destination option. The contents of the invocation record and supported destination services vary by the source. So the next element that is present on this page is permissions. Like I've already mentioned before, the default execution role that was used for this Hello World Lambda function has the permission to store logs in the Amazon CloudWatch logs. Now this is the only permission that we have as of now. The resource permissions can vary depending on the role that you select for your function. Finally, there is something called as monitoring. Now when you click on this monitoring element, you can see some graphs which do not show any data as of now. This is because I've not invoked my function yet. Once the function has been invoked, you'll be able to monitor, trace, and debug your Lambda functions. So coming back towards our Hello World function. So let me just scroll down to the code editor. So now to invoke this function, I will have to test it. Before clicking on test, let me show you the default test event. Now you can open the test configuration either by clicking on Select Test Event dialog box or by opening the drop-down list that is present next to the test option in the code editor. So let's click on Configure Test Events. Now you can see there is some default test event present over here. Also, by default, the Create New Test Event option has been selected. The other option, that is Edit Save Test Events, cannot be selected as I have not created any test event before. So let's just give some name to this event. I'll say Event 1 and click on Create. So now our function is all set. To invoke this Lambda function, I'll have to click on the test option like I've already mentioned before. Okay, so let me just click on that. Now as you can see, I have a dialog box that says execution result has succeeded. When you open the details, you'll be able to see the summary and the log output. The summary section shows the key information such as the time taken for the execution, build duration which is 100 milliseconds, request ID, etc. that are reported in the log output. The log output section will show the logs generated by the Lambda function execution. Now, when you check the monitoring page this time, you will see that all the metrics here would be updated. For instance, let me hand over the error count and the success rate metrics. As you can see, it clearly shows that our program has executed with 100% success rate and 0 errors. Similarly, you can check various other metrics such as the number of invocations, the duration, etc. Now let us do something that will show us. Okay, So now let us do something that will show us the real-time metrics. What I'm going to do over here is add a trigger, and that will be an API gateway. This way, I'll be able to see how many times my function has been invoked, the average duration, etc. So let us go back to the configurations element and click on Add Trigger. Then I will open this drop-down list and I will select API Gateway. So over here, I will create an API with the default HTTP API type, and I can keep the security open as this is just for demonstration. However, please make a note that in real-world scenarios, this is not the case. The name will just be Hello World API, and the deployment stage will be default. So just create the API. So now, as you can see on the screen, I have an API endpoint over here. Let me just open that link in a new tab, and I will repeat the same thing a few times. I've opened that link in 4 new tabs, and now I'll get back to our console. I'll open the metrics page and let's see what happens. So as you can see, I have some real-time data that is present over here. I have 4 invocations, the corresponding minimum and maximum duration, etc. So now there are many more things that you can do with AWS Lambda functions. However, for the sake of this session, we won't be getting into any further details. However, there is one last and important task that is left. Once you're done using your Lambda function, make sure that you delete it. To do so, all you have to do is click on the Actions drop-down list and select Delete Function option. So congratulations guys, you have learned how to create and manage your AWS Lambda function, which is very important in learning how to run applications without needing to provision or manage servers.
What is AWS EMR? So Amazon EMR, that is Elastic MapReduce, is the service offering that lets you scale and run data lake services on demand in the Amazon cloud. EMR is designed to be an alternative to on-premise big data server provisioning and processing using open source products such as Hadoop, Hive, Spark, Flink, Presto, TensorFlow, working with S3 for storage and EC2 instances for computing power. So EMR is a fully managed data lake service that can decouple data storage from compute resources, and instead it can make compute clusters scalable, available to be utilized on demand. It includes the ability for multiple clusters to access the same data sets at once. So this was the definition of AWS EMR. And now let us talk about the benefits or the advantages of AWS EMR. So as you can see here, the first advantage that EMR has to offer us is the reduce the cost of physical infrastructure. As with all cloud-based compute services, EMR removes the need to purchase, maintain, run, and house physical server infrastructure that would be performing big data computational services on site. You can use the same tools and services that you currently use on site in the cloud instead, but instead pay per second for the compute cluster resources that you use. So the second point here is it saves system admin time. One of the most important advantages of using EMR is savings in the system administrator's time that would otherwise be spent configuring and provisioning on-site servers for big data computational tasks. It is possible that you may have self-built scripts to aid in this process. For every change that's made or new service that's added, these will need to be tweaked. With EMR handling all these operational details for you, it means you spend less time configuring manual admin tasks. The next point here is the optimum resource utilization. The key to EMR's cost-saving benefits really lies in the fact that storage and compute can be decoupled. This means that you can spin up and scale EC2 instances and clusters when needed. Then release resources once you're done. Inbuilt elasticity with AWS auto-scaling implies that you only pay for what you need. Here you must keep in mind that to get the same performance as in-house processing, your storage will need to be kept locally. And apart from this, if you talk about the other benefits, so EMR includes 24/7 customer support as standard with a subscription, which is far less than other Spark and Hadoop vendors charge. fast spin-up times for instances to run your service, and an EMR that can be run on AWS Virtual Private Cloud for increased corporate data security. The benefits of EMR extend far beyond simply time and cost savings. EMR is useful to deliver real business value by processing big data. So these were the benefits, or you can say the advantages of AWS EMR. And now let us talk about the AWS EMR applications. So the first application here is change the rigid in-house cluster infrastructure. Running the same complete cluster infrastructure anytime you need to analyze big data, no matter what the terms of analysis are, is a waste of resources. Unless you have managed to configure elastic clustering on your machines, EMR is more resource efficient. The second point here is the hassle-free Hadoop management. Currently, businesses rely on on-premise Hadoop for their big data processing needs. With Hadoop fully managed on EMR, this implies that you remove the time and complexity involved with in-house Hadoop management, such as upgrading, maintenance, node failures, operational costs, and so on. And the last point here is the less time for data processing. If running processing in-house is too time consuming, leaving people waiting around for results or other teams waiting to add to the queue, then you have the option to either add new physical hardware to speed up the process, or you can choose a completely scalable EMR solution to complete tasks in a fraction of the time. Switching to EMR reduces the time on average to run the queries by 40% and increasing the number of queries run each day by 33%. So these were some of the applications or the scenarios, or you can even say the usages of AWS EMR. So one of the most common query is like when to use AWS EMR and when to use AWS Redshift. So if you talk about Redshift, that is AWS Redshift, so you must use Redshift when you have a traditional data warehouse. Second point here is when you need the data to be relatively hot for analytics, such as the business intelligence. Third, when there is no data engineering team. Fourth point here is when you require joins on your data. And the last point here is when you need a cluster which is to be available 24/7. So these were the circumstances when you should use AWS Redshift. Now, if you talk about the AWS EMR, you should use AWS EMR when you don't need a cluster 24/7. The second point here is when elasticity is more important. Like one of the top priorities of your application is the elasticity. So the third point here is when the cost is important. The next point here is you must use AWS EMR when you have until a few hundred terabytes of data, or even you can say petabytes of data. And finally, you should use AWS EMR when you want to separate compute and storage. So these were the scenarios where you should use AWS EMR. So let's just consider a use case here. So there's this company called Yelp, which was founded in the year 2004 with the main goal of helping people connect with great local businesses. The Yelp community is best known for sharing in-depth reviews and insights on local businesses of every sort. In their 10 years of operations, Yelp went from one city wonder, that is San Francisco, to an international phenomenon spanning across 29 countries with more than 120 markets. Yelp had an average 138 million monthly unique visitors and more than 61 million local reviews that have been written by Yelpers, or the people who use Yelp. So what was the challenge in front of this company called Yelp? So Yelp has established a loyal consumer following due in large part to the fact that they are vigilant in protecting the user from shill or suspect content. Yelp uses an automated review filter to identify suspicious content and minimize exposure to the consumer. The site also features a wide range of other features that help people discover new businesses, such as lists, special offers, and events, and communicate with each other. Additionally, business owners and managers are able to set up free accounts to post special offers, upload photos, and message customers. The company has also been focused on developing mobile apps and was recently voted in the iTunes Apps Hall of Fame. Yelp apps are also available for Android, BlackBerry, Windows 7, and so on. So local search advertising makes up the majority of Yelp's revenue stream. The search ads are colored light orange and clearly labeled sponsored results. Paying advertisers are not allowed to change or reorder their reviews. So how did Yelp made use of AWS, that is Amazon Web Services? So Yelp originally had to depend upon giant RAIDs to store their logs along with their single local instance of Hadoop. When Yelp made the move to Amazon Elastic MapReduce, they replaced the RAIDs with the Amazon S3, that is Simple Storage Service, and immediately transferred all Hadoop jobs to Amazon Elastic MapReduce. Yelp uses Amazon S3 to store daily logs and photos, generating around 1.2 TB of logs per day. The company also uses Amazon EMR to power approximately 20 separate batch scripts, most of those processing the logs. So if you talk about the features of AWS EMR, their jobs are exclusively written in Python, while Yelp uses their own open source library called MRJob to run the Hadoop streaming jobs on Amazon EMR, with Boto to talk to Amazon S3. Yelp also uses S3 CMD and the Ruby Elastic MapReduce utility for monitoring. So Yelp developers advise others working with AWS to use the Boto API as well as MRJob to ensure full utilization of Amazon Elastic MapReduce job flows. Yelp runs approximately 250 Amazon Elastic MapReduce jobs per day, and all this can be done with the help of AWS with other Hadoop application development. So how did Yelp gain out of this application? So using Amazon Elastic MapReduce, Yelp was able to save $55,000 in upfront hardware costs and get up and running in a matter of days and not months. However, most important to Yelp is the main opportunity cost. So these were the benefits that Yelp gained by making use of AWS EMR. So now let's just move on to the next part here, and which is the final part of this session, that is the demo part. So here we are going to create an EMR cluster in AWS. So let me just quickly show you how are we going to do this. For that, you just need to log into your AWS console here. So this is the management console. Once you log in using your credentials, you'll be navigated to this page, AWS Management Console. So once you go here you have to click on EMR. So EMR can be found in the analytics section here. Okay, as you can see here, just click on that. And this is where you'll be navigated. Since we have to create a cluster here, so let's just click on the cluster here. Once you do this, you have to name your cluster. So you can name it whatever you want as per your convenience. I'm naming it Arvind cluster, and launch mode is by default cluster. The release is the latest one, EMR. And depending upon your application, you can select this, any one out of this four. If you have core Hadoop application, select this option. Whereas if you want to run a Spark application, you can select this option. Okay. So as of now, we are selecting this only. And the hardware configuration by default, it's 3, 1 master, 2 core nodes. So after this, you have to select one EC2 key pair. If you don't know how to create an EC2 key pair, you can click on the link here and create it. So now I'm clicking on this create cluster here. So as you can see here, it shows starting. The message is being displayed here, starting. So this might take a few minutes. Okay, so as you can see here, it is still starting. So we just need to refresh this, and this might take a few minutes here. Since our cluster is starting now, and the cluster will be ready once it goes into the waiting state. So before that, we have to create a few things here. So as you can see here, security groups for master. You have to click on this link here, and you'll be navigated to this page here. So once you do that, you have to click on the security group of master here. Okay. After that, you have to click on this inbound tab here. Okay. So once you do this and click on edit. So what you have to do is you have to click on add rule here. And for that, you have to select one option called SSH. And here it says anywhere. You have to select this option anywhere. And you have to just save this. So the same thing can be done for slave as well, but it is totally optional. So once we're done with this, let me just close this. So let me just refresh the EMR console here. And there's this option here to connect to the master node using SSH. So these are the steps that you must follow. This is the procedure to connect to the master node, and you can then write your steps or jobs. You can write your jobs using the command line. So the steps are very simple here. For that, you have to download an application called Putty. So I've already downloaded that. I have to click on this. So once you do this, you have to click on session here. On this session, you have to enter the host field name. Just copy this and paste it here. And once you do this, you have to click on connection here. You have to enable this option here, enable TCP keep lives. Just click on here, and after that, click on SSH here. And once you do this, click on authentication here, and you have to select a private key here. That is PuTTY private key. So I already have this key here, Edureka key pair. Select this and click on open. So you'll get this alert here, PuTTY security alert, whatever this is written here. You have to just click on yes here. So as you can see here, this is the command line from where you can write your jobs. So this is how you connect to the master node. As you can see here, previously it was starting and now it is running. So which means the cluster is ready. As you can see here, Arvind cluster, it's running and the green symbol here. So after this, how do you write jobs for this cluster? So for that, you have to click on steps here. So what you can do is you have to click on add step here. So depending upon the type of application, say for example, if you have to write a pig program, Hive program, streaming program, or any custom jar. So say for example, you have a Hadoop program on Eclipse, you can export it using a jar and you can select that jar here. So custom jar, whatever the name of the jar, and the location where you have this jar. So you can keep that jar file on the Amazon S3, which is basically used for storage purpose. So similarly, if you have a Hive program like Hive queries, so you can select even that as well. So for Hive, there's a script called Hive script, and which can be stored on S3. As you can see here, you can store it on S3 and script input and output. So basically here what you do is when you go to S3, you have to create 3 separate folders. So one folder will have a script. You have to just copy the location of that over here and the input data and the output. These are the various things that you can perform using a cluster in AWS EMR. So let me just click on cluster here. Okay, so as of now, you can see it is in the running state. Once it is running, you write whatever steps or the jobs that you want. You perform your operations or tasks. And after that, once you're done with this, you have to terminate this. So it's very important to terminate the EMR cluster here, else it will fetch you unnecessary charges. Like cluster is running and you're not doing anything on it. It is simply running. So this will cost you unnecessarily a few dollars maybe. So whenever you're done with using a cluster, you must terminate it. For that, you have to select this cluster here and click on terminate. So it says, are you sure? I'm sure. So once you're done using your cluster, you can just terminate it here. Okay. So here it says terminating user request.
So what exactly is cloud storage? Now, first and foremost, let me tell you what prompted me to actually go ahead and take this session. Well, recently I had been interviewing and where I asked people what did they know about cloud computing, and they told me that cloud computing is a place, or it is a place online where you actually store data. I mean, to some extent, I agree. Yes, cloud computing helps you store data, but that is not the definition on the longer run. So that is why I thought that we should actually go ahead and have this session so that we can discuss some of the myths that surround cloud computing and cloud storage in particular. So guys, let's start with the basic definition first. Storage, well, it is something that is made available in the form of service, which is connected over a network. So guys, this is a very basic definition, and to throw some more light, I would like to actually go ahead and give in certain examples as well to specify what does this definition mean. But to some point, this definition is correct. It says that it is nothing but a storage which is available as a service which is connected over a network. Now again, you might wonder, as in this is what people told me in the interview, right? I mean, it is a place where you store data. So yes, cloud storage to some extent, yes, this is what it is. But when you talk about cloud storage, it is a lot more than this basic definition. Let's try to understand what all does cloud storage exactly has to offer to you people. Well, first and foremost, as I've already mentioned, it is storage. It can let you store emails. Media. Now when I say media, you can store in different kind of media, whether it's your images, whether it's your videos, or maybe other kind of files. It also lets you hold services as well. Yes, we are living in the world of internet right now, and there are various services, websites that are online, and this data can be stored by using cloud platform. And finally, I'm sorry guys, finally it is nothing but the backup. Now when I say backup, guys, we're talking about large enterprises that let you back up the data, and they're using cloud platform to do that. But again, it still holds the same point, right? I mean, when I say emails, media, services, backup for large organizations, I mean, it is still a simple storage. No. Now let me tell you what it does. When I say backup for large organizations, we are referring to a lot of pointers here. Data coming in from different sources, the way it is processed, the way it is integrated and stored into a particular storage, how it is handled, and what all can you do with it. Now when you talk about a cloud storage, it actually takes care of all these things. That means it's not a redundant or a dead storage where you just take your data and put in your data. You can think of it as smart data storage. So to understand that, let's talk about cloud computing a little. So what cloud computing does is it lets you have this data on their platform, and it is a platform where it has n number of services that lets you compute or process this data to suit your business needs. Now it can be using machine learning, big data, finding out certain patterns using Power BI tools, or not Power BI tools, BI tools, and also do a lot of other things like maybe use a cloud platform where the data can be used for marketing purposes, maybe building IoT bots and stuff like that. So this is what a cloud computing platform does. It basically lets you use different sources and use this particular data to do multiple or different kinds of things. So when I say a cloud storage, it basically ensures there is a mechanism that in first place it stores data and lets you perform some of the actions that you can actually perform on this data. So as we move further, I would be discussing quite a few pointers that support this claim or this definition of mine. So let's just move further and try to understand a little more pointers or some other pointers that talk about cloud storage. But to keep it simple, it is a storage that lets you do a lot of things with your data. Primary reason being storing the data, and the other reasons being processing it or managing it also. So let's move further and take a look at the next pointer. So what are the myths that surround a cloud storage? Well, when you talk about the myths, this is what some people had to say, that cloud computing is suitable only for large scale organizations. No, this is not true. Let me give you an example. Recently what happened was, one of my friends, he actually happened to format his mobile phone and he lost all the images and all the data that was there on that phone. So the problem was he never backed that data up on any drive, neither on Google Drive or anywhere. So he lost the data. So he came to us and he told us that this is what happened. So we told him that probably he should have backed it up maybe on Google Drive. So next time he did that. And again, he being used to losing his data, he lost his data again. So he again comes up and he's like, I've lost the data. So we reminded him that he had his data stored on the Google Drive. So when you talk about Google Drive, it is nothing but an online storage where you actually make a copy of your data. So he made a copy of his data and he could actually get that data back. So when I say cloud storage, it gives you a simple application or a simple service where you can actually go ahead and just put in your data, just like Google Drive, where you can put in your data as well. So it is not limited to large scale organizations only. If even you are a single individual where you just need to store your data, you can use cloud storage. Now there are various cloud service providers that actually meet or cater different cloud computing needs. So based on that, the cloud storages might get complicated and might give you more functionality. But even if your need is as basic as storing data, don't worry, cloud computing or cloud storage is for you as well. Now if you talk about small scale businesses, yes, these days the amount of data that is generated is huge, and that is why what happens is, even for small scale organizations, you need a place where you can store your data and somebody can manage that data for you so you can focus on your business goals. So this is where cloud storage comes into picture for even small scale businesses as well. So if you ask me, yes, large scale organizations are suitable for cloud computing or only large scale organizations are suitable for cloud storage, this is a myth. Complexity with cloud, guys. Now, what does this term symbolize? People normally assume that having their private infrastructures makes it easier for them to actually go ahead and put in your data. That is not true. The fact that people are used to certain methods or methodologies, they feel comfortable with it. Whether cloud is complex or not, I would say it is not. Why? Because if you get used to certain services, you would realize that storing or moving your data to cloud is actually a lot more easier than your normal infrastructures or your previous or traditional infrastructures is what I would say. So whether cloud is complex, I would say no. As we move into the demo part, probably we would be talking about this pointer, or once I give the demo, probably you would have a clearer picture how easy it is to actually move your data to cloud. Not eco-friendly. Now, this might sound out of the blue. I mean, you might wonder, this is not a sociology session, so where did this point come in from? I mean, not eco-friendly. Yes, what people assume is the fact that the large amount of data is being stored on these platforms. So we have huge amounts or huge numbers of data centers which are big in size, and they consume a lot of electricity. So there is power wastage, electricity wastage. Well, that is a myth again. First and foremost, the fact that we are getting a centralized storage somewhere, that means most of the data would be stored there. So yes, you're automatically saving out on your power consumption when you talk about it from a global or an eco perspective. The other thing is, I would not want to point out a particular cloud service provider, but when you talk about GCP, that is Google Cloud Platform, they normally provide their cloud services at a very affordable price. Now, why is that? The reason for that is they've actually put in a lot of effort into the research part, where they've researched a lot on how they can actually minimize the cost. And how did they do it? They basically ensured that the amount of power that is consumed by their resources, they've tried and optimized that amount to a minimum amount so that they are charged less, and in a way you are charged less. So if they're optimizing that particular process, obviously you're consuming less amount of electricity. So whether it's eco-friendly, definitely it is eco-friendly. Zero downtime. Again, there's no such thing as zero downtime. Now, the fact that I'm talking about cloud storage does not mean that I tell you that it has zero downtime and you're completely secure. No, there is a possibility that there might be a downtime. The fact that cloud ensures that this downtime is very less, now that is a plus point. What cloud also does is it ensures that there is a disaster recovery, and there is always a backup of your data or your resources. So even if something goes down for a very little time, I mean, normally it happens for a very less time if it does happen, and it happens very rarely, but even if it happens, care is taken that nothing harms your resources or your data. So zero downtime, no, that is not true, but definitely downtime is taken care of when you talk about cloud storages. There is no need of cloud storage. Okay, this is one of the biggest myths. Whether people agree or not, if you go back like 10 years from now, probably people did not know a lot about cloud computing, but with time, people are actually moving to cloud. And if you take a look at recent statistics, they would agree as well. I mean, people would be wanting to switch to cloud in near future. And the reason for that is there are quite a few services, quite a few facilities that cloud gives you. And that is why people are moving to cloud. And if you do move to cloud, you'll be using cloud storage inevitably. So yes, that is going to happen. And if you think that there is no need for cloud storage, definitely in near future, I would assure you that even you would be moving to cloud. So guys, these are some of the major myths. There are some other myths as well. As we move further, not worry, we would be discussing that as well in some other pointers. So let's just go ahead and talk about some of the benefits of using a cloud storage for data storage, or basically using cloud for data storage. So what are the benefits of this thing? Now, I purposely kept this pointer for the later half, and I first discussed the myth because these pointers would definitely help you understand some of those myths better. Now, your cloud platform is customer friendly. What do I mean by this? Well, first and foremost, when you talk about cloud storage, what you're able to do is you're able to scale up your storage, scale down your storage, keep it secure, monitor it, and you can ensure that there is constant backup taken of your data. So when you talk about it from a security perspective, it is secure as well. Plus, what cloud service providers do is they've had so many services that are there in the market. You talk about any popular cloud service provider, they have a lot of services that are made available. What do these services do is they ensure that your functioning on cloud platform is very smooth, and same is for cloud storage as well. You can utilize various services which ensure that your functioning or your working on cloud becomes easy. Again, which I've been reiterating for a while now, that I would be talking about these in future slides. Don't worry, as we get into the demo part, you would understand how user friendly these cloud platforms are. Security. Now again, this is an important point. When you talk about cloud platforms, cloud storages, are they secure or not? Definitely they are very secure, and there was a time when people believed that these platforms were not secure to a greater extent, and that doubt was understandable. I mean, if there is something that is new in the market, you tend to doubt that. But if you talk about cloud platforms, these platforms are actually more secure than your on-premise or your traditional architectures which people are used to using. The reason for this is, if you talk about cloud service providers, let's talk about AWS, that is Amazon Web Services in this case. What it does is it gives you a shared security model. Now what do I mean by this? You have service level agreements where you and your customer, or maybe the customer and the AWS providers, they basically come to a term where they decide as in what kind of security or what kind of principles are to be implemented on the architecture, and you can take control, as in you can decide what accesses do you want to give to the vendor and what are the accesses you want to keep to yourself. So when you do combine this approach, it ensures that security is at the optimum, and you get to be, or you get to take control of your security as well. So yes, if you talk about cloud storage being secure or not, yes, it is very secure. To name some, we have S3 in AWS. It is highly durable and it is highly reliable. So when you talk about disaster recovery and durability, it is almost up to there. And as I've already mentioned, not everything is 100% when I talked about the downtime, or the downtime part. So yes, not everything is 100%, but when you talk about security and durability, when you talk about S3 in particular, it is 99 point some 6 or 7 times 9, that is 99.9999999 times durable. So that does make your system very secure. Another benefit, guys, it is pocket friendly. Now if you talk about cloud service providers, whether it's storage, whether it's compute service, database services, all these services, you can actually go ahead and use these services for rental basis. It's just like paying for your electricity. I mean, if you're using a particular service, you'd be paying for that service for the duration you use that service, and you'd be paying only for the resources that you've used. So it is pay as you go kind of a model where you pay only for the resources you use and only for the time duration you use. So whether it's pocket friendly or not, yes, it is pocket friendly. And as you move further, I mean, if you're using more storage, the cost again, it cuts down to a greater extent. So it is already cheaper, and if you decide to scale up, it would be more cheaper, or it would be cheaper is what I should say. So yeah, these are some of the benefits. Now if you talk about cloud computing and storage, again there are other benefits like, as I've already mentioned, durability, scalability, and various other benefits, but these are some core ones. I would not want to get into the details because I wish to keep everyone on the same page, for people who have been attending this session for the first time, and for people who probably know a bit about cloud computing. Again guys, if some of the terms that I'm talking about in this session, you feel that these terms are fairly new for you and I'm probably going at a faster pace, I would suggest that you actually do go ahead and check into the other sessions that we have on our YouTube channel, because we've talked about a lot of stuff there. I mean, other cloud services, what cloud computing is, what cloud service providers are, what are different service models, and quite a few other videos and sessions, to be honest. So I would suggest that you go through those sessions as well. And I'm sure that by now many of you might have been wondering as in whether this session would be recorded and a copy of it would be available to you people or not. Not worry, most of our sessions, they go on YouTube, so probably a copy of it would be there on YouTube. And if not, you can actually share your email IDs as well. If it does not go on YouTube, somebody would share a copy of the session with you people. So guys, if I'm happening to go a little faster than what you're expecting, do not worry, you'd be having a copy of this as well. But for now, just try to keep up with the pace that I am going with, and I'm sure that by the end of this session, we all would be good. So guys, what are some of the cloud storage practices that you should take care of? Now, these are the practices that should concern somebody who is planning to move to cloud. Again, if you are a newbie and you're just here to practice, we are not talking about you in particular, but these pointers are important for you as an individual as well. But I'm talking about it from more business perspective or more industrial perspective. So if your organization is planning to move to cloud, definitely these are some of the practices or pointers that you should take care of. So first and foremost, scrutinize SLA. So as I've already mentioned, you have SLAs where your service providers or your vendors basically come to a term where you actually go ahead and decide on particular rules, as in, okay, these are the terms and these are the services as a vendor I would be providing you people, and you as a customer, you agree to certain terms, as in, okay, this is what you would be giving us and this is what we would be paying you. So there are certain pointers that you should consider while you're actually signing your SLAs. One thing that you need to understand is when they say that you would be, this is the base charge, try to understand how the charges would be when you decide to scale up and stuff like that. Other thing that you need to consider is, I've talked about downtime, right? So normally you have SLAs where people talk about the stuff that there won't be an outage which is more than 10 minutes. So yes, I mean, this sounds fairly good, right? So in an hour's time, this is a hypothetical example. Do not consider that there would be a downtime of 10 minutes. This is for your understanding. Let's assume that there's a downtime of maybe 10 minutes in an hour's time, which is too high for now, but let's assume that. So what a service provider would claim is, if there is a downtime once, probably this is what the charge would be. But if it goes down after that, probably you get some more concession discount and those kind of things. So if there is an SLA where you say that it is 10 minutes, and what if there were two downtimes of 99 minutes in an hour? And that is fairly close, right? So you've been robbed of your right. So that is what I'm trying to say. I mean, if you do actually go ahead and have particular SLAs, make sure that you consider in right points that suit in your business as well. Follow your business needs. Again guys, storage, as we move further, we will be discussing what are the different kinds of storages. So when you talk about cloud service providers, they provide you n number of storages, or n types of storages is what I should say. So depending upon the business you're dealing with, the kind of data that is generated, you should be able to choose a proper storage for your requirements. I mean, whether you're dealing with the real-time data, whether it's stationary data, archival data, based on that, you should be able to actually go ahead and set up your cloud storage. Also, you need to understand, as in, okay, this is the data I would be putting in, and these are the integrations I would be needing because I'm using these kind of tools. So are those compatible with my cloud platform? So probably you need to consider these pointers as well. And if you follow these rules, probably your business would end up saving a lot of money. Now, there have been use cases where businesses have actually gone ahead and saved lakhs of dollars, thousands of dollars. So yes, considering these pointers, understanding your business also becomes important. You need to ensure that the security which you are actually managing or monitoring is defined properly. I've already mentioned that if you talk about cloud service providers, they let you have an SLA where you both come to a similar agreement. So understand the security, what are the accesses that you have, what are the accesses you want to give, what kind of data are you dealing with, and based on that, probably you can come to terms when you're actually moving to cloud. Plan your storage future. What we are trying to say here is plan the future of your storage. Again, do you need to scale up in near future? What are the peak times that you can expect and stuff like that? So when you initially actually set your storage up, probably you would be in a much better position to scale up. I'm not refraining from the fact that cloud providers are already scalable, but just to be secure, you can do that. When you talk about cloud providers, mostly they give you an option of scaling right away or instantly, but still having an understanding of how much storage you need, where you're gonna move in like 2 years, 3 years time, probably having an understanding of all those things would definitely hold you in a much better position. Be aware of hidden costs. Again, guys, I've talked about the first SLA, right? So it is similar to that. Understand what you're paying for, how much are you paying for. It is a pay-as-you-go model, but having an understanding of which services would cost you how much would help you in forming proper SLAs or having proper policies for your storage. So these are some of the do's and don'ts of cloud storage, guys. Again, if you need more insights on different services as well, we have a video or a session on YouTube which is called as AWS best practices. You can take a look at that as well, where we talk about different services and how can you actually perform certain tasks which would ensure that you are in the best possible position. So guys, we've talked about quite a few things. We've understood what cloud storage is. We've understood what are the benefits, what are some of the myths, and what are some of the practices that you should take care of. Now let's take a look at some of the different cloud service providers that provide you with these services. And once we are done with it, then probably we would move into the demo part. So guys, there are quite a few cloud service providers which also provide you with storage services. We have Google Cloud Platform, which is one of the leading ones. DigitalOcean, probably it's everywhere, whether you search for internet ads, companies, it's there. Terramark, again, this is a popular cloud service provider. IBM is there in storage or in cloud for a very long time, guys. Now if you go way back, I happen to attend a session where I believe it was AWS and some reInvent session where I do not remember the name of the speaker, but that person made a very valid point. He said that in 1980s he remembered, or he happened to visit a facility. I believe it was IBM's. I'm not sure whose. I think it was IBM's. So he said that they had this huge machine which was for storage. I mean, it looked very cool in 1980s, a huge machine, and it was very costly. It was like somewhere around thousands of dollars, and the storage space was 4 MB. Yes, for 4 MB the cost was thousands of dollars. So you can understand how far storage has come, how far cloud has come. And yes, IBM, it has been there. I mean, it has been there since then. So if you talk about IBM, if you talk about Google Cloud Platform, these are principal cloud service providers. Then you have Microsoft Azure. Now if you talk about current market, I mean, if you go by the stats alone, Microsoft Azure and AWS, these are the leading cloud service providers. AWS is way ahead of all the other cloud service providers. I'm so sorry. But if you talk about Microsoft Azure, it is actually catching up with Amazon Web Services, and recent stats show that Microsoft Azure is doing fairly well. So yes, these are some of the popular cloud service providers, and more or less all of them have good storage services as well. But as I've already mentioned, Amazon Web Services is one of the best in the market, and in today's session we would be understanding some of the popular cloud services that Amazon Web Services has to offer to you. And when I say popular services, I would be focusing on storage services specifically. So guys, let me switch into the console and we can discuss some of these services there and directly move into the demo part. So yes guys, I hope this screen is visible to you people. This is how the AWS management console looks like. So again, for people who are completely new to cloud platform, let me tell you that what Amazon Web Services or most of the other cloud service providers do is they give you a free tier account. What they're trying to say here is you use our services for free for a short duration of period, and if you like, then go ahead and buy our services. So these services are actually made available to you for free for one complete year. Yes, there are certain limits or bounds on these services. So if you exceed those limits, you would be charged. But if you stay in the bounds or limits, you won't be charged. And if you talk about exploring these services, these limits or free tier services are more than enough. So again guys, if you are completely new, you should come here, that is Amazon Web Services Management Console, create a free tier account. It is a very simple process. Put in certain details, where you work, why do you want to use these services, your basic details, and then probably you would have to enter your debit card or credit card details. Don't worry, they won't charge you. but this is for the verification purpose. And again, if you're worried about whether you would be charged or an amount would be minus from your credit amount that or your credit card, that does not happen, guys. AWS gives you notifications saying that okay, you've been using these services and probably you might be overusing some of your services. Also, you can set in alarms where if you reach a particular limit, after that you can actually go ahead and ensure that there is an alarm so that you do not exceed the free tier limit. So yes, once you do have an account, you can avail all these services that are here, guys. So let's just go ahead and take a look at the console a little and just jump into the storage services right away. So when you click on this icon here, storage, guys, or services rather, you get access to all these services. As I've already mentioned, AWS provides you quite a few services. There's somewhere around 100 services, guys, and they cover different domains. You can see the domain names at the top: compute, robotics, analytics, business applications, storage. You have management and governance, security, identity management, and all those services, guys. So there are n number of services, whether it's migration, whether it's media services. You have services for almost everything. So guys, we would be focusing on the storage services. Before we go there, this is one thing. Probably you can select a region where you want to operate from. That is, you want to create your resources in this particular region. You can always have this option of using it. So what is a region, guys? Your data is based in a data center, right? I mean, your data is copied somewhere. So if you are using those resources, probably your data would be fetched from that particular location. So you can choose a region probably which is close to you if you like, or if your business is located somewhere else, probably you can choose that region as well. So you need to go through the list of regions that are available and accordingly make a decision. Now, this being a simple demo, guys, I would be sticking to Ohio basically. So let's just go ahead and jump into the cloud services part, and let's talk about storage in particular. So guys, if you take a look at the storage services that are here, you can see that these are the storage services that AWS has to offer to you. We have S3, we have EFS, you have FSX, you have S3 Glacier, Storage Gateway, and AWS Backup. Let me just try and throw some light on some of these services, and probably we would just go ahead and get into the demo of one or two of these services at least. So guys, when you talk about S3, it is simple storage service. So that is SSS. Now this storage is basically object bucket kind of a storage. I mean, your container where you put in your data, where you store your data, is called as bucket, and your data or your files are basically stored in the form of objects. Let's just go ahead and quickly create a small bucket. This would be a very small introduction to this service. Let's just go ahead and do that. So when you click on this icon, guys, that is S3, it redirects you to the S3 console, guys, where you can actually go ahead and create a bucket. I've mentioned the pointer that there are certain services that make your job very easy with cloud service providers. And when you talk about storage services, it is no different. I mean, there are services which ensure that your job is fairly easy. So let's just go ahead and see how easy it is to work with S3. If you wish to create a bucket, guys, if you wish to create a container, it is very easy. Just go ahead and click on create bucket and give it some name, say sample for today maybe. Guys, I'm very bad at naming conventions, but please forgive me for that. Again, the names here should be unique. I mean, if the name is taken somewhere else, probably you cannot rename. I mean, you cannot use that name again. So yes, ensure that your name is unique, and probably, guys, you should try and name your buckets in such a way that those are more relatable. Say for example, if you have a bucket for maybe creating a particular application, so maybe bucket for that application or something like that, so that you have a hierarchy, and in that way you can assign IAM users or access to those buckets in a particular order, because you would not want all your users to have access to that bucket, right? So naming convention becomes very important. So just go ahead and say next. Keep all the versions, guys. Versioning becomes very important. Again, let's not get into the details, but let me give you a small idea what happens here. Versions, that means each time my buckets get updated, probably I would want a version or a copy of it, and I would want the latest one. So when I version it, it maintains those copies, and if I need to go back, I can actually go back to a particular level or a benchmark which I set the previous time. In this case, let's stick to basic one, and I do not want any logging details either, so just next. Again, guys, there are certain public accesses which have been given, so permissions and access. We would talk about that, do not worry. For now, just say next. And I would say create a bucket. And guys, the bucket is already ready. I mean, my container is already ready. So I can just go ahead and probably open this bucket and put in a file if I want. And that too is very easy, guys. I say upload. And if I'm connected to my local system, I just say add files. Let's pick this random file which uses this name, and I say upload. And there you go, guys. The file is already there. I mean, we've created a bucket, a container, we've put in a files. It's as simple as that. Permissions, as I've already mentioned. Now let me talk about this point. I skipped this point, right? So let's discuss this a little. So guys, security is something that you can handle. So you would decide, or you need to decide, what are the users that need to access a particular bucket. Suppose your organization has different people working on different teams. I mean, you have somebody who is a developer, there's somebody who's working on maybe the administrative part, or maybe on the designing part. So for particular bucket, you have particular data, so you can decide who gets to access what. So setting in policies becomes important. You can create your own policies as well. Initially we saw that certain public accesses were restricted to this bucket. I said let's skip that for now. So when I say that public access is restricted, that means not any public policy can come in and dictate terms here saying that use this policy. Why? Because there is a restriction. This is a private bucket and not anyone can use it. So guys, when you talk about S3 in particular, you can create buckets, you can have backups, you can have your EBS backups also moved here. You can move your data from here to Glacier. We would be talking about Glacier, do not worry. You can have your Elastic Beanstalk applications, your PaaS applications, and the data can be stored in your S3 buckets. You can have your CI/CD pipelines, and the data can be moved again to the S3 bucket. Now this is highly durable and highly reliable source of storing data, and it gives you fast retrieval of data as well. Let's go ahead and try to understand some other services as well, guys. So when I come back here and I see EFS, Elastic File Storage, or system rather. So here basically in this storage you can store files. Yes, we are talking about data that is in the form of files, and if you wish to connect it better with the network, you can go for EFS as well. Guys, then you have something called as S3 Glacier. Yes, we talked about S3, right, where data is durable and it can be accessed very quickly. S3 on the other hand lets you store archival data. Let me tell you what archival data is first. So guys, when you talk about archival data, basically what happens with archival data is you're dealing with a data that you do not need to use every day. Let me give you an analogy. I'm not sure whether you would be able to relate to that. So guys, your birth certificate. Now I belong to India, and we've been taking up a lot, but we still have a lot of data that is in the form of papers. Even if you go to hospitals, at times you request for a birth certificate, it might take days for you to get that birth certificate. Why? Because there is some person who will be going through all those documents and giving you that document. This is just an example, do not relate it like very seriously, but yeah, so it might take a couple of days, right? So, and the birth certificate thing, I mean, I might not need birth certificate every day. It might be once in a decade that I might go to a hospital and probably request that particular birth certificate, right? So this is a kind of data probably which I do not need regularly or in real time. So I can compromise a little on the fact that if the person is giving me that data in 2 days time, it's okay, because that does not cost me anything. I can wait for 2 days maybe, but that's not the case. At times you need the data to be retrieved very quickly. So if that is the case, you should store it where? In S3. But if you're fine with this delay, probably you would want to store it in Glacier. Why? Glacier normally takes a longer while to retrieve your data. But the advantage of Glacier is it is profitable because it is very affordable compared to S3. S3 is already affordable. You can check in for the prices. But if you have archival data which you won't be using every day, you can store it here. And the fact that it takes a longer while, it won't cost you. It won't cost you in that perspective of accessing your data in real time, right? So if the data is something that is not needed regularly, you can move to S3 Glacier, right? So what happens is S3, you can actually move in all your data, and then if you realize that there is certain data which you do not need every day, just move it from S3 to S3 Glacier, where the data is stored in archival form and it is or it does not cost you a lot. So again guys, I won't be getting into the demo of S3 Glacier. We have a session on S3 Glacier, or Amazon Web Services Glacier rather, and to do that what you need is you need probably a third-party tool which makes it easier for you to retrieve the data. So I won't be getting into the stuff where I download that tool and show you how it works. It's very simple. Just like we created buckets here, you create vaults there and you probably move in your data and you can retrieve that data. But again, it takes a longer while to retrieve that data. So it is similar to S3, but little different. So yeah, that is S3 Glacier. We've understood what EFS is and what S3 is. Then again guys, you have some other services as well here. If I scroll down, you have your storage gateway, you have your AWS backup as well. So what are these things and what do these things do? Well, storage gateway and AWS backup, basically backup, as it says, you can have backup of your data and you can like save it from going down and stuff like that. When you talk about storage gateway, these are services that let you move your data from on-premise atmosphere or your infrastructure rather, just to help you do that, and those services are your storage gateway services. So guys, we've discussed some of these services. There is something else which is called as elastic block storage. Now elastic block storage, what it does is it lets you create volumes, snapshots and copies of the volume that is attached to your instances. Let's go ahead and take a look at how this works. I mean, there are a lot of pointers to talk about it. So as I move further, I would be discussing those pointers while I also show you how to do it. So guys, when I say EBS or elastic block storage, what it does is it lets me attach some kind of volume to my instance. Now instances, let me tell you what instances are first. Now when you talk about cloud services, they give you compute services where you can spawn instances or spawn temporary servers or servers where you want to host your data. Now each time I won't be going ahead and buying a new machine, right? Instead, what cloud does is it, and what happens? Yes guys, okay guys, I'm not sure whether there was a lag while you were going through this session. What happened is, let me tell you what happened. My connection, the streaming connection to my software which I'm using to stream this session did go down a minute back, and it shows now that it is connected. So I would like to know whether I'm audible to you people or not. If yes, then we can continue with this session guys. Okay, I'm guessing we are fine, so I'm just gonna go ahead and continue with the session. I was talking about instances. Let me talk a little more about it. So when I talk about these servers that are ready to use, basically these servers are something that you can use and you can have some memory attached to it. So what we're gonna do is we're gonna go ahead and launch one instance and understand how memory or how storage works with it. So to do that, we are gonna go ahead and just launch that particular service. It is called as EC2, which is a compute service guys. So here I can actually go ahead and create servers or launch instances in simple words. So let's just go ahead and launch a particular instance. Now I have the freedom of launching both Linux based, Windows based, Ubuntu based kind of instances. So you have the freedom of choosing what kind of instance do you want. This being a simple demo guys, I'm gonna stick with the Windows instance. I'm not gonna show you how to deal with that instance because I've done that in previous sessions. You can take a look at some of those sessions as well guys. Let's just go ahead and launch this particular session, or this particular instance rather. Now guys, this is a Windows instance, and okay, not this. Let me launch some basic one. This is also free tier guys, but yeah, I would want this. Make sure that your instance is EBS backed. So guys, your backing up works in two ways. You can back it up on S3, you can back it up on EBS, that is elastic block storage. Now elastic block storage is important. Why? It lets you create images and volumes. What are those? We'll talk about that once we create this instance. So ensure that for now it is EBS. So if I click on, okay, this is the thing. If I click on this icon, it would give me details what kind of instance I'm launching. When I say T2 micro, it is a small instance which has one CPU and 1 GB of memory for now. And I can just go ahead and say next. Okay. Some of the other details, whether you want a VPC or not, let's not discuss that. And then you get into the storage part, guys. This is the device to which I'm attaching my root volume. So this is the path rather. So I need to focus on this. It is SDA1, guys. That is /dev/SDA1. You need to remember this when you create new volumes. And the types of volumes that you can attach to your instance are these. You have general purpose SSD, provisioned IOPS, and magnetic. Magnetic is something that is getting outdated, probably might be replaced. So these are the few ones. You also have some other kind of volumes that you can attach, but the point that you need to remember is when you talk about having a primary volume, in that case you have only these options because these are bootable, guys. So there are certain other volumes that you can attach. If I attach a secondary volume, you see the options are more. I have HSD for throughput optimization, and then I have cold HSD as well. But this is a basic thing. We're not gonna get into the details of that. We would skip that. So guys, all I'm trying to say is this is the device, this is the size, and probably this is the type of instance or volume, sorry, is that would be attached to my instance. So let's just go ahead and say next, add tags. For now, let's not add anything. And then let me say configure the settings. So guys, when I launch an instance, it says that security is not optimum, but it's okay. I mean, you can assign the ports you want to when you use it for a higher security purpose. And then this is important, guys. For your each instance, you need a key pair, which is a secret way of logging in, or a secure way of logging in, not secret, a secure way. So this is a second place authentication. Once you're logged into your account, you would be needing a key pair if you wish to use this instance. So make sure you create one and you store that one as well. If you have one which you can use, probably you can do that. Else you can just create one. Say new key. I say download. Guys, once you download it, keep it safe somewhere. It is stored in the form of .pem file. So do that. And then I say launch an instance. So guys, once this happens, if I just go back to the EC2 dashboard, probably I can see that there is an instance which is running. For now it is 0. Why? Because guys, my instance is still getting launched. It takes a couple of minutes or 1.5 or 1 minute probably to launch an instance. The reason for this is probably a lot of things happen in the background. I mean, certain network is associated. If you talk about an instance, it needs to communicate with other instances, right? So in that case, probably you need to have a network that lets all these instances connect. So a network is set here basically, and probably all the storage volume is attached, and a lot of things happen. That is why there are certain status checks that your instance needs to go through, and hence it takes a minute or so to launch this instance. So if you take a look at this, the status checks, it says that it is initializing. So if you refresh it, probably it happens at times. So let's just try our luck, see whether it's no, it's still initializing, but guys, we can see the volume that would be attached to it. So let me just come here and rather go here. If I click on volumes, guys, there is a volume that is attached to it. So there is a 30 GB volume. So there is a volume that probably has a size of 30 GB. So it is here already and it is in use. So it would be attached to my instance once it is up and running. So the point I'm trying to make here is what Elastic Block Storage does is it lets you manage all these things. Now there are two ways to manage these things. Either you create a copy of this volume, disable this volume, and then attach the next one, or probably you can directly scale your existing volume or make changes to it right away. So what Elastic Block Storage does is it lets you manage the storages. So again, let me tell you how it works. So when I create an instance, probably it is created in a particular region, right? So in that particular region, say for example, now I'm based in India, so I have a data center in Mumbai. So my instance would be created at that data center, and probably the storage for it would also be there. So there is no latency when I try to use that storage. So this is what EBS does. It lets you manage that particular storage. So how it works is I can create a copy of it. So what this copy does is it serves two purposes. So next time, if I wish to make changes to that storage, I can do that. If this particular storage or volume goes down, I have a backup copy. Again, I can create snapshots as well. Now what snapshots do is basically they let me replicate my instance and the volume that is attached with it. So instead of creating an instance again and again with if I've defined certain properties for my instance, I do not have to worry about defining those properties again and again. I can just create a snapshot, or I can rather create an EMI out of it, which I can store and use it next time if I want to spawn a similar instance. So this is where EBS helps in. It lets you have backups of all these storages. It lets you create copies of it, so even if something goes down, you can work on the copy that you have. So guys, by now our instance would be created. Let's just go ahead and take a look at it. It says it is running, guys, and we've already taken a look at the volume. Let's just create a copy of this volume. To do that, I'm going to go to the actions. My instance is selected already. I can just go to modify and make changes to this volume right away, which is an easier way, but I'm going to show you how it can be done the other way as well, how it used to work previously. So I can just say that create a snapshot, details, sample, and I say create. So guys, a snapshot is created. If I come here, I can take a look at the snapshot. Again, it is pending. Might take half a minute for the snapshot to get created. So I can just come here and replace, or refresh rather. These things at times take a little while. So guys, we would be creating a copy of it. Probably we would be detaching the volume that we've created and it is attached to our instance, and we would replace that with the copy that we are creating now. So once this thing is done and created, we can do that. For some reason it's taking a longer while today. Let's hope that it gets done quicker. Okay, it's still processing. Let's bear with me, or just bear with me meanwhile this happens. Again guys, if I was too fast and if I missed out on certain things, I would like to tell you that you can go through our other sessions on YouTube and probably you'd be in a much better state to understand what has happened here. Again, there was an outage where, not outage, my software did not work properly, the streaming software, and probably there was a lag of a minute or two. So I'm hoping that you all did not miss out on anything that was happening. Meanwhile, just hope that this snapshot gets created quickly. It is still pending and this is irritating at times when it takes a longer while. It's completed guys. Our snapshot is ready. I can just go ahead and say create a volume out of it which I wish to attach. So guys, there are certain details that we need to do. So for that, let's just go back first. Let's go back to the instance that we have. And let's see where the instance is created guys. So as you can see, if you come here, it would give you the details of the place where the instance is created. So it is US East 2C. So when you create a volume, it is necessary that you create it in the same region guys, because as I've already mentioned, the benefits of having it in same region is that you can attach it to your existing instance and it saves you from various latencies. So yep, let's go back to the snapshots part and say create a volume of it. I say create, and then I probably, let's say I want more storage guys, let's say 90. Okay, this is general purpose, it is two-way, so let's go to 2C. If I'm not wrong, it was 2C. Let's just go ahead and create it in 2C and say create a volume, close. So guys, our instance is, or our volume is created successfully. Again guys, now you can take a look at it from this perspective. I have my snapshot here, right? So this snapshot says 30 GB. That does not mean that the snapshot which I took, its size is 30 GB. It says that it was created from an instance whose size is 30 GB. So there's a difference between these two things guys. Understand that as well. So I have a volume which is based in availability zone 2C. I have an instance which is here, and it again is an availability zone 2C. So we can attach to it. Let's just again go back to the volumes part. So guys, I have two volumes. I created this one and this is attached to my instance. Let me just try and remove this first. detach volume. Okay, it's giving me an error. Try to understand why this error is there. Guys, my instance is already running, so I cannot directly remove this volume from here. For that, I would have to select this instance, go to instance state and say stop. So it stops working for now. And once it does, I can attach the volume. So for now, what you can see is there are these volumes here. It is in use, right? So once the instance stops, it would be available and won't be in use. So I can replace it with this instance. So it is stopping. It hasn't stopped yet. So guys, do not worry, we would be done with the session very soon, and once we are done, probably you all would be free to leave. I believe that this session has taken longer than my normal sessions, but yeah, there was a lot of stuff to talk about. We talked about the complete storage services that AWS has to offer to you people, hence this session was so long. So let's just quickly go ahead and finish the stuff. Okay, it has stopped. So guys, I can now go ahead and remove the volume or detach this volume and go ahead and attach the other one. So if I say detach, it would detach. Yeah, see, both are available now. Let's try to attach this volume and say attach volume. Search. This is the instance, guys, which we've created, and you need to give in the device details, which was slash what were the details. Let's just go back and take a look at the details that we're supposed to enter in here. So guys, you need to give in the path that we talked about, which is the drive that we've discussed, right? So that is the path that you need to enter, and then you actually go ahead and say SDA1 slash, and probably you'd be more than good to go. So this is the other thing, I do not remember the other part. So you need to go ahead and put in these details here. If you put in these part details, guys, you can just go ahead and attach your volume right away, and this volume would get attached to your instance. So this is how it works, and you can actually go back and do other things as well. So if I just come here, I have this instance. So what you have to do is you have to actually go ahead and click on this thing. For now it's not working, but if you just come back here or to the volume part, so if you just go to the volumes part, which we were at in the previous slide, you can actually go ahead and attach the volumes. Now here you go. If I just go to instances, probably go back and I say EC2 again. Yeah, if I come back to volumes, guys, you can attach the volumes that are there, you can delete those, and you can do a number of changes that you wish to do. So just go ahead and attach these volumes, and you'd be more than good to actually go ahead and launch your instances or manage the storages that are there. Again, the only thing that I missed out on is the path. I told you to note the path, the device name, right? You just have to go ahead and enter in the device name here, and if you enter in the device name while creating your volume or attaching your volume, your instance would get attached to that, or your volume would get attached to that instance right away. So yes, guys, this pretty much sums up today's session. We've talked about quite a few things here, guys. We've talked about S3 services. We've talked about EBS in particular. We've understood like how to detach a volume, how to attach one. I just did not show you how to attach the volume, but you can do that. The reason I'm not showing you that is I probably lost out on the device name here, which normally comes in here. So before you deactivate your device, make sure that you have this name, and when you do launch or attach your volume to that particular thing, all you have to do is you just go to the volumes part and probably when you say attached to a particular instance, put in that device name there, and your instance would be attached, or your volume would be attached to your instance, and you can just go ahead and say launch or just start this so-called instance again, and you'd be good to go, guys.
So let us just try to understand what the storage exactly is. So guys, when you talk about S3, now it is a simple storage service which is simple or easier to use in real sense. It lets you store and retrieve data which can be in any amount, which can be of any type, and you can move it from anywhere using the web or internet. So it is called as storage service of the internet. What are the features of this particular service? It is highly durable, guys. Now, why do I call it durable? It provides you durability of 99.999999, some 11.9. Now, when you talk about that amount of durability, it is understandable how durable this service is. What makes it this durable? It uses a method of checksum where it constantly uses checksums to analyze whether your data was corrupted at a particular point. And if yes, that is rectified right away. And that is why this service is so durable. Then it is highly flexible as well. As I've already mentioned, S3 is a very simple service, and the fact that you can store any kind of data, you can store it in any region or any available region is what I would mean by the sentence. It makes it highly flexible to store the data in this particular service, and the fact that you can use so many APIs, you can kind of secure this data in so many ways, and it is so affordable. It meets different kinds of needs, thus making it so flexible. Available. Is it available? Yes, definitely it is very much available. As we move into the demo part, I would be showing you which regions basically let you create these kind of storages and how can you move and store data in different regions as well. So if you talk about availability, yes, it is available in different regions, and the fact that it is so affordable, making it available becomes all the more easy. Cost efficient, yes. Now to start with, we normally do not get anything for free in life, but if you talk about S3 storage, AWS has a free tier which lets you use AWS services for free for 1 complete year. But this happens in certain limits. Now, when you talk about S3, you can store 5 GB of data for free, at least to get started or get used to the service. I believe that is more than enough. And what it also does is it lets you have somewhere around 20,000 get requests and somewhere around 2,000 put requests as well. So these are something that let you store and retrieve data. Apart from that, you can move in 15 GB of data every month outside of your S3 service as well. So if you're getting this much for free, it is definitely very much affordable. Also, it charges you on pay-as-you-go model. Now, what do I mean by this? Well, when I say pay-as-you-go model, what we do here is we pay only for the time duration that we use this service for, and only for the capacity that we use this service for. So that is why as you move along, if you need more services, you would be charged more. If you do not need more amount of the service, you won't be charged to that greater extent. So is it cost efficient? Definitely it is. Scalable? Yes. That is the best thing about AWS services. Most of them are scalable. I mean, you can store huge amount of data, you can process huge amount of data, you can acquire huge amount of data. If it is scalability that is your concern, you do not have to worry about it here, because even this service readily scales to the increasing data that you need to store. And the fact that it is pay-as-you-go model, you do not have to worry about the cost factor as well. Is it secure? Definitely it is. Now you can encrypt your data. You have various bucket policies as well that let you decide who gets to access your data, who gets to write data, who gets to read data. And when I said you can encrypt your data, you can actually go ahead and encrypt your data both on client side and on your server side as well. So is it secure? I believe that answers the question on its own. So guys, these were some of the features of Amazon S3. So guys, now let us try to understand how does S3 storage actually work. Now it works with the concept of objects and buckets. Now bucket, you can think of it as a container, whereas an object is a file that you store in your container. These can be thought of as AWS S3 resources. Now, when I say an object, basically object is your data file. I've already mentioned that you can store any kind of data, whether it's your image, whether it's your files, docs, whatever it is. These are nothing but your data, and this data comes with metadata. When I say an object, it is combination of your data plus some metadata or information about that data. What kind of information? Basically, you have the key, that is the name of the file that you use, And version ID is something that tells you which version are you using. As we discuss versioning, probably I would talk about version ID a little more. But meanwhile, I believe this is more than enough. Your objects are nothing but your files with the required metadata. And the buckets, as I've already mentioned, these are nothing but containers that hold your data. So how does it work, guys? Well, what happens is basically you go ahead and create buckets in regions and you store your data in those regions. How do you decide what buckets to use, what regions to use, where to create the bucket and all those things? Well, it depends on quite a few factors. When I say I have to create a bucket, I need to decide what region would be more accessible to my customers or to my users, and how much cost does that region charge me, because depending upon the region, your cost might vary. So that is one factor that you need to consider. And latency as well. I mean, if you put your data in an S3 bucket that is far away from you, fetching it might cause high amount of latency as well. So once you consider these factors, you can create a bucket and you just store your objects. When I said version ID key, actually your system automatically generates these features for you. So for you, it is very simple. Create a bucket, pick up your object, put it in it, or just go ahead and retrieve the data from the bucket whenever you want to. So I believe this gives you some picture about what S3 is. Now, let me quickly switch into the demo part and let me give you a quick idea or quick demo as to how S3 works so that it is not too much theory for you people. So guys, what I've done is I've actually gone ahead and I've switched into my Amazon Management Console. Now, as I've already mentioned, AWS gives you a free tier for which you can use AWS services for free for 1 complete year. Mine is not a free tier account, but yeah, if you are a starter, you can create a fresh account. You just have to go ahead and give in certain details. All you do is you just go to your web browser, search for AWS free tier and sign in with the required details. They would ask you for your credit card or your debit card details. Enter any one of those for the verification purpose. And you can actually go ahead and set up alarms as well, which would tell you as in, okay, this is the limit to which you have used the services. And that way you won't be charged for access of data usage or service usage. Having said that, guys, this is about creating an account. I believe it is fairly simple. You can create an account. Once you create an account, guys, this is the console that would be available to you. What you have to do is you have to go ahead and search for Amazon S3. If you search S3 here, it would kind of redirect you to that service page. So guys, as you can see, this is the company's account probably. Somebody uses it in the company and they have their buckets that are already created. Let's not get there. Let us just go ahead and create our own bucket and just go ahead and put in some data into it. It is fairly simple, guys. I've already mentioned it is very simple to use kind of service. All I have to do is click on create bucket and enter in name for some bucket. Guys, now this name is unique. It is globally unique. Once you enter a name for the bucket, you cannot use the same name for some other bucket. So make sure you put in valid name. And the fact that I use the term global, something reminded me to be explained of. So guys, as you can see, if I go back here, I want you to notice this part. So guys, when you are into the management console or you open any service, by default, the region is North Virginia. Okay, so if I create a resource, it would go to this region. But when I select the service that is S3, you can see that this region automatically goes to global. That means it is a global service. It does not mean that you cannot create bucket in particular regions. You can do that, but this service is global is what they're trying to say. So let us just go ahead and create the bucket. Let us call it today's demo. You cannot use caps, guys. You cannot use some symbols. So you have to follow the naming convention as well. Today's demo. Sorry, I'm very bad at naming conventions, guys. I hope it is okay. Let it be in US East. You can choose other regions as well, guys, but for now, let it be whatever it is. So I'm gonna stick to North Virginia. There are 76 buckets that are being used. Let us just say next. Bucket name already exists. So this was already taken, guys. See, so you cannot use it. Let's call it, say, Ramos bucket 13113. Okay, do you want to keep all the versions of the object? We will talk about what versions are. Okay, guys. Meanwhile, you just bear with me. I'm just going to go ahead and create a bucket. Create a bucket. And there you go, guys. I'm sure Ramos bucket should be here somewhere. Here it is. If I open it, I can just go ahead and create folders inside it, or I can directly upload data. So I say upload, select a file,
Let's just randomly select this file. It is Van Rossum, founder of Python basically. Let's just say next, next, next. And the data is uploaded, guys. You can see the data being uploaded and my file is here for usage. So guys, this is how object and bucket kind of stuff works. You can see that this is the data that I have. If I click on it, I would get all the information. What is the key? What is the version value? For now, let's not discuss version, but this is the key or the name of the file that I've uploaded. So it is fairly clear, right guys? So let us just quickly switch back to the presentation and discuss some other stuff as well. Now guys, another important topic that is to be discussed here is S3 storage classes. Now we've discussed how the data is stored or how buckets and objects work. But apart from that, we need to discuss some other pointers as well. As in, how does AWS charge me, or what kind of options do I have when it comes to storing this data? So it provides you with three options, guys: standard, infrequent, and glacier. Let me quickly give you an explanation to what do these storage classes mean and what all they offer to us. When I say standard, it is the standard storage which gives you low latency. So in case if there is some data that needs to be fetched right away, you can actually go ahead and use standard storage. Say for example, I wish to go to a hospital for certain kind of checkup. So in that case, my details would be entered in. And the fact that I'm getting myself checked in a hospital or diagnosed in the hospital, what happens is this data is important, and if it is needed right away, it should be available. So this kind of data can be stored in your standard storage where the latency is very less. The next we have infrequent access. Now what do I mean by that? Now in this case, my latency period has to be low because I'm talking about data that I would actually need anytime if I want to. But when I store this data for a little longer duration, all I want is this data to be retrieved quickly. Say for example, I get a particular report or a particular test done. So in that case, I would actually go ahead and submit my details, or say for example, my blood samples, but I need this information maybe after 3 days. So what happens is, in this scenario, I would want to store this data for a longer term, but the retrieval should be faster here. In the first case, that was not the case. If I needed that data right away, and if I wanted it to be stored for a very short duration, I would use standard. But if I want to store it for a longer duration and I want a quick retrieval, in that case, I would be using infrequent access. And finally, I have Glacier. We have already discussed this. Here, your retrieval speed is low and the data needs to be put in for a longer duration. And that is why it is more affordable. If you take a look at the stats that are there in the image above, you can see that minimum storage duration is nothing for standard. For infrequent, it is 30 days, and for Glacier, it is 90 days. If you take a look at latency, it is milliseconds, and 4 hours. So that itself explains a lot of stuff here. So what are storage classes and what do they do? I believe some idea is clear to you people. Again, as we move into the demo part, we would be discussing this part as well. And we would also discuss expiration and transition that supports these terms. But let us move further and try to understand something else first. Versioning and cross-region replication. Now guys, when I say versioning, I'm actually talking about keeping multiple copies of my data. Now, why do I need versioning and why do I need multiple copies of my data? I've already mentioned that AWS S3 is highly durable and secure. How is that? Because you can fix the errors that are there, and you can also have multiple copies of your data. You can replicate your data. So in case if your data center goes down, a copy of it is mentioned or maintained somewhere else as well. How is this done? By creating multiple versions of your data. Say for example, an image, I store it in my S3 bucket. What happens here is there is key, the name is same, image, and version is some 33333, right? Now take a look at the other image. If I actually go ahead and create a copy of the first image, its name would remain same, but its version would be different. So suppose both of these images, they reside in one bucket. What these images are doing is they are having multiple copies or giving me multiple copies. Now in case of image, not a lot would change, but if I have doc files or data files, in that case, versioning becomes very important, because if I make changes to particular data, if I delete a particular file, a backup should always be there with me. And this is where versioning becomes very, very important. What are the features of versioning? By default, versioning is disabled when you say, or when you talk about S3, you have to go ahead and enable this versioning. It prevents overwriting or accidental deletion. We've already discussed that.
you get non-concurrent version by specifying version ID as well. What do I mean by this? That means if I actually go ahead and create one more copy of the data and store it, so the latest copy would be available on top. But I can go to the versions option, put in the ID that belong to the previous version, and I can fetch that version as well. So what is cross-region replication? Now, guys, we've discussed versioning. Let us talk about another important topic, that is cross-region replication. Now, when you talk about S3, basically what happens is you create a bucket in a region and you store data in that region. But what if I want to move my data from one region or from one bucket in one region to other bucket in other region? Can we do that? Yes, cross-region replications let you do that. So what you do is you basically go ahead and create a bucket in one region, you create another bucket in another region, and probably you give access to the first bucket to move data from itself to the other bucket. So this was about versioning, this was about cross-region replication, and I believe we've also talked about storage classes. Let me quickly switch into the demo part and discuss these topics to little more detail. So guys, moving back, what we have done is we've actually gone ahead and created a bucket already, right? When you talk about what was the name of the bucket, it was Remos, if I'm not wrong. Yep. So if you click on the bucket name, Remos, what it does is it basically shows you these details, guys. Now you can see that your versioning is disabled, right? So if I click on it, I can actually come to this page and I can say enable versioning. That means a copy of the data that I create is always maintained. So if I go to Remos bucket, or I just move back, okay, this interface can be a little irritating at times. You have to move back and forth every now and then. So guys, there is a file which we have stored. You can just take a look at this date first. It says that it is 2:35. That was the time when the object was moved. Let me just say that upload the same file. This was the file we uploaded. I say next, 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 upload. So guys, this file is getting uploaded. You can see the name of the file is still same. We have only one file here. Why? Because it was recently modified at 245. From 225 to 235, it got changed to 245. So it is fairly clear, guys, what is happening here. Your data is getting modified. And if you wonder as in what happened to the previous version, don't worry. If you click on this show option, you can see that both of your versions are still here, guys. This was created at 235 and at 245. So this way, data replication and data security works much better. So you can secure your data, you can replicate your data. So in case if you lose your data, you always have the previous versions to deal with. How does the previous version thing works? So guys, what happens is if I delete this file, what Amazon S3 would do is it would set a marker on top of this file. And once I delete it, if I search for that ID won't be available. Why? Because the marker has switched to the next ID now. So whatever I want to do, I can do with the next ID as well. So guys, one more thing that you also need to understand here is what happens to the file. I mean, I've actually deleted a file, but a version is there with me. Can I delete all the versions? Yes, you can specify the ID and you can delete all the versions that you want. You can also do one thing, that is you can set a particular life cycle for your files. When I say life cycle, you can decide as in, okay, now I have a file in standard storage. We've discussed these storages, right? Standard storage, infrequent, and glacier. What you can do with your lifecycle management is you can decide as in, okay, for a particular time duration, I want this file to stay in standard. Maybe after a while, I want to move it to infrequent, and after a while, I want to move it to glacier. Say, for example, there is certain data which was very important for me, but having used that data, I don't want to use it for next few months. So in that case, I can move to the substitutes or to the other storage classes where probably I won't be needing to use that data for a longer while. And doing that, I won't be paying for this data as I used to pay for the standard, because standard is the costliest of the three. So let us quickly see, can we do that, or how does it work at least? If I just go back, this is my file. I can actually just go ahead and switch to management. In that, I have the option of life cycle. If I click here, there is no life cycle. Add a life cycle. You can add a life cycle rule as well, guys. New, let me call it new, and let me say next. It asks me what do I want to do. You can add rules in lifecycle configuration to tell Amazon S3 to transition objects to another storage class. There are pre-request fees.
when using lifecycle to transition data to any other S3 or S3 Glacier storage. So which version do I wish to use? Current, I can say yes. Add transition, and I can select transition to this tier when after 30 days. And if I say next, it would agree. Expiration, you can select other policies as well. So guys, when I say transition, first thing what it does is it tells me what time to transition to which storage class. And expiration, it tells me when does this expire. So I can decide when to clean up the objects and when not to. Let's not do that for now. Let's just say next. Next. So guys, what will happen here is after 30 days, my data would move to standard 1A storage. So you can actually go ahead and decide whether you want to move to Glacier. In that dropdown, you had more options as well. I did not show you that, but it is pretty understandable. You can move to Glacier as well. So this is about life cycle, guys. One more thing, you have something called as replication. You can add replication as well if you wish to replicate your data. Cross-region replication. I believe, guys, I do not have access to do that because I'm using someone else's account for now. But let me just give you some idea as to what you can do to replicate your data. You can just go ahead and click on Get Started. So replication, to remind you people, it is nothing but a process of moving your data from bucket in one region to other bucket in some other region. So for that, I need to select a source bucket. So let us just say that this is the bucket that I have. Next. Now guys, in my case, I haven't created the second bucket. What you can do is you can just go ahead and create one more bucket. Once you create the bucket, you can select the destination bucket. For now, let us just say that this is a bucket that has been created by someone else. I'm not going to transfer data here, but let's just select this for the demo sake. This is the bucket that I have. See, it says that bucket does not have versioning enabled. This is very important point, guys. I showed you how to enable versioning, right? If you select the bucket, there is an option on the right side saying versioning. You can actually go ahead and enable versioning there. So once you enable versioning, you would be able to use this bucket. Do you want to change the storage class for the replicated objects? If you say yes, it would give you the option of selecting what storage class do you want to select, right? If you don't have to. You can say next. You have to enter an IAM role. If you do not have any, you just say create a role and then the rule name. In this case, I do not have any details about this and I don't want to create a role because this account does not belong to me. Sorry for that inconvenience, but you can actually go ahead and select create a role and just say next. And I'm sure that you can actually go ahead and your bucket starts working or your cross-region replication starts working. What happens after that is once you store your object in a particular file, you can actually move that object, not in a particular file, in a particular bucket. You can move that data from that bucket to the other bucket. And a copy of your data is maintained in both the buckets that you use. So this is what cross-region replication is, guys. I believe that we've discussed what are storage classes, we've discussed what is cross-region replication, and we've discussed versioning in general. Let us quickly move back to the presentation and discuss the remaining topics as well. So guys, I've switched into the presentation part. Till time we've discussed how cross-region replication works, we've discussed how versioning works, and we've seen how to carry out that process. The other important topic that we need to focus on is we've known like how to create versions, how to move data from one place to the other. But the thing is, what if I have to move data from a particular location to a location that is very far away from me and still ensure that there is not too much latency in it? Because if you're moving data from one location to a location that is far away from you, it is understandable that it would take a longer while. Why? Because we are moving data from internet. So the amount of data that you move and the further you move, it should take a longer while for that. So how do you solve that problem? You have S3 transfer acceleration. You can do that by using other services as well. We discussed Snowball and Snowmobile as well, but they physically move the data and at times it takes n number of days to move your data. With S3 transfer acceleration, that is not the issue because it moves your data at a very fast pace. So that is a good thing. So how can you move your data at a faster pace? By using S3 transfer acceleration. Now guys, let us first understand what it is exactly. So what it does is it enables fast, easy and secure transfers of files over long distances between your client and S3 bucket. And to do that, it uses a service called as CloudFront and the edge locations it provides you. As I move further, I would be talking about what CloudFront is. Do not worry about it. First, let us take a look at this diagram.
So normally if you are moving your data or directly uploading your data to a bucket that is located at a faraway distance, I mean, suppose I'm a customer and I wish to put my data into an S3 bucket, which is located maybe a continent away from me. So using internet, it might take a longer while. Instead, what I can do is I can use transfer acceleration. So how is it different? Now guys, there is a service called as AWS CloudFront. What it does is it basically lets you cache your data. When I say cache your data, that means you can store your data at a location that is in the interim or that is close to your destination. Now this service is basically used to ensure that data retrieval is fast. Suppose I'm searching for a particular URL. What happens is when I type that URL, a request is sent to the server, it fetches the data and sends it to me. So if it is located at a very far location, it might take long while for me to fetch the data. So what people do is they analyze as in how much requests are coming from a particular location. And if there are frequent and a lot of requests, what they do is they set up an edge location close to that particular region. So you can put your data, you can cache your data on that edge location, and that data can be fetched from that edge location at a faster rate. So this is how edge locations work. What transfer acceleration does is it basically puts in your data at the edge location so that it can be moved to your S3 bucket at a quicker pace. And that is why it is fast. So guys, this was about S3 data acceleration. Let us quickly move into the console part and try to understand how S3 acceleration works. So guys, I've switched into the console. S3 acceleration or data transfer acceleration is a very easy thing to do. I do not remember the bucket name. I think it was Remos something. Okay, if I select this and open it, I can actually go to the properties part. Guys, there are other things that you might want to consider. You can come here and take a look at those as well. For now, I'm just gonna say go ahead and enable transfer acceleration very quickly, or I can use this bucket to transfer my data at a quicker pace by using data transfer acceleration by S3. Again, guys, I missed out on one important point. The fact that we have been talking about buckets and stuff like that, there is something important that I would like to show to you people. First, let us just go back and disable this part. I do not want it to have the transfer acceleration thing going. I just wanted to show it to you people how it is done. I just say go back to suspend it. And one more thing, guys, if you once you actually enable the transfer part and if you upload a file, you can see the difference in the speed. The problem is you need a third-party tool to do that. So you can actually go ahead and download a third-party tool as well. And using that, you can actually go ahead and see how it works. Having said that, I was talking about buckets in general. So let us just go back and go to Remos again. There you go. And I'm going to copy the ARN. I'll tell you why. I've copied the ARN. Now, when I open this bucket, guys, we have quite a few things. Permissions, I talked about security, right? So you can decide public access as in who gets to access your bucket. So guys, you can actually go ahead and decide who gets to access what kind of buckets. Say for example, here in your block public access, you can decide who gets to access what data publicly. For that, you have access control lists. Using these ACLs, you can actually decide who gets to access how. Other thing you can do is you can just go ahead and create a bucket policy and decide who gets to access your bucket or who gets to put your data, delete your data, and do all these things. Let us just go ahead and create a policy. Now you can write your own policy or you can just use a policy generator, which again is a third-party tool. So I want to create a bucket policy for my S3. So let's just say S3 bucket policy. And what kind of effect I want? I mean, do I want someone to access my system or do I want to deny someone from accessing my system? I can decide that. So let's for now just say that I want to deny someone from doing something. And what I want that someone to do is to deny a particular thing for that person for all the objects. I mean, I do not want that person to access any of the objects that is there. So what I say is star. That means nobody should able to do anything to any of the objects that are there in this bucket. So it says star service Amazon S3. What action I want? I want to prevent someone from deleting an object. There you go. And this is the ARN. That is why I copied it. It should be followed by a / and a star. Add a statement. And I say generate policy. So guys, the policy has been generated. I just have to copy it. If I copy this thing and I go back to the console, if I paste it here, I can say save. It's saved. I'll save it again just to be safe. So guys, we have actually gone ahead and let me just go ahead and again go to Remos. So guys, now there is an object here. Let me just try and delete this object. If I just go to the actions part here and I say delete, see the file is still here. Is it the other version? No, it's not deleted. See, there's an error here. If I click on it, it says 100% failed. Why? Access denied, because I do not have the access to delete the object right now. Why? Because I've created a bucket policy, guys. So that is what bucket policies and ACLs do. They let you make your objects or your data more secure. And as you saw in the option, there are quite a few options that you have at your disposal, which you can choose from, which you can mix and match and decide as in, okay, this is what I want to do. I want to probably give someone an access to delete a bucket. I want to give someone an access to do this or do that. So guys, this was about S3 data transfer acceleration, and we've also seen how you create a bucket policy, how you attach it to your bucket and stuff like that. Now let me just go back and kind of brush up this session or finish this session up with a use case so that you can probably understand the topics that we've discussed a little more. First, let us go back to the use case, guys. So guys, I've switched into my presentation console again, and we would be discussing IMDb Media. Now, for people who watch movies, they might know what IMDb is. It is a website that gives you details about movies. They tell you what are the movies that are nice. If you probably select or type a particular movie name, they would give you details about it, as in who were the actors, how was the movie, how was the review, a short snippet explaining you what the movie is about, its genre and stuff like that. Plus they have their own ratings to kind of gauge in the customers even better, as in IMDb being a popular site, and when they say that this movie is this person good or liked by these many people, people normally believe it. So they have that score as well. So if you talk about a website that basically deals with movies, you understand the number of movies that are released worldwide. And if most of them are present here on IMDb, that means that database is huge. But we are talking about data that is being processed in great numbers, great amounts. I mean, when you talk about the data that is here, what is happening here is you have n number of movies that are being released. So if someone searches for a particular movie, it has to go through the database and that data has to be fetched to him right away. So how do you deal with the latency issue? Well, this would answer a lot of questions, or it would sum up a lot of topics that we've discussed here. Let us go through this use case probably. So what happens here is, in order to get the lowest possible latency, all the possible results for a search are pre-calculated with a document for every combination of letters in the search. What this means is, probably based on the letters, you have a document that is created, and it is traversed in such an order that all the data is scanned letter-wise. When you actually go ahead and put forth a query, what happens is, suppose if there is a 20-character letter or a word that you put in, so there are somewhere around 23 into 1030 combinations that are possible. So your computer has to go through these many combinations. What S3 does is, it basically lets you store the data that IMDb has. And once IMDb has stored that data, they use CloudFront again. We have discussed what CloudFront is. They use CloudFront to store this data to the nearest possible location, so that when a user fetches this data, it is fetched from that location. So what happens is, basically, when these many possibilities or combinations are to be dealt with, it becomes complicated. But in practice, what IMDb does is, it basically uses analytics in such a way that these combinations become lesser. So in order to search for a 20-character letter, they basically have to go through 150000 documents. And because of S3 and CloudFront, you basically can distribute all the data to different edge locations and to buckets within hours. And since we are talking about huge amount of data, it is more than terabytes. It is like hundreds, thousands of terabytes of data. So we can understand how much data are we talking about. And S3 actually features or serves a number of such use cases or requirements. So guys, I believe by now you've understood what S3 is. Suppose you are a particular user and you're trying to visit a particular website, and imagine that that website is based somewhere at a very far location. Suppose you're based somewhere in USA, and that website, its server actually hosts or is based in Australia. Now, in that case, when you make a request for particular object or particular image or maybe content, now your request is sent to the server that is in Australia, and then it gets delivered to you.
And in this process too, there are quite a few interrelated networks that deal which you are not aware about. The content directly gets delivered to you, and you have a feeling where you feel that you type in a particular URL and the content is directly made available to you. But that is not how it works. Quite a few other things happen in the interim. And due to that, what happens is the data that gets delivered to you, it does not get delivered to you very quickly. Why is that? Because you'd be sending in a request, it would go to the original server, and from there the content is delivered to you. Now, if you are based in USA, the situation would be convenient if the data is delivered to you from somewhere close by. Now, when you talk about a traditional system where you are sending a request to somewhere in Australia, this is what happens. Your data or your request is sent to the server based in Australia, and then it processes that request and that data is made available to you, which gets delivered to you. But if you have something like CloudFront, what it does is it sets in an intermediate point where your data actually gets cached first. And this cached data is made available to you on your request. That means the delivery happens faster and you save a lot of time. So how does AWS CloudFront exactly do it? Let's try to understand that. Well, when you talk about AWS CloudFront, what it does is first and foremost, it speeds up the distribution process, and you can avail any kind of content, whether it's static or dynamic, and it is made available to you quickly. What CloudFront does is it focuses on these 3 points. One is your routing, 2 is your edge locations, and 3 is the way the content is made available to you. Let's try to understand these one by one. When you talk about routing, I just mentioned that the data gets delivered to you through a series of networks. So what CloudFront does is it ensures that there are quite a few edge locations that are located close to you, and the data that you want to access, it gets cached so that it can be delivered to you quickly. And that is why the data that is being delivered to you is more available than in any other possible case. So what happens exactly, and how does this content gets delivered to you? Let's try to understand this with the help of this diagram. Suppose you are a user. So basically what you would do is you would send in a request that needs to reach a particular server. Now in this case, what happens is first your request, it goes to an edge location and from there to your server. To understand this too, you have to understand 2 scenarios. First and foremost, suppose you are based in USA and you want to fetch a particular data that is based in Australia, you would be sending in a request. But what AWS does is instead of sending that request directly to your server, which is based in Australia maybe, it has these interim edge locations which are closer to you. So the request, it goes to the edge location first and it checks whether the data that you're requesting is already cached there or not. If it is not cached, then the request is sent to your original server. And from there, the data is delivered to the edge location. And from there, it comes to you. Now, you might wonder, as in this is a very complex process. And if it is taking these many steps, how is it getting delivered to me quicker than in normal situation? Well, think of it from this perspective. If you do send in this request directly to the main server, again, the data would flow through some network and then it would be delivered to you. Instead, what happens here is at your edge location, the data gets cached. So if you request it again, it would be delivered to you quicker. If it is requested by anyone else, it would be delivered to them quicker. Plus, how edge locations work is when you do send in this request and when the edge location fetches this data from your so-called original server, in that case too, when the first byte it arrives at your edge location, it directly gets delivered to you. And how does this content exactly get stored here? Well, first and foremost, what happens is what your edge location has is it has some regional cache as well. Now, this cache would basically hold all the content that is requested more frequently in your region. Suppose a website has some number of content, and out of it, some content is kind of requested a lot in a particular region. So surrounding that region, the closest edge location would have a regional cache which would hold all the content that is more relevant for those users, so that it can be frequently delivered to these users and can be made available to them quickly. In case if this data gets outdated and it is no longer being requested, then this data can be replaced with something else that is requested more frequently. So this is how CloudFront works. What it does is it creates a distribution and you have some edge locations through which you can actually request that data faster. So So what are the applications that CloudFront has to offer to you? Now, I won't say applications. Instead, I would say some of the benefits of using CloudFront. Let's try to understand those one by one. First and foremost, what it does is it accelerates your static website content delivery. We just discussed that. That means if you're requesting a particular image or something like that, it gets delivered to you quicker. Why? Because it is cached at your edge location and you do not have to worry about any latency issues. Next, what it does is it provides you various static and even dynamic content. Suppose you need some video or a live session or something like that. Even that gets delivered to you quickly. I just mentioned that when you request a particular thing, when the first byte it arrives at your edge location, your CloudFront starts streaming that to you or start delivering that to you. Same happens with your live streaming videos as well. You would be getting that streams instantly without any latency whatsoever. Encryption. Now, when you do access this content, what AWS CloudFront does is it lets you have this so-called domain where you put in HTTPS and you get secured data. So you already have one layer of security, but it also lets you add another layer of security by giving you something called as encryption. By encrypting your data or by using your key value pairs, which is the same, you're actually ensuring that your data is more secured and it can be accessed privately as well. Customization at the edge. Now, what do I mean by this? Now, there is some content that needs to be delivered to the user or to the end user. If the customization it happens at the server, again, it might be time consuming and there are quite a few drawbacks of it. Say, for example, I need a particular content and it needs to be processed or customized at the very last moment. So these things can be done at the edge location as well, thus helping you save time, money, and various other factors as well. And finally, what it does is it uses something called as Lambda Edge, which again lets you deal with various customizations and lets you serve your content privately. So these were some of the applications or uses of CloudFront. What I'm going to do now is I'm going to switch into my AWS console and I'm going to talk about AWS CloudFront distributions and how can you go ahead and create one. So stay tuned and let me quickly switch into the console first. So yes, guys, what I've done is I've gone ahead and I've logged into my AWS console. Now, for people who are completely new to AWS, what you can do is you can actually go ahead and create a free tier account. You have to visit AWS website and search for free tier. You would get this option. Just create an account. They would ask you for your credit or debit card details probably, but they won't charge you. A minimal amount is charged and that is reverted back to your account. That is for verification purpose. And after that, what AWS does is it offers you certain services which are made available to you for free for one complete year. That is, as long as you stay in the limits or the specified limits which AWS has set. So those limits are more than enough to practice or to learn AWS. So if you want to go ahead and get a proper hands-on on various AWS services, I would suggest that you do visit their website and create this free tier account. Once you do have that account, you have all these services that are made available to you. As I just mentioned, there are 70 plus services and these are the services that are there, which you can actually go ahead and use for different purposes. Our focus today, however, is creating a CloudFront distribution, which we just discussed in the so-called theory part. I would be repeating few topics here too while we do go ahead and create our CloudFront distribution. Now, as I've already mentioned, we want to fetch data or fetch a particular object. And if that is placed at a particular edge location, that would be made available to me. So what we are doing here is imagine that our data is placed at a particular original server. In our case, let's consider it as an S3 bucket. Now, S3 is nothing but a storage service with AWS, that is simple storage service rather, that is SSS, and that is why we call it S3. So what we are going to do is we are going to go ahead and create an S3 bucket. In that, we would be putting in certain objects and we would be accessing that by using our CloudFront distribution. So let's just go ahead and create a bucket first. You can see we have S3 in my recently used services. You can just type S3 here and that would be made available to you. You can click on it and your simple storage service opens. You would be required to go ahead and create a bucket. This is how you do it. You click on create and you give it some name, say maybe bucket, use small letters, bucket for AWS demo maybe, and I would give in some number 000. I say next. I need a basic bucket, so I won't be putting in any details. Do we have a bucket here? There you go. We have a bucket here. And in this bucket, what I'm going to do is I'm going to put in some content that we can actually request for. So let's just go ahead and create an HTML file and put in maybe an image or something. So I have a folder here. In that folder, I have a logo of Edureka. I would be using that logo, and I would want to go ahead and create an HTML file which I can refer. So I would open my notepad and I would write a simple HTML code. I won't get into the details of how to write an HTML code. I assume that you all know it. If not, you can use this code. So let's create a head file basically, or a head tag rather. Let's say demo tag maybe, and I close this head tag. I need some body in here, right? So let's say let the body be say welcome to Edureka, and I end the body here, and I save this file. I say save as. Where do I want to save it? And save it here, and I would save it as say maybe index.html. I say save. It probably got saved somewhere else. Let me just copy it and paste it here. I've done that. This is the file. Now we have these files. Let's upload it to our S3 bucket. Come here, I say upload. I want to add files. So add files. Where do I go? I go to the F folder. I go to demo and I select these two files and I say upload. There you go. My files are here and I say upload. Small files, so should not take a long time. 50% successful, 100% successful. There you go. You have these two files. Now we have our S3 bucket and we have two files. This is our origin server. Now I need to create a distribution and use it. To do that, I would click on services and come here and I would search for CloudFront. There you go. And I say create a distribution. So I click on this icon. Now you have two options. First one is something that lets you have your static data moved in or moved out. Or if you want to live stream your data, you should go for this option, but that is not the case. We would be sticking to this thing. I say get started. I need to enter in a domain name. So it gives me suggestions, and this is the first one which I just created. Original path is something that you can give in for the folders from where you want to access the data, but mine directly resides in the bucket. There are no extra folders, so I don't need to enter anything. Original ID, this is what I have here. Basically, I can use this, or I can just go ahead and change the name if I want to, but I would let it stay the way it is. Restrict bucket access, yes, I want to keep it private, so I say restrict and I create a new identity. And there you go, I have a new user created here. Apart from that, grant read permissions on bucket, yes, update my bucket policy accordingly is what I would say. Then I would scroll down, customer headers and all, I don't need to put in these details. How do I want my data to be accessed? The protocol policy. I would say redirect HTTP to HTTPS so that it is secured. If I scroll down, I have some other options as well. Cached HTTP methods and all those things. Do I need to change these? Object caching, can I customize it? Yes, I can, but again, I would be using the by default one. If you want to, you can customize it. Smooth streaming, no, these are some of the things that you need to focus on. If you have some streaming data, you can put in details accordingly, but we are not doing that. What is the price class that you want to choose? You have some options here which you can pick from. I would be going for the default one. And then I just scroll down and I say create a distribution. So your distribution is getting created now. And this process might take a longer while. If you click on this thing, you'll realize that it is in progress and it takes somewhere around 10 to 12 minutes for this distribution to get created. So meanwhile, I'm gonna pause this session and I would come back with the remaining part once this distribution is completed. So bear with me for that while. So there you go. The distribution has been deployed. The status is deployed here. So we can actually go ahead and use this thing. Now we have a domain name here which I can use and I can just enter it here and we would be redirected to the page. And what happens here is you would be actually given access to this page through the edge location. That means you're not going to the server. Instead, the data is being cached to you from your distribution or your edge location rather. So you enter this website and you hit the enter button. There's an error. It shouldn't have been. Oh, I know what just happened. When you do go ahead and create your so-called distribution, in that you actually have an option of selecting a by default file. which I did not. So I'll have to give in an extension here saying /index.html. And if I hit the enter button now, it should redirect you to the demo tag, which says welcome to Edureka, right? So this was the HTML file that we created. And we also had a PNG file which we wanted to access. The name was logo.png. Okay, this is funny. This should not happen. Why is this happening? Let's take a look at it, whether we have that file there, because if it was there, we should be able to access it. And what was my bucket? This was the one. Oh, this has happened. When I uploaded that file, it got saved with this extension .png. So if I come here and I type .png here, there you go. You have that object delivered to you through your so-called distribution.
First, let us try to understand why we need cloud-based monitoring with a couple of scenarios. In our first scenario, consider that you have hosted a messenger app on cloud, and your app has gained a lot of fame, but lately the number of people using your application has gone down tremendously, and you have no idea what the issue is. Well, it could be due to two reasons. Firstly, since your application has complex multi-tier architecture, monitoring the functionality of every layer by yourself will be a difficult task. Don't you think? And secondly, since you're not using any kind of monitoring tool here, you wouldn't know how your application is performing on cloud. Well, one solution for that is to employ a monitoring tool. This monitoring tool will provide you insights regarding how your application is performing on cloud. And with this data, you can make necessary improvements, and you can also make sure that your application is in par with today's customer needs. And definitely after a while, you'll notice that the number of people using your application has increased. Moving on to our next scenario, let's say your manager has assigned you with a project and he wants you to make this project as cost effective as possible. So as you can see in this project, you're using 5 virtual servers which perform highly complex computations. And all these servers are highly active during daytime. That is, they handle most traffic during daytime. But during nighttime, the servers are idle. By that I mean the CPU utilization of these servers during nighttime is less than 15%. And yet, as you notice here, in both the cases you are paying same amount of money. You have to notice 2 points here. Firstly, all your virtual servers are underused during nighttime. And secondly, you are paying for the resources which you're not using. And this definitely is not cost effective. So, one solution is to employ a monitoring tool. This monitoring tool will send you notification when these servers are idle, and you could schedule to stop the servers on time. So guys, this is one way to make your project most cost effective and avoid paying unnecessary operating costs. Let's consider another scenario for better understanding. So let's say I have hosted an e-commerce website on cloud, and during sales season, many customers are trying to access my website, which is definitely a good thing. But for some unfortunate reason, application downtime has occurred, and you guys have to remember that I'm not using any kind of monitoring tool here. So it'll be difficult for me to identify the error and troubleshoot it in reasonable amount of time. And it's quite possible that in this period, my customer might have moved on to different website. So you see that I've lost a potential customer here. So if I've had a monitoring tool in the situation, it would have identified the error in earlier stages itself and rectified the problem. Well, I could have easily avoided losing my customer. So I hope guys, with help of these use cases, you were able to understand as to why we need cloud-based monitoring. So let me just summarize what we've learned till now. We need monitoring firstly because it provides a detailed report regarding performance of your applications on cloud. And secondly, it helps us to reduce unnecessary operating costs which we are paying to the cloud provider. Moreover, it detects problems at earlier stage itself so that you can prevent disasters later. And finally, it monitors the user's experience and provides us insights so that we can make improvements. So well guys, in this session, we will be discussing about one such versatile monitoring tool called Amazon CloudWatch. Amazon CloudWatch basically is a powerful monitoring tool which offers you a most reliable, scalable, and a flexible way to monitor your resources or applications which are currently active on cloud. It usually offers you with 2 levels of monitoring, which are basic monitoring and detailed monitoring. If you want your resources to be eligible for basic monitoring, all you have to do is to sign up for AWS free tier. In basic monitoring, your resources are monitored less frequently, like say every 5 minutes, and you're provided with a limited choice of metrics to choose from. Whereas in detail monitoring, all your resources are monitored more frequently, like say every 5 minutes, and you're provided with a wide range of metrics to choose from. But if you want your resources to be eligible for detail monitoring, you'll have to pay a certain amount of money according to AWS pricing details. Now, let's have a look at few monitoring services offered by Amazon CloudWatch. Amazon CloudWatch, firstly, it provides a catalog of standard reports which you can use to analyze trends and monitor system performance. And then it monitors, stores, and provides access to system and application log files. Moreover, it enables you to set up high resolution alarms and send notifications if needed. And Amazon CloudWatch also sends system events from AWS resources to AWS Lambda functions, SNS topics, etc. So if you have not understood any terms which I've used here, don't worry, we'll get to know more about these terms as we progress through the course of this session. Earlier, I mentioned that Amazon CloudWatch allows administrators to monitor multiple resources and applications from single console. These resources include virtual instances hosted in Amazon EC2, databases located in Amazon RDS, data stored in Amazon S3, elastic load balancers, and many other resources like auto-scaling groups, Amazon Cloud Trail, etc. So guys, now let's try to understand Amazon CloudWatch a little deeper. Firstly, we'll have a look at few Amazon CloudWatch concepts, and then I'll explain you how Amazon CloudWatch actually operates. So it's metric. A metric represents a time-ordered set of data points that are published to cloud. So what I mean by that is, suppose let's say you have three variables x, y, and z, and you have created a table which has values of x with respect to y over a period of time. In this scenario, the variable x which you have been monitoring till now is a metric. So you can think of metric as a variable which needs monitoring. Next we have dimensions. Let's consider same variables x, y, and z. Previously you had created a table which has values of x with respect to y. Now let's create another table which has values of x with respect to z. So basically we have two tables which describe same variable x but from two different perspectives. These are nothing but dimensions. So basically a dimension is a name value pair that uniquely identifies a metric. And Amazon CloudWatch allows you to assign up to 10 dimensions to a metric. Then you have statistics. Previously we had created two tables which had values of x with respect to y and as well as z. You can combine data from these tables like to create a chart or maybe plot a graph for analytical purposes. This combination of data is nothing but statistics. Statistics are metric data aggregations over a specific period of time. Then you have alarm. Let's say you have been monitoring this variable x for some time now and you want a notification to be sent to you when the value of x reaches certain threshold. All you have to do is set an alarm to send you notification. So basically, alarm can be used to automatically initiate actions on your behalf. Now that you have clear understanding of concepts of Amazon CloudWatch, let's see how Amazon CloudWatch operates. Amazon CloudWatch has complete visibility into your AWS resources and applications which are currently running on cloud. So firstly, it collects metrics and logs from all these AWS resources and applications. And then by using these metrics, it helps you visualize your applications on CloudWatch dashboard. Moreover, if there is some sort of operational change in AWS environment, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective action, like maybe it sends you a notification or it might activate a Lambda function, etc. And finally, it provides you real-time analysis by using CloudWatch Metric Math. So if you're wondering what CloudWatch Metric Math is, it is a service which integrates multiple CloudWatch metrics and creates a new time series. And you can view this time series on CloudWatch dashboard as well. So working this way, Amazon CloudWatch provides you with system-wide visibility. It even provides you actionable insights so that you can monitor your application performance. Moreover, it allows you to optimize resource utilization if needed. And finally, it provides a unified view of operational health of your AWS environment. So I hope that by now you know what Amazon CloudWatch is. So now let's try to understand how Amazon CloudWatch works with help of a demo. So guys, this is my AWS console. Let's say AWS Management Console. And the services which you can see on the screen are the services offered by Amazon AWS. But in this demo, we're going to use only few services. Let's say CloudWatch, and then you have EC2 and a service called Simple Notification Service. And when I click on EC2, it takes me to EC2 dashboard where you can see that I have 4 instances which are currently active. You know that here in this demo, I'm supposed to get a notification saying that CPU utilization of my instance is less than 25%. For me to receive a notification first, I'll have to create a topic and subscribe to it with my email ID. So let's explore a service called Simple Notification Service, where you can create a topic and subscribe to it. Once you reach SNS dashboard, click on Topics option on the navigation pane and click a Create New Topic. Give your topic a name. Let's say CW topic, and give the display name as well. Let's give the same name and click on Create Topic option here. You can see that I've successfully created a topic. Now click on the topic which you have created and select Actions and subscribe to topic option. Well, I want notification to be sent to me in form of email. You have different options as well in form of Lambda function or JSON, etc. But I'm going to choose it as email and give my email ID, which is here, and then click on Create Subscription option. So now whenever AWS console wants to send me a message, it will send to the email ID which I used to subscribe the topic. Now let's go back to CloudWatch dashboard. So guys, this is my CloudWatch dashboard, and you can see different options on navigation pane. Firstly, I have dashboard where I can view all my metrics at same place. Then you have alarms, which shows the list of alarms which you have configured. And then you have events and logs, which we'll be exploring later. Our topic of interest is the last one, which is metrics. Select the metrics option here and then choose EC2 and then per instant metrics. When you do that, a list of metrics will be shown to you like network out, CPU utilization, network packets in, network packets out, and various other metrics for various resources which are currently active on your cloud. So, but we are interested only with CPU utilization. So I'm going to type that here. Well, it shows the list of instances which are active on my cloud. And I'm going to choose Windows 2 instance and then click on Graph Metrics option here. Okay, let's select Windows 2 only. And then on the right side, you can see you have a alarm button. When you click on that, a dialog box will be open where you can configure your alarm. Firstly, let's give alarm a name. Let's say low CPU utilization and a brief description as well. Let's say lower than 25%. Lower than 25% CPU utilization. Now I'm going to set the threshold, which is less than 25% in this case. And on the right side, you can see a period option. If your resources are eligible for basic monitoring, this period option by default is 5 minutes. And if your resources are eligible for detailed monitoring, it's usually 1 minute. And when you scroll down, you can see a send notification to option here. So select the topic which you have previously created. That will be C topic in my case, and then click on create alarm. Well, there is some error. Okay, it says there's an alarm already with this name. So let's give it another name of my instance. Now let's try again. And when you click on this alarm button and click on refresh option here, it says that I've successfully created an alarm. Here you can see that low CPU utilization of my instance. And when you click on that, it shows you all the details like description, threshold, and what action it is supposed to take when alarm is configured and all the details. So guys, try it out. It'll be easy for you to understand CloudWatch console much better. Okay guys, now you know what Amazon CloudWatch is, what it does, and the way it operates. But to understand the capability of Amazon CloudWatch completely, we should be aware of two important segments of Amazon CloudWatch, which are CloudWatch events and CloudWatch logs. So let's discuss them one by one. Firstly, we have Amazon CloudWatch events. Consider the scenario. Let's say you have created an auto-scaling group, and this auto-scaling group currently has terminated an instance. So you can see this as some sort of operational change in AWS environment. When this happens, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective actions. Like in this case, it might send you a notification saying that your auto-scaling group has terminated an instance. or it might activate a Lambda function which updates the record in Amazon Route 53 zone. So basically what Amazon CloudWatch Events does is it delivers a real-time stream of system events that describe change in your AWS resources. Now let's have a look at few concepts related to CloudWatch events. Firstly, we have event here. An event indicates change in AWS environment, and AWS resources generate events whenever the state changes. Let's say you have terminated an active EC2 instance. So the state of this EC2 instance has changed from active to terminated, and hence an event is generated. Then you have rules. Rules are nothing but constraints. Every incoming event is evaluated to see if it has met the constraint. If so, the event is routed to target. Target is where the events are handled. Target can include Amazon EC2 instances or a Lambda function or an Amazon SNS topic, etc. Now let's try to understand Amazon CloudWatch events better with help of use case. In this use case, we are going to create a system that closely mimics the behavior of dynamic DNS. And for those who don't know what dynamic DNS is, let me give an example. Let's say you want to access internet at home. Then internet service provider assigns you an IP address, but since internet service provider uses different kind of online systems, this IP address keeps changing, because of which it might be difficult for you to use this IP address with other services like webcam, security camera, thermostat, etc. So this is where dynamic DNS comes into picture. What dynamic DNS does is it assigns a custom domain name to your home IP address, and this domain name is automatically updated when IP address changes. So basically, dynamic DNS is a service that automatically updates a name server in domain name system. And Amazon offers you with a similar kind of service called Amazon Route 53. So in this use case, we are going to update Amazon Route 53 whenever an Amazon EC2 instance changes its state. Now let's see how the use case actually works. This use case precisely works this way. So whenever an EC2 instance changes its states, Amazon CloudWatch event becomes aware of these operational changes and it triggers a Lambda function. This Lambda function uses different kind of information regarding the instance like its public and private IP address, and it updates a record in appropriate Route 53 hosted zone. So let's say you have an EC2 instance and you have terminated the instance. So Amazon CloudWatch events become aware of this and it triggers a Lambda function. And this Lambda function deletes the record from Amazon Route 53. Similarly, if you have created a new instance, again Amazon CloudWatch events become aware of this and it triggers a Lambda function, and this Lambda function creates a new record in Amazon Route 53. I hope you have understood what Amazon CloudWatch events is and what it does. Now let's discuss how Amazon CloudWatch events works with help of a demo. So in this demo, we will schedule to stop and start EC2 instances with help of Lambda function and CloudWatch events. So let's go ahead with demo. So guys, you can see that I have 4 instances which are currently active. First, I'm going to create a Lambda function which is going to stop my Windows 2 instance. And you guys need to know that for Lambda function to do that, we need to assign permission. So Amazon provides you with a service called IAM, which is Identity and Access Management, where you can assign permissions. When you search for IAM in the tab, it shows you the service. Select that, and on IAM dashboard, on the navigation pane, you can see a policies option here. Select that and click on create policy option. First, it's asking you for a service here, which will be EC2 in our case. Click on EC2 function, then actions, which will be to start and stop my EC2 instances. So let's search for start instance. Well, a predefined function is already there, so you can choose that. Then you have stop instance. Again, select that. And then I want this to be eligible for all the resources, so I'm going to choose all resources here and click on review policy option. Let's give our policy a name, that is to start and stop EC2 instances, and description as well, a brief description. Let's say to start and stop instances. And now click on create policies. It's taking a while. So I've successfully created a policy here. Next, we have to assign this policy to Lambda function. So click on roles here, then click on create role, choose Lambda function here and click on next permission. Search for the policy which we have created earlier, that is to start and stop. I found the policy, select that and click on next review option. It's asking for a name. Let's give a name. Start, stop instances. and click on create role. I've successfully created a role. So what we have done here is we have assigned permission for Lambda function to control EC2 instances. Now let's create a Lambda function. You can search for Lambda in the search tab and there click on create function. Give your Lambda function a name. Let's say to stop instance and select the role which you have previously created and click on create function. You can see that I've successfully created an Lambda function. And now I'm just going to copy the code to stop EC2 instances here. I'm going to select this and paste it over here and make sure to save it. As you can see here in this function, it asks for instance region and instance ID. So let's configure the details. Let's give it as stop instance. And here you'll have to insert instance region and ID. Instance region and instance ID. Now we'll have to copy the instance region and ID of the instance whichever we need. So let's go to EC2 dashboard here. Now let's say I want my Windows 2 instance to be stopped. This is the instance ID which I'm going to paste it over there. Similarly, instance region now. Well, in this case, I'm choosing Windows 2 instance. You can choose whichever instance you want to stop. Once you're done that, you click on create option here. Test the configuration details. When you scroll down, you can see the execution results here. It says that my instance has been successfully stopped. Let's go and check in the EC2 dashboard. Here on the EC2 dashboard, I'm going to refresh it. And you can see that my Windows 2 instance has successfully stopped. Now we'll create another Lambda function which will restart this function. Again the same, search for Lambda function in the search tab and click on create function option. It asks for a name, so let's say start instance and choose the role which you have previously created and click on create function. Again, you'll have to paste the code to start the instances over here and click on save option. Let's try to configure this. Let's name it as start instance. And again, it asks for two attributes which are instance region and ID. Now all we have to do is copy the instance region and ID here like we did earlier. Let's go to EC2 dashboard and copy the instance ID and region. Well, you guys can see that here my Windows 2 instance has been successfully stopped. Now I'll copy this and paste it over there. Similarly, instance region as well. And click on create option. Now test the configuration. And when you scroll down, you can see that my instance has successfully restarted. In the EC2 dashboard, I'm going to refresh this. Well, my Windows 2 instance is on its way to get restarted. Till now, I've used Lambda function to start and stop my instances. But now I'm going to automate this process with help of Amazon CloudWatch. So let's go to CloudWatch dashboard here. Well, it's taking a while to load. Then choose events option and click on create rule. So here we're going to schedule to stop my instances every day at 6:30 p.m. and to restart this instances every day at 6:30 a.m. So click on schedule. If you want to know more about cron expressions, you can visit Amazon documentation. So let me show you. It has 6 fields. Firstly, it's minutes, then you have hours, then day of month, day of week, and year. We're concerned only with minutes and hours because we want our instances to be start and stopped every day, every month. So let's give the details. So if you're going to create a rule to stop the instance, let's say 6:30 in the evening, 30 minutes and 18, which is nothing but 6 p.m. And then rest all, you don't have to mention anything. When you give a proper cron expression, sample timings will be provided to you. You can see here the rest of the sample timings. And now let's add a target function, which is Lambda function in our case, and select on stop instance function and click on configure details. Give your rule a name. Let's say stop my EC2 instance and description to stop my EC2 instance at 6:30 p.m. every day. and click on create rule here. You can see that I've successfully created a rule to stop my instance every day at 6:30 p.m. Now let's create another rule to restart this instance every day at 6 a.m. in the morning. Again the same. Choose the schedule here and cron expression, which will be 6 a.m. in the morning. Again the sample timings are shown here. Then let's add target function, again lambda function, and select the function that is to start instance and click on configure details. Let's name it as start my EC2 instance and description as to start my EC2 instance every day at 6 a.m. and click on create rule. So now we have successfully created two rules to start and stop the EC2 instances at 6:30 p.m. and 6:30 a.m. respectively. So what we have done is we have saved our time here. We have automated the process of stopping and starting EC2 instances. So try it on yourself. It'll be easier for you to understand. So guys, now let's discuss our next topic, which is Amazon CloudWatch logs. Have you guys heard of log files? Well, log files are nothing but detailed record of events that occur when you're using your AWS environment. You can view your log files on your on-premise server as well. Search for an app called Event Viewer. Select the app and click on Windows Logs and select Systems. A list of log files will be shown to you. When you choose a particular log file, all the details regarding that log files will be shown, like the number of keywords, the login time, number of hours the file has been logged onto, and various other details. Similarly, you have log files created when you use AWS environment as well. So you can consider these log files as a data repository. Most of the metrics are generated from these log data. So whenever a metric is generated, a part of data is extracted from this log data. So you're designing metrics according to your like by choosing a part of data from this log data. So basically these log files are what you call a primary data storage place. And Amazon CloudWatch logs is used to monitor, store and access log files from AWS resources like EC2 instances, CloudTrail, Route 53, etc. Let's try to understand CloudWatch logs better with help of some features. Firstly, you can use Amazon CloudWatch logs to monitor your application and system log files. Let's say you have made a lot of errors but trying to deploy your application on cloud. In this scenario, you can use CloudWatch logs to keep track of your errors and send a notification to you when the error rate increases certain threshold so that you can make avoiding errors again. Then you have log retention. By default, logs are kept indefinitely. But CloudWatch provides you with an option where you can set the period between 10 years to 1 day. Then you have log storage. You can use CloudWatch logs to store your log data in highly durable storage. And in case of system errors, you can access raw log data from this storage space. And then you have DNS queries. You can use CloudWatch logs to log information about the DNS queries that Route 53 receives. Now let's have a look at few concepts regarding CloudWatch logs. Firstly, we have something called log event. So log event is just a record of activity that has occurred in AWS environment. It's straightforward. Then you have log stream. A log stream is a sequence of log events that have same source. Then you have something called log group. Log group defines group of log streams that has same monitoring and access control settings. By default, you have to make sure that each log stream belongs to one or the other log group. Guys, now let's try to understand CloudWatch logs better with help of this use case. In this use case, we are going to use Amazon CloudWatch logs to troubleshoot the system errors. You can see that I have 3 instances here and a CloudWatch agent which is monitoring all these 3 instances. So what CloudWatch agent does is it collects custom level metrics from all these EC2 instances, and then all these metrics and logs collected by the agent are processed and stored in this Amazon CloudWatch logs. Amazon CloudWatch logs then continuously monitors these metrics, as you can see here. By then, you can set an alarm which will send you notification when some sort of error occurs in the system. So whenever you receive a notification saying that some sort of error is there in your system, you can access the original log data which is stored in CloudWatch logs to find the error. So this is how you can use Amazon CloudWatch logs to troubleshoot the system errors. So basically you are having a look at original data so you can solve your problems faster and quicker.
So why do we need CloudFormation? So for example, you have an application. Now most of you guys know that and we have done this in the previous sessions as well, that we created an application, right? Now that application is actually dependent on a lot of AWS resources. Now if we were to deploy and manage all these resources separately, it will take up a lot of time of yours, right? So to reduce that time or to manage all these resources, what if I told you you have a service? Yes, you got that right. So you have a service called AWS CloudFormation. So using AWS CloudFormation, you can manage and create and provision all these resources at a single place. Now, this is what CloudFormation does. But now, what is CloudFormation exactly? So a CloudFormation is basically a service which helps you model and set up your AWS resources so that you can spend more time on your application rather than setting up and provisioning these resources, right? So basically it's a tool using which you can create your applications quickly. Also, you can create templates in AWS CloudFormation. Now, how do you create templates? Basically, you would be using the CloudFormation designer. You'd be putting in all the resources that are needed. You would be defining the dependencies of these resources, and then you'll be saving this design as a template, right? Now, what will you do with this template? This template can be used to create as many copies as you want, right? Say, for example, you have a use case wherein you want your application in multiple regions for backup purposes, right? So if you want that, you won't be implementing or you won't be creating each and every resource one by one in each of the regions. What you can do is you will create it at one place in CloudFormation, have that template in your hand, and deploy that template in the other regions as well, right? So what will this do? So first of all, your replication will be very precise, right? So there won't be any changes in the copies that you have made. Second of all, you'll be doing that quickly because you don't have to do the process all over again. You just have to click a button and that template will be provisioned or will be launched in that region. So this is what AWS CloudFormation is all about. It makes your life simpler by handling all the creation and the provisioning part, right? So this is what is AWS CloudFormation. Now, how do we get started in CloudFormation? Since it's a very useful service, how can you as a user use this service? So let's move on. So for using the CloudFormation service, first of all, you need a JSON script. Now, why do you need a JSON script? Because you'd be creating a template, right, in the CloudFormation designer. You'd be using the drag and drop option and filling in the AWS resources, right? Now, when you'll be doing that in the backend, it'll actually be creating a JSON script. Now, what you can do as a user is if you're good in JSON, you can create your own JSON script. Otherwise, you can use the CloudFormation designer to create a template. Now, for creating a template, like I said, you need a JSON script. Now, what is a JSON script then? So a JSON script is basically a JavaScript object notation file, which is an open standard format. That means it is human readable. So you can read it as well as the computer. So if you don't need the programming knowledge for this, what you as a user would be doing is you would be designing your template in the CloudFormation designer, and that will automatically create a JSON script. You can do it the other side as well. Like I said, you can create your own JSON script and feed it in the CloudFormation designer. So this is how CloudFormation works. This is how you'll be using AWS CloudFormation. But then how can you learn the JSON script? So it's very easy. So basically you have to follow a structure in the JSON document. What is this structure? So that structure is like this. You'll be creating the following fields. So the first field will be the AWS template format version. So this will basically contain version of your template. Next up is the description. So description is a text only file or is a text only field wherein you'll be describing your template in words, right? So if I'm a user and I want to know what your JSON does, without reading your JSON script from beginning to end, I can read the description in simple English and understand what your JSON script will do, right? Then you have the metadata. So metadata will basically contain the properties of your template. Then you have the parameters. So any values that you have to pass to the template will be included in the parameters. Next comes mappings. So mappings would basically include the dependencies between your AWS resources. Then comes conditions. So conditions are basically the conditions that you'll be giving to your template when the stack will be created or while the stack is upgraded. So if your stack is being created or your stack is being upgraded, these conditions will be looked onto. Then comes outputs. So whatever outputs your template will provide or your creation or stack will provide will come in the outputs header. Then you have the resources field. So resources field will basically include all the AWS resources that you want to include in your infrastructure, right? Now, if you look carefully, you actually will be only dealing with the resources part, right? Because you will just be populating in the resources and creating the dependencies, right? So basically you'd be populating the resources part, and that is what it was all about, the resources part, right? Now, this is theory. Now, how does a JSON document actually look like, right? A JSON document looks something like this. So like I said, you'd be working on the resources field, right? So you'd be including the resources field, and in that, say so this JSON document is all about, if you had noticed, it's about S3, right? So you are basically including an S3 bucket, and in the type you'd be specifying the type of service that will be including this bucket, right? Like in this example, a JSON document doesn't know what service you're talking about. So you'd specify the name of the bucket, and inside the braces you'll be specifying which service. So over here you'll be specifying the S3 service. Don't worry, I'll be showing you guys this JSON document in a moment, but before that you should understand how a JSON document is structured, and this is what we're doing right now. Now guys, this is the CloudFormation dashboard. Now you have to create a stack over here, right? And for the creation of a stack you require a template. So first we'll design a template and then we'll create a stack. So this is my CloudFormation designer. Let's go back to our slide and see what we actually have to do. So this is our first demonstration. Herein we'll be creating a S3 bucket from CloudFormation. So we'll be designing a template around that for first, and then we'll be deploying this code, right? So let's do that. So let's go to our CloudFormation window now. So we have to create a S3 bucket. So we'll scroll down to the S3 service. So here is the S3 service. We'll click on the S3 service. We'll click on bucket and drag it over here, right? So this is our S3 bucket, guys. Now you can edit the name of the template over here. You can name it as Edureka CF. That means Edureka CloudFormation, right? So you specified that. Now this is your JSON code. Now you can compare the JSON code, guys. Let me make it a little bigger for you guys. Yeah, so this is the JSON code, guys. Now I didn't code this JSON script, right? I just dragged and dropped this bucket over here in CloudFormation, and it automatically generated the script. Comparing it with the code that we have in our presentation, let's see. So we have resources. Yes, we have resources. We have the name of your bucket part. So basically this is the name of your bucket, and then it's a type wherein you'll be specifying the S3 service. So you have type and you're specifying the S3 service over here. Alright, so if you want to change the name of the bucket, we can do that over here. Let's specify it as Edureka CF. Alright, so we are done. So this is it, guys. This is all you have to do. So now for running this in CloudFormation, all you have to do is click on this icon, create stack. Now this will lead me to this page, which is the create stack page. Now it has automatically uploaded this template to the S3 bucket, and it has specified the URL here, right? You'll click on next. You'll specify the stack names. Let's specify it as Edureka CF, right? So you don't have to specify anything here. Let's click on next. Click on create. So you'll be seeing the events on this page. Let's refresh this. So it says create in progress, right? So my template is now being created into a stack, and that stack will have the AWS resource in it, which is the S3 bucket, right? So I think the time is enough. Let's refresh it and check if our stack has been created. So it's still in the creation phase. Let's wait. All right. So now it shows me that the create is complete. All right, guys. So let's go to our S3 service and check whether we have that bucket that our AWS CloudFormation created for us. So we'll go to the S3 service. And here it is, guys. So this is the bucket that we created, all right? And so you can see the time, it's March 28th, 2017. Today is March 28th, 2017. And the time is 7:05 and the time is 7:07 here, all right? So this bucket has just been created by CloudFormation. So guys, like I said, it is very easy. It is easy to understand and to deploy as well. You basically just have to create a template, and that is it. AWS CloudFormation will do the rest for you. And the cool part is that you can replicate that template as many times as you want, right? So it will save you the time. Okay, this demonstration is done. So we have created an S3 bucket using CloudFormation. Let's see what our second demonstration is all about. So now we'll be creating an EC2 instance in which we'll be deploying the LAMP stack, which means in that EC2 instance, you'll be installing Linux, you'll be installing Apache, you'll be installing MySQL, and you'll be installing PHP as well, right? So let's see how will we do that. So for our second demonstration, we will again go back to the CloudFormation console. We'll click on create stack. Now we have to launch a LAMP stack. So a LAMP stack is basically a sample template in AWS, right? So we can select the sample template and we'll click on view or edit template in designer. So a LAMP stack is basically an EC2 instance with Linux, Apache, MySQL and PHP installed onto it, right? You can see in the designer that you have only specified an EC2 instance and you've attached a security group to it. So you need the security group obviously because you have to connect to this EC2 instance, right? Now a LAMP stack is basically a web server, remember? Now let's see the template for this LAMP stack. So we discussed the structure of a JSON document, if you guys remember. So the first part was the AWS template format version, then you have description, then you have parameters. So parameters, if you guys remember, it is basically the values that you'll be passing to the template, right? Now if you're creating a LAMP stack, you'll be needing the database name, you'd be needing the database password, you'd be needing a lot of things, right? If you're installing MySQL, you'd be needing the username, you'd be needing the password. So all of that you can feed in here in the parameters. So you can specify the key name. So if you are connecting to the EC2 instance through SSH connection, you'd be needing a key pair, right? So you'll be specifying the key pair here. Then you'll be specifying the DB name and the other details. Now how will that look when you'll be creating a stack? So let's do that. We'll click on this icon which will now create a stack automatically. So you'll be prompted on this page, click on next. Then you will reach this page wherein you are feeding the entry, right? So you would specify the stack name. So this is by default. So stack name, so we'll be specifying the stack name first. So let us stack name be LAMP demo. And then we move on to the parameters part. So whatever you specified in the JSON parameters field will be reflected over here. So we specified DB name over here. So it is asking me for the DB name. So let's give it as Edureka and let's give the DB password as something. Can DB root password, DB user as Edureka. Instance type as t1.micro. Why t1.micro? Because if you guys noticed in the template, we didn't specify a virtual private cloud. That is a VPC. Now all the instances which are launched these days, of which all the new instances which are there in EC2 are to be by default launched in a VPC. But since we are creating a JSON file and we didn't specify a VPC, you have to select an older version of your EC2 instance. So let it be T1. So T1 is an older version. It runs without a VPC as well. And then you have to specify a key name. The key name would basically be used to create a SSH connection to your instance, right? So our key pair was Edureka_A. We'll select that and we'll click on next. Now SSH location is basically your IP address if you want to specify. I don't want to specify it, so we'll click on next. You don't have to enter anything over here. Click on next, confirm and click on create. Now is happening in the background is it is picking up that JSON file and is creating a stack for us. Launch an EC2 instance. It will then install Linux onto that. It will then install Apache, MySQL, and then in the end a PHP installation. So what we will do, once it says that the creation is completed, we will go and check if everything has been installed on our server by creating an SSH connection, right? So let's wait until this stack is complete. Alright guys, so as you can see in the events that the creation is now complete. So let's check that if our installation has been correct. We'll go to the EC2 instance. Now this is our instance which has just been created. We can check that it's been created on March 28th, right? So today is 28th. Alright. So now let's connect to this instance. So for that, we'll have to copy the IP address. This is the PuTTY software. For those of you who don't know how to connect to EC2, you'll be pasting your IP address here, right? And then you have this private file, right? So this is of the PEM extension. But the PuTTY software needs a PPK extension. So you have to convert this PEM file to PPK. That can be done using the 𝐵 software. So this is the 𝐵 software. So I'll be dragging this file here. Okay, it doesn't work. So we'll click on load, go to downloads, click on all files, select my PEM file, click on open, click on OK, and then click on save private key. So let's name it as Edureka _A, click on save. So my file has been saved. We'll close it, go back to our PuTTY software. You have entered the IP address here. You'll click on SSH, click on authentication, click on browse, go to your PPK file, click on open, and click on open here. So now you'll be connected to your SSH, through your SSH to your EC2 instance. So any Linux installation on your AWS infrastructure, the login will be EC2-user. Alright, so you're in. Let's see if we can connect to our MySQL installation. So MySQL-edge, so it is on localhost -p port number 306, and then the user that we gave was Edureka, and the password was this. Okay guys, so we are in. So that means we successfully created the Edureka username, which we specified in the JSON script. That works well. And then you specified, okay, we also specified that we need a database, right? So let's see if it is showing our databases, or our databases have been created as well. Okay, so it has a database called Edureka, right? So the JSON script worked well. Now the thing here to notice is that how granularly you can configure your JSON file, right? First of all, it launched an EC2 instance, then it installed Linux, then it installed MySQL, it configured its settings, and inside MySQL it gave you a database, right? So this is awesome guys. So this gives you the whole control of AWS just through JSON script, right? And this is the power of CloudFormation. Now if you want this infrastructure or whatever you have created right now to be replicated again to some other instance, that can be done with a single click of a button, right? And it is actually pretty awesome, because if you were to install this LAMP stack on a server or on AWS, again, if you launch a EC2 instance with a Linux OS, installing Apache, MySQL and PHP may take time. It actually takes time because you have to open the console, you have to open the terminal, you have to enter the commands, and depending on your internet speed, you will install all those packages. So this is neat. It does everything for you automatically, right? So guys, this is what CloudFormation was all about.
What is an API? API is basically the acronym for Application Programming Interface, which is a software intermediary that allows two applications to talk to each other. Suppose you're searching for a hotel room through an online travel booking site. Using the site's online form, you will fill the necessary information like the city you want to stay in, check-in and check-out dates, number of guests, and the number of rooms. Then you click Search. But what exactly is going on between entering your information to receiving your hotel choices? Yes, that's API. The site aggregates information from many different hotels, and when you click Search, the site then interacts with the hotel's API, which delivers results for available rooms that meet your criteria. And all this happens in seconds because of an API, which acts like a messenger that runs back and forth between applications, databases, and devices. So what exactly is the AWS API Gateway? The AWS API Gateway is basically a service provided by Amazon that is used to create, publish, maintain, monitor, and secure various APIs such as REST API, HTTP, and WebSocket at any scale. As an API developer, you can create APIs that can access either Amazon Web Services or any other web services along with the data stored in the AWS cloud. As an AWS Gateway API developer, you can create APIs for use in your own client applications as well as make your APIs available to third-party app developers. The API Gateway creates RESTful APIs. The term REST basically stands for Representational State Transfer. It is an architectural style that defines a set of rules in order to create web services. In a client-server communication, REST suggests to create an object of the data requested by the client and send the values of the object in response to the user. For example, if the user is requesting a movie in Bangalore at a certain place and time, then you can create an object on the server side. So over here, you have an object and you are sending the state of an object. This is why REST is known as Representational State Transfer. The architectural style of REST helps in leveraging the lesser use of bandwidth to make an application more suitable for the internet. It is often regarded as the language of internet and is completely based on the resources. The features of API Gateway. Amazon API Gateway offers features such as support for stateful or WebSocket and stateless or HTTP and REST APIs. It is powerful, provides flexible authentication mechanisms such as AWS Identity and access management policies, Lambda authorizer functions, and Amazon Cognito user polls. You can also make use of the developer portal for publishing your APIs. It also provides canary release deployments for safely rolling out changes. It provides CloudWatch access logging and execution logging, including the ability to set alarms. You will also be able to use the AWS CloudFormation templates to enable API creation. It also provides support for custom domain names and integration with AWS WAF for protecting your APIs against common web exploits. Also, integration with AWS X-Ray for understanding and triaging performance latencies is available. So those were some of the features of the AWS API Gateway. Talking about the benefits of using the AWS API Gateway. Now, there are a number of benefits of using the AWS API Gateway. First is that it supports efficient API development. You will be able to run multiple versions of the same API simultaneously when you make use of the API Gateway, which allows you to quickly iterate, test, and release new versions. Also, you will have to pay for calls made to your APIs and data transfer out, and there are no minimum fees or upfront commitments. Performance at any scale. You can provide end users with the lowest possible latency for API requests and responses by taking advantage of the global network of edge locations using Amazon CloudFront. Throttle and traffic authorize API calls to ensure that backend operations withstand traffic spikes and backend systems are not unnecessarily called. The Amazon API Gateway provides a tiered pricing model for API requests. With an API request price as low as $0.9 per million requests at the highest tier, you can decrease your costs as your API usage increases per region across your AWS accounts. Easy monitoring. Performance metrics and the information can be monitored on API calls, data latency, and error rates from the API Gateway dashboard, which allows you to visually monitor calls to your services using Amazon CloudWatch. Flexible security controls. You will be able to authorize access to your APIs with AWS Identity and Access Management, or the IAM, and Amazon Cognito. If you use OAuth tokens, API Gateway offers native OIDC and OAuth 2 support. To support custom authorization requirements, you can execute a Lambda authorizer for AWS Lambda. RESTful API options. Create RESTful APIs using HTTP APIs or REST APIs. HTTP APIs are the best way to build APIs for a majority of use cases. They are up to 71% cheaper than REST APIs. If your use case requires API proxy functionality and management features in a single solution, you can use REST APIs. So who makes use of the API Gateway? The API Gateway is basically used by two types of developers, that is, the API developers and the app developers. An API developer is basically someone who creates and deploys APIs to enable the required functionality of an API gateway. To make use of AWS API Gateway, you must be an IAM user in the AWS account that owns the API. On the other hand, An app developer builds a functioning application to call AWS services by invoking a WebSocket or REST API created by an API developer in the AWS API Gateway. This way, the app developer becomes the customer of the API developer. Therefore, the app developer does not require to have an AWS account. However, the API that is created should either not require the IAM permissions or it should support authorization of users through third-party federated identity providers that are supported by Amazon Cognitor User Pool Identity Federation. Such identity providers include Amazon, Amazon Cognitor User Pools, Facebook, and Google. API Gateway REST API. So if you remember, we've spoken about REST API, WebSocket API, and HTTP API. Now let me just brief you about each of these. API Gateway REST API. It is basically a collection of HTTP resources and methods that are integrated with backend HTTP endpoints, Lambda functions, or other AWS services. You can deploy this collection in one or more stages. Typically, API resources are organized in a resource tree according to the application logic. Each API resource can expose one or more API methods to have unique HTTP verbs supported by the API Gateway. Using AWS API Gateway, you can create RESTful APIs that are HTTP based and can enable stateless client-server communications and also implement standard HTTP methods such as GET, PUSH, POST, PATCH, and DELETE. The AWS API Gateway WebSocket API. It is basically a collection of WebSocket routes and route keys that are integrated with backend HTTP endpoints, Lambda functions, or other AWS services. Just as REST API, you can deploy the collection of WebSocket APIs in one or more stages. API methods are invoked through front-end WebSocket connections that you can associate with a registered custom domain name. The AWS API Gateway will create WebSocket APIs that adhere to the WebSocket protocol, which enables stateful, full duplex communication between the client and the server. Also, you can route incoming messages based on the message content. API Gateway HTTP API. It is nothing but a collection of routes and methods that are integrated with backend HTTP endpoints or Lambda functions. Just as the previous two, you can deploy this collection in one or more stages. Also, each route can expose one or more API methods that have unique HTTP verbs supported by the API Gateway. Now that you have a brief idea about the three types of APIs available, let's take a look at some of the important terms and concepts that you should be aware of when you're working with APIs. First up is API development. It is nothing but a point-in-time snapshot of your API Gateway API. To be available for the client's use, the deployment must be associated with one or more API stages. API developer. This is nothing but your AWS account that owns an API Gateway deployment. For example, a service provider that also supports programmatic access. API endpoint. An API endpoint is a host name for an API in API Gateway that is deployed to a specific region. An API key. An API key is basically an alphanumeric string that API Gateway uses to identify an app developer who uses your REST API or the WebSocket API. API Gateway can generate API keys on your behalf, or you can import them from a CSV file. These API keys can be used along with Lambda authorizers or usage plans to control access of your APIs. API stage. An API stage is a logical reference to a lifecycle state of your API. These API stages are identified by an API ID and the stage name. A callback URL. When a new client is connected through a WebSocket connection, you can call an integration in API Gateway to store the client's callback URL. You can then use that callback URL to send messages to the client from the backend system. Developer portal. An application that allows your customers to register, discover, and subscribe to your API's products, manage their API keys, and view usage metrics of your APIs. Edge-optimized API endpoint. It is the default host name of an API that is deployed to the specified region while using a CloudFront distribution to facilitate client access typically from across the AWS regions. API requests are routed to the nearest CloudFront point of presence or POP, which typically improves connection time for geographically diverse clients. Integration requests. It is the internal interface of a WebSocket API route or REST API method in an API gateway. An API gateway in which you map the body of a route request or the parameters and the body of a method request to the formats that are required by the backend. Integration response. The internal interface of a WebSocket API route or REST API method in API gateway in which you map the status codes, headers, and payload that are received from the backend to the response format that is returned to a client app. A mapping template. It is a script in Velocity Template Language or VTL that transforms a request body from the front-end data format to the backend data format, or that transforms a response body from the backend data format to the front-end data format. Mapping templates can be specified in the integration request or in the integration response. They can reference data made available at runtime as context and stage variables. The mapping can be as simple as an identity transform that passes the headers or the body through the integration as is from the client to the backend for a request. The same is true for a response in which the payload is passed from the backend to the client. Method request. It is the public interface of an API method in API gateway that defines the parameters and the body that an app developer must send in requests to access the backend through the API. Method response. It is the public interface of a REST API that defines the status codes, headers, and body models that an app developer should expect in response from the API. Mock integration. In a mock integration, API responses are generated from API gateway directly without the need for an integration backend. As an API developer, you decide how API gateway responds to a mock integration request. For this, you configure the methods integration request and integration response to associate a response with a given status code. Model. A model is basically a data schema specifying the data structure of a request or a response payload. A model is required for generating a strongly typed SDK of an API. It is also used to validate payloads. A model is convenient for generating a simple mapping template to initiate creation of a production mapping template. Although useful, a model is not required for creating a mapping template. So those were some of the important terms that you should be knowing in order to move ahead with the session. Don't worry if you haven't understood it completely. We'll be elaborating more over this when we move on to the hands-on session. Before we move on to the hands-on session, let's discuss the pricing of the AWS API Gateway. With the AWS API Gateway, you only pay when your APIs are in use. There are no minimum fees or upfront commitments. For HTTP APIs and REST APIs, you pay only for the API calls you receive and the amount of data transferred out. There are no data transfer out charges for private APIs. However, AWS private link charges apply when you're using private APIs in the API Gateway. API Gateway also provides optional data caching charged at an hourly rate that varies based on the cache size you select. For WebSocket APIs, you only pay when your APIs are in use based on the number of messages sent and received and the connection minutes. The API Gateway free tier includes 1 million HTTP API calls, 1 million REST API calls, 1 million messages, and 750,000 connection minutes per month for up to 12 months. Post-free tier services, you will be charged based on the region, the type of API service that you use, and the number of requests. To know more in detail about the pricing, you can check out the official AWS API Gateway pricing page. Here, you will find all the necessary details based on the region of your choice. Now let's move on towards the most interesting part of the session, which is creating APIs using the AWS API Gateway. Prerequisites. Before using the Amazon API Gateway for the first time, you must have an AWS account. Therefore, you will have to sign up for an AWS account. And once your account has been created, you should also create an AWS Identity and Access Management, that is an IAM user with administrator permissions. To know more about how to create an AWS account, make sure to check out AWS Crash Course video from Edureka. creating a REST API using Lambda. Now, before doing that, I'll just brief you about what is AWS Lambda. AWS Lambda is basically a serverless compute service, meaning the developers don't have to worry about which AWS resource to launch or how they will manage them. All they have to do is just put the code on Lambda and it executes. The AWS Lambda executes your backend code by automatically managing the AWS resources. When we say manage, it includes launching or terminating instances, health checkups, auto-scaling, updating or patching new updates, etc. So in order to create a REST API using AWS Lambda, the first thing that you have to do is create a Lambda function. Now to do that, you will have to open up the AWS console. Now if you already have an AWS account, just log into your account. Else, create a new account before you get started. Please note that AWS will provide free services for an year, and to know more about the free tier services, you can check out Amazon's official page for the same. Now since I already have an account, what I'm going to do is just log into my account and get started. Okay, so once you've logged into your account, you'll be able to see the AWS Management Console, which is just as you can see on the screen. Now, as you can see, there is a huge list of services that are provided by AWS. So if you just scroll down, you will notice that the Lambda service is present under the compute section. So just click on that to move on to the functions list page. This page basically shows all the functions that you have created in the current AWS region. Please make a note that recently created functions might not immediately appear. It might take a while for them to show up. Now, as you can see, this page has several options such as create function, filter, actions, etc. Also, if you are a returning user who has already created some Lambda functions, you will see a list of functions that you have created, else the list will be empty. Now, if you want to create a new Lambda function, simply click on the create function option that is present at the top right corner of the page. Please make a note that the action drop-down list is not clickable. This is because the actions are to be performed on Lambda functions that are already created. So if you do not have any function, you will not be able to click on the actions list. However, if you have some function present already, select the function and you will see that the actions list gets enabled and it provides three options, that is view details, test and delete. As the name suggests, these actions will help you view the Lambda function details, test it or delete the functions if it is no longer required. Now, since we are focusing on creating a Lambda function, let me just create on the create function option. So now we've moved on to the create function page. The first option is author from scratch that allows you to create the Lambda function completely on your own. So if you want to create your own Lambda function, just give a suitable name and specify the runtime that you prefer. In our case, the name of the function will be Hello World. The runtime or the language that I want to make use of is Python. So I'll just select Python 3.8. So next up, after the runtime, you see something called as permissions, which basically refers to the function permissions. By default, Lambda will create an execution role with permissions to upload logs to the Amazon CloudWatch logs. Amazon CloudWatch is nothing but a monitoring and management service. It provides data and actionable insights for AWS, hybrid and on-premises applications, and infrastructure resources. When you make use of AWS CloudWatch, you can collect and access all your performance and operational data in form of logs and metrics from a single platform. However, the default role can be customized later when you wish to add triggers. Okay, so now I'll go ahead and click on Create Function option. It will take a few minutes to do so, so let me just wait for the same. Okay, so once the function has been created, you will see the message just as you see on the screen, which says successfully created the function Hello World, which is the name of the function that I just created. Now this page basically allows the user to manage the code and the configurations. Once you have provided the required code and its configurations, simply click on Test in order to execute the code. Now before doing that, let me walk you through this page. The first element that you see over here is page configuration. This element has something called as the designer. Here, you can add triggers, layers, and destinations to the Lambda function that you have created. A trigger over here refers to an AWS service or a resource that is used to invoke the Lambda function. Now, if you want to connect your function to a trigger, just click on Add Trigger option. And as you can see, there is a drop-down list over here with a huge list of triggers that you can choose from. Choose any service from the list to see the available options. As of now, I will not be using any of these, so I'll just click on Cancel to get back to the previous page. The next thing that you see over here is two options, that is the function that you've just created, which in my case is Hello World, and below that is Layers. By default, the function is selected, and when you scroll down the page, you will be able to see the code editor and a sample code that has been generated automatically for our function. Now, this is a very simple function called as the Lambda handler, which simply returns a message saying Hello World from Lambda. The code editor in AWS Lambda console enables you to write, test, and view the execution results of your Lambda function code. Okay, so now let me just scroll back up and select the Layers option. Layers are basically resources that contain libraries, a custom runtime, or other such dependencies. You can create layers to separate your function code from its dependencies. By default, no layer has been added. To add a layer, all you have to do is choose Layers and then click on the option Add a Layer. To include libraries in a layer, place them in a directory structure that corresponds to your programming language. Now, since we have a very simple function, I will not need any extra layer for it. But just for the sake of showing you guys, let me click on Add a Layer option. As you can see, there's a drop-down list present over here as well. There are two more options that are present over here. One is Custom Layer and the other one is Specify an ARN. In the Custom Layer option, you will see any of the previously used or created layers. Since I've not used any, my list is blank. The next option that I see over here is to use an ARN. ARN basically stands for Amazon Resource Name. Entering an ARN enables you to use the layer that is shared by another account or a layer that does not match your function's runtime. The format in which you should specify an ARN is shown in the text bar itself. Okay, so now let's get back to the previous page. So I'll just click on Cancel. Next up is the Destinations option. Destinations are AWS resources that receive a record of an invocation after success or failure. You can configure Lambda to send invocation records when your function is invoked asynchronously or if your function processes records from a stream. To add a destination, choose Add Destination option. The contents of the invocation record and supported destination services vary by the source. Now, the next element that is present over here is permissions. Like I've already mentioned before, the default execution role that we used for this Hello World Lambda function has permission to store logs in Amazon CloudWatch logs. Now, this is the only permission it has got for now. The resource permissions can vary depending on the role that you select for the function. Finally, the monitoring element of this page. When you click on this page, you see some graphs which are not showing any data for now. This is because I have not invoked my function as of yet. Once the function is invoked, you will be able to monitor, trace, and debug your Lambda functions. Okay, so coming back towards the Hello World function, let me just scroll down to the code editor. So now, to invoke this function, I will have to test it. Before clicking on Test, let me just show you the default test event that is present. Now you can open the test configuration either by clicking on Select a Test Event dialog box or opening the drop-down list that is present next to the test option in the code editor. So let's click on Configure Test Events. Okay, so now as you can see, there are some default test events that are present over here. Also, by default, the Create New Test Event option has been selected. The other option is Edit Save Test Events that cannot be selected as I have not created any test event before. So what I'm going to do is just give some name for this event, say Event 1, and then I will click on Create. Okay, so now our function is ready. To invoke the Lambda function, click on Test. As you can see, the message says execution result has succeeded. When you open the details, you will be able to see the summary of the log output. The summary section shows the key information such as the time taken for the execution, build duration, which is 100 milliseconds, request ID, etc., reported in the log output. the log output section will show the logs generated by the Lambda function execution. When you check the monitoring page this time, you can see that the metrics over here have updated. In order to gather some more metrics, all you have to do is just execute or run the Lambda function a few times. Okay, so now our Lambda function is ready. The next thing that we have to do over here is create the API gateway. So in step 2, you have to get back to the AWS console and from Networking and Content Delivery Service list, select API Gateway. Now in case you have already created APIs earlier, you'll be able to see them just like how you were able to see the Lambda functions list. Now, if you want to create a new API, click on Create API option. If you are using the API Gateway list for the first time, you see a page that introduces you to the features of the API Gateway. Now, since we are constructing on building a REST API, I will click on Build from REST API option. When you do this, you'll be able to see the Create New API page. Under Settings, for API name, you can enter any name and I'll be entering New API. Next, if you wish, you can enter a description in the description field. However, this is optional, so you can leave it empty as well. In my case, I'll just leave it empty. For the endpoint type, I'll keep it regional. Now once that is done, click on Create API. Okay, so as you can see, under Resources, there is nothing but just a slash. This basically depicts the root level resource, which corresponds to the base path URL for your API. Next, click on the Actions menu. From the Actions menu, click on Create Method. When you do this, you will see that a new drop-down menu pops up below the root directory. This list basically consists of basic API methods such as get, put, post, delete, etc. For the purpose of this tutorial, I will select the get method and click on the tick mark beside it in order to save the choice that I just made. So as you can see, the get method setup pane has opened and by default, the Lambda function option has been selected. If you remember, prior to creating this API, we created the Lambda function that we wish to use along with this API. So next, select the Use Lambda Proxy Integration option. For Lambda region, choose the region that you created the Lambda function in. In my case, it's Ohio. Now since Ohio is in US East 2, I'll just keep the region as US East 2. Please select the region according to where you have created your Lambda function. In the Lambda function field, enter the name of the Lambda function that you created earlier. Okay, so as you can see, the moment I type H, the function hello world is displayed in the drop-down menu. In case you forget the name of the function that you have created, just type any character and delete it. Then you will be able to see a drop-down menu that shows the Lambda function that you have created earlier. Leave the Used Default Timeout checked and finally click on the Save button to save your choice. Okay, so as you can see, a pop-up named Add Permission to Lambda function has been displayed that says, you are about to give API Gateway permission to invoke your Lambda function. Now this is exactly what we want. So just click on OK. So next up, you will see another pane that is Get Method Execution pane. As you can see, this execution pane consists of a number of items. The client box over here represents the client, which is the browser or the application that calls your API's get method. If you click on the test link and then click on test, this simulates a GET request from a client. The method request box represents the client's GET request as it's received by API Gateway. If you choose method request, you'll see settings for things like authorization and modifying the method request before it's passed through to the backend as an integration request. Now for this demonstration, I leave everything set to the default values. The next box that you see is the integration request box. This box represents the GET request as it's passed to the backend. Here, the settings depends on the integration types that's selected. The URL path parameters, URL query settings parameters, HTTP headers, and mapping template settings are for modifying the method request as needed by the specific backend. The integration type for this demonstration will be set to Lambda function, and I leave the other settings set to the default values itself. So the next box represents the backend Lambda function that you have just created. If you click on this, it opens the Lambda function in the Lambda console. Integration response. The integration response box represents the response from the backend before it's passed to the client as a method response. For Lambda proxy integration, this entire box is grayed out because a proxy integration returns the Lambda function's output as it is. For a Lambda non-proxy integration, you can configure the integration response to transform the Lambda function's output into a form that's appropriate for the client's application. We'll be doing it later on in the other demonstrations, but for now, I'll just leave everything set to the default values as I've mentioned earlier. Method response. The method response box represents the method response that's returned to the client as an HTTP status code, an optional response header, and an optional response body. By default, the response body that's returned to your Lambda function is passed through as it is as a JSON document. So the response body default setting is application/JSON with an empty model indicating that the body is passed through as it is. For this as well, I'll just leave it set to the default values. Okay, so next is step 3. In step 3, you will have to deploy your REST API in the API Gateway console. Now until here, you've created your API, but you cannot actually use it. This is because it needs to be deployed. To deploy this, all you have to do is click on the Actions drop-down menu and choose Deploy API. From the Deployment Stage drop-down menu, click on New Stage, and for stage name, just enter prod. Once that is done, click on Deploy. So as you can see in the prod stage editor, the invoke URL is present right at the top. If you choose to invoke the URL, it will open a new browser tab with that URL. Now when you refresh this, you will see the default message that is hello from Lambda. Now if you wish to test the API that you've just created, you can make use of various tools such as curl or Postman. In this tutorial, I'll be using curl. Therefore, I'll show you guys a quick demonstration of how to install curl for Windows operating system. So what I'm going to do over here is just open the browser and search curl for Windows. Select the option curl for Windows and then you will see two options, that is 64-bit and 32-bit. Select the appropriate option that suits your system and download the same. Once it has been downloaded, extract the files. So the next thing that you have to do is open the bin directory of this folder, paste its path in the path variable, which is present in your system environment variables. So just open your system environment variables, select path and click on new. Paste the path that you've just copied followed by a slash and then click on OK. Now to test the API, open the command prompt and type the following command along with the link of the API that you've just created. So curl -x get in caps followed by the link. As you can see, I have the desired output displayed on the screen which says hello from Lambda. So the next part of our demonstration deals with creating another Lambda function. What I'm going to do over here is add a parameter to the Lambda function. So click on the service drop-down list and select Lambda. Just as before, click on create function and I'll just name my new Lambda function as hello world 2 and the runtime will be Python 3.7. Under permissions, expand choose or create an execution role and from execution role drop-down list, choose use an existing role. From existing role, choose the role from your previous Lambda function. Also, you can create a new role with basic Lambda permissions. Then choose create function. In the function code pane, you'll see the default hello from Lambda function. Now what I'm going to do is just replace the entire function with the code that I've already kept ready over here. So I'll click on deploy. And the next thing that I'm going to do over here is add a resource, method, and parameter to the REST API in the API Gateway console. So I'll just click on Services, and then I'll click on API Gateway. From the APIs list, choose New API, and under Resources, click on /. Next, click on the Actions drop-down menu and click on Create Resource. For resource name, I'll just enter my resource. So notice that the resource path field is populated automatically with the resource name. Choose Create Resource. Next, from the Actions drop-down menu, choose Create Method. And under the resource name, that is My Resource, you will see a drop-down menu. Choose Get, and then I'll just click on the checkmark icon to save the choice. Now in the My Resource Get Setup pane, for integration type, I'll just keep it as Lambda function. And for Lambda region, just like before, we'll choose the same region where we've created the Lambda function. In my case, it's US East 2. In the Lambda function box, type any character and then choose the Lambda function that you've just created, which is Hello World 2 in my case, from the drop-down menu. Now, in case the drop-down menu doesn't appear, just like I've told you earlier in the first session, type any character and just delete it. So once you've selected the Lambda function that you created, click on Save. So once this is done, you will see the Add Permission to Lambda function pop up. Now this basically says that you're going to give API Gateway permission to invoke your Lambda function. Now since this is what we want, I'll just click on OK. In order to grant the API Gateway the permission that is required. Now once that is done, you will see the My Resource Get Method Execution pane. Unlike the previous session, this time the integration response box is not grayed out. So just click on Integration Request and then expand the Mapping Templates option. Okay, so next, set the Request Body Pass-Through option to when there are no templates defined. So I'll just do that. And then I'll choose Add Mapping Template. For the content type, what I'm going to do is just type application/JSON and choose the checkmark icon. And then I'll click on the checkmark icon. Now in our case, the content type is application/JSON. Now in the template window, I'll just enter the code that I've already kept ready. Now this is the JSON document that will be passed to your Lambda function in the body of the input event object. The right-hand side of this tells the API gateway what to look for in your input query string. The left-hand side stores it into the parameter that you're about to add to your Lambda function. So once that is done, just click on Save. And from the Actions drop-down menu, I'll choose Deploy API. From the Deployment Stage drop-down menu, click on Prod and then choose Deploy. So as you can see, again, I have the invoke URL present over here. The next thing that I'm going to do is test the API that I've just created. So what I'm going to do is just open the command prompt and I'll enter the curl command, that is curl-x get followed by the invoke URL. Okay, so as you can see, I have the desired output, that is hello from Lambda. In the next part of our demonstration, I'll be showing you guys how to create an API gateway directly through the Lambda service. So get back to the Lambda console and select the Lambda function that you've created. As you can see over here, it shows that a trigger that is an API gateway has already been added. Now click on Add Trigger. From the drop-down list, select API Gateway. So I'll just click on API Gateway and then select the Create New API option from the API drop-down list. And for the API type, I will just select HTTP API. Now the security can be kept open since this is just for demonstration purposes. Please make note that for real-time applications, you cannot keep the security option as open. Then click on Add. Now when I come back to the Lambda function configuration page, you will see that there are two API gateways for this function. When you scroll down, you will see both the APIs that have been created. Open the details of the Hello World API and click on API Endpoint link. Okay, so as you can see, the function returns hello from Lambda. Now I'll just click on test a few times and then I'll open the monitoring page to see the metrics. So as you can see over here, I have the corresponding metrics for my Lambda function through the API that I've just created. So till now, we have seen how to create a REST API using the Lambda function through various methods. The next thing that I'm going to show you over here is how to create a REST API with mock integration. A mock integration basically enables your API to return a response for a request directly without sending the request to a backend. This enables you to develop your API independently from your backend. So the first thing that you have to do over here is create the API. Now for the purpose of this demonstration, I will create an API with the get method and a query parameter in the API gateway console. What I'm going to do over here is get back to the API gateway pageant, and then I'll click on create API just like we've done earlier. On the next page, what I'm going to do is click on build for REST API. So under create new API, choose API, and for the settings, I'll keep the API name as my API, and just like before, the description is optional, so I'll just leave it blank. Okay, for the endpoint type, set it to regional. The next thing to do is click on create API. Now as you can see, the methods page option is empty, just like it was earlier. So from the actions drop-down menu, click on create method. Under the resource name, that is /, you will see a drop-down menu. So from this drop-down menu, I'll just click on get, and then I'll just click on the checkmark icon to save the choice. So now as you can see, the get setup pane has appeared. Over here, for the integration type, I'll choose mock, and then I'll just click on save. Now we move on to the get method execution pane. Okay, so now we've moved on to the get method execution pane. Now the terms that are present over here have already been explained in the previous session. So in case you guys want to know what they are, just get back to the previous session and take a look at it. So for the next thing, what I'm going to do is create the mock integration. In this step, instead of integrating with the backend, I'm going to add a query string parameter to the get method, and then I'll specify the response codes and messages that our API will have to return. So first, create the query string parameter. Now for this, I'll just choose method request. In the get method request pane, I will expand URL query string parameters, and then I'll choose add query string. Over here, I'll just type my string for the name. I'll click on the checkmark icon. Okay. So next, what I'm going to do is create a mapping template that maps the query string parameter values to the HTTP status code values that are to be returned to the client. So I'll just get back to the method execution pane, and then I'll select on integration request. Okay, so from the integration request, I'll expand the mapping templates pane, and for request body pass-through, I'll choose the recommended option, that is when there are no templates defined. Content type again will be application/JSON. So I'm going to replace the contents that are present over here with the code that I've already kept ready. So I'll just paste it, and then I'll just click on save. So step 3 is to define the successful response. So what I'm going to do over here is create a mapping template that maps the HTTP 200 status code value to a success message that is to be returned to the client. So I'll just click on method execution, and from here, I'll move on to the integration response. Now expand the 200 response, and then expand the mapping template section. Okay, so under content type, I'll just choose application/JSON. And for the template contents, I'll just have a basic message that says hello from Edureka. Okay, so I'll just paste that over here, and then I'll click on save, that is present in the mapping template section. Please make a note over here, guys, that you can see 2 save options. One is in the mapping template section. From both these options, you will have to select the save option that is present in the mapping template section. Now in step 4, I will add an HTTP 500 status code and an error message. Okay, so in this step, what I'm going to do is add an HTTP 500 status code that the front end can return to the client, and then you map it to an error message. So first, I'll have to add the 500 status code. So I'll just get back to method execution, and I'll click on method response. Then just click on add response. For HTTP status, enter 500, and then click on the check mark, and then I'll just click on the check mark icon. Okay, so now create a mapping template that maps the returned 500 status code value to an error message from the front end to the client. So for that, I'll just get back to the method execution pane, and I'll get into integration response. Then I'll choose Add Integration Response. And for HTTP status regular expression, enter 5/D and 2 within curly braces. Now for method response status, choose 500 from the drop-down menu and then just click on Save. Next up, all you have to do is expand the 500 response and then expand the mapping template section if it isn't already expanded. Under content type, I'll choose Add Mapping Template, and in the box under that, I'll just enter application/JSON, and then I'll click on the check mark icon. Now the message over here will be replaced saying that this is an error message. Okay, so I'll just paste that and I'll save the changes. Now for the final step, that is step 5, I'll have to test the mock integration. So I'll just click on method execution and I'll just click on the test option that you see over here. Now under query string, I'll just enter my string equals my value. And then I'll choose test. So as you can see over here, we have our desired output that says hello from Edureka. Now this basically means that we have successfully created the mock API. Now in case you want to check if the error condition is also working, all you have to do is just go back to the query string text box and just delete some item from there. What I'm going to do is just delete whatever value is present for my string and I'll just leave it as an empty string. Okay, and then I'll click on test. So there it is. You can see the desired message that says this is an error message. So this brings us to the end of this AWS API Gateway.
So what is Amazon SES? Amazon SES, or Simple Email Service, as the name describes, is an email service for sending both transactional and mass emails. It is cloud-based and offers a wide list of possible integrations. You have your SMTP interface, which is your Simple Mail Transfer Protocol, which is a communication protocol for email transmission. As an internet standard, your SMTP is an application that is used to send, receive, and relay outgoing emails between senders and receivers. When an email is sent, it's transferred over the internet from one server to another using SMTP. In simpler terms, an SMTP email is just an email sent using the SMTP server. You also have the AWS SDKs with seamless integration with your applications, and even email clients or other types of software. But then you have your regular email service. Why do you want to use AWS? Now, AWS can boast its reliable infrastructure at a very reasonable cost. Amazon prices are very competitive compared to other solutions available in the market for this particular service. If you check its consumer reviews, you will notice it as the most often mentioned advantage, as with other things on the AWS console. But we are going to take a closer look at the Amazon prices as well as its advantages and disadvantages a little bit later in this Amazon SES tutorial. Here we are just going to discuss the main features and the appeal of Amazon SES. First of all, its high deliverability or its deliverability rate. It's one of the main parameters to consider when choosing an email sending service. Amazon takes reputation and whitelisting extremely seriously by supporting all three authentication mechanisms, which are DKIM or Domain Keys Identified Mail, which is an email security standard designed to make sure your messages aren't altered in transit between sending and recipient servers. It uses public key cryptography to sign email with a private key as it leaves a sending server. There's also SPF, which allows email senders to define which IP address are allowed to send mail from a particular domain, and it's better known as your sender policy framework. You also have DMARC, which is domain-based message authentication, reporting, and conformance, which is an email authentication protocol which basically uses the sender policy framework. So as a sender, you authenticate your email using SPF and DKIM, and you publish a DMARC record in your DNS. In addition, you can track all of your sending activity and manage your reputation as well.
So obviously, it's highly deliverable. Next, you get content personalization with replacement tags. Personalized emails are messages tailored to a specific user, notwithstanding the name. Personalized email are a part of automated marketing. They are created with special templates that become individual due to its dynamic content. Your username, date of birth, location, behavior, all in the app. Each of these parameters change from user to user and may affect the type of information included in the message. With dynamic content, you can personalize emails with the user details or even show different information to different users. It's done with variables or placeholders or merge tags. The most common example is sending a newsletter to a list of subscribers and inserting their first names into the welcoming sentence. I'm pretty sure many of you might have gotten emails that way, which seems sort of generic but also personal at the same time. In this case, you use one template and add a first name tag for personalization. And finally, email receiving. Now with Amazon SES, you can not only send emails, but also retrieve them. In this case, you have a set of flexible options as well as usage of the received message as a trigger in AWS Lambda. Now we won't go into details of email receiving in this Amazon SES tutorial. So if you're interested in this feature, you can obviously read up more on it on the official documentation. Now the most obvious use case for the Amazon SES is supplementing a list of other AWS services you already work with. Amazon SES easily integrates with Amazon CloudWatch, Amazon EC2, Amazon Elastic Beanstalk, AWS IAM, AWS Lambda, Amazon Route 53, Amazon S3, Amazon SNS, and Amazon Workmail. So if your app is hosted in Amazon EC and it sends emails with the simple email service or the Amazon SES, the first 62,000 of your monthly emails will be free. This way, if you host your app on Amazon EC2 and need a scalable way of sending emails, Amazon SES is an extremely beneficial choice. So versatile integration is your fourth point. Another point which is extremely important for a service like this is pricing. So let's take a look at Amazon SES's cost. Now, as I already mentioned, if your app is a part of Amazon EC2 or Elastic Beanstalk infrastructure, then you're eligible for a free tier and the first 62,000 emails are free every month. For all other cases, Amazon's policy of pay for what you actually use applies. For emails over the 62,000 limit, you will pay as much as 10 cents or $0.1 for every 1,000 emails that you send, plus 12 cents or $0.12 for each GB of attachments. If your app is not hosted on Amazon's server, the cost will be the same. You have 10 cents for every 1,000 emails you send and 12 cents for each GB of attachment. The only difference is that you will start paying from the message sent. This means that the 10,000 emails without attachment will cost you only $1. If each of these messages have 1 MB of attachment, you will add $1.18 to your payment. The Amazon SES email size is limited to 10 MB. This means you can pay up to $3 for 10,000 emails without monthly charges. If you need a dedicated IP address for more security, it will cost an additional $24.95, so not even $25 per month. Again, an AWS calculator where you can go ahead and look for specific and detailed pricing for your requirements. This is very, very helpful in cost estimation. Moving on, let's discuss a few pros and cons of Amazon SES. Now, Amazon services definitely have both fans and haters, but in general, the concept and especially the cost of Amazon SES are more than inspiring. However, even the moon has its dark side. So let's sum up the pros and define the cons. In addition to my own experience with Amazon SES, I've also reviewed what users have to say on certain platforms such as TrustRadius, Quora, and Stack Overflow. So that is going to be my point of reference for this particular section. Let's first look at advantages. Now, the pros of Amazon SES obviously include high deliverability, as we discussed before, and reliability, along with high sending rates. Apart from this, you don't need any additional maintenance once you have it all set up. So obviously it's pretty low maintenance. Third point is something I shouldn't even have to mention, which is best quality to price ratio. And finally, you also get a comprehensive set of tools for both email receiving and further management of your infrastructure. Since we spoke about this extensively in the features section, this was a brief recapitulation of that segment. But the cons or the disadvantages is what I want to speak slightly more in depth about. So first con, it has a quite complicated initial configuration. Well, I would call it rather detailed and lacking exhaustive documentation, which I think is one of the selling points of most AWS services, that it has really great documentation. You can follow it word for word and you will never face any issue. And you obviously need a good set of documentation when you start working with a new service. But we're going to solve that issue for you with this Amazon SES tutorial. So no problems there. The next point is there are a few initial limitations before you get approved and verify your sending domains. You need to correctly configure Amazon SES and expand your limits by submitting requests. The third reason is that Amazon SES is a simple sending service and not a marketing platform. And it has been advertised that way to all the right, which is fair. However, many users find the lack of template building extremely confusing. If you're not a web developer and you need to send responsive emails with Amazon SES, what should you do? It's kind of a pain that needs a solution. And in addition to this point, Amazon SES does not provide you with an email list storage, so that is on you. Now, because we discussed the cons of Amazon SES, it is only fair that we see how SES compares to other services. It is often seen as an alternate to SendGrid or MailChimp, which are email marketing platforms rather than email sending services. Amazon SES offers both SMTP and API integration. On the other hand, it is simply for email sending and doesn't feature any additional options like drag and drop templates, A/B testing, or detailed analytics. But there are several tools similar to SES with varying functionalities. First of all, you have Mailgun. This is an email service for developers, which you can also integrate with your app via API or SMTP. In addition to email sending, it offers an email list management and validation system. However, compared to the Amazon SES, it's only fair to say that Mailgun is a way more expensive tool. Next, you have ClickSend, which is a dedicated email sending service. You can integrate it via API or SMTP, or use its dashboard for marketing emails as well. And finally, you have PeppyPost, which is an email sending service as well, and this can be integrated via API or SMTP Relay and offers extremely competitive pricing to Amazon SES as well. Now, it is worth mentioning that these are several platforms built on top of Amazon SES. They use it as a delivery service and add extra functionalities like email templates. Email Octopus and Sendy are a few tools that they use. Now that you have decided to go with Amazon SES, or at least experiment with it, which is why I'm assuming you are following this tutorial, then this is the section for you. Now, of course, I'm always going to recommend following the official documentation, which you can look at after this Amazon SES tutorial. Indeed, there are many details that you should be paying attention to when you configure your Amazon SES for the first time. But the official guide has dozens of sections which is interlinked, and it's extremely easy to get lost off a linear track if you're trying to dive in deeper. So I've gathered the most important points here, briefly explain them, and then basically I'm going to show you on my management console how to go about this setup. Now, if you're totally new to AWS, what you need to do first is create an Amazon Web Services account first. Yeah, it's your AWS free tier account. You'll be required to enter your credit card information at the registration stage, but you won't be charged until you start using the paid services. So you can go ahead and select the free plan out of the 3 plans to start, and you will get access to all of the Amazon services. Next, you're going to go into your AWS Management Console. This is what mine looks like, and select Simple Email Service from the list of services. So let's go on search and type SES. You get the Simple Email Service. I'm going to click on this. Okay. Now what we're going to do is we're going to verify email address identities. Yes, it's a little bit annoying, but it's a matter of security and high deliverability. So what you need to do is verify the email identities that you use. So on the left hand side, I'm going to go and create my SMTP credentials. Now to send emails through the Amazon SES SMTP interface, which is the one we're going to use right now, we are going to begin by creating the SMTP credentials, which is a username and a password. So in the left navigation bar, I'm going to click on SMTP settings. And here you can see your server name, your port, your TLS configuration, and your authentication. I'm going to go ahead, click on this blue button which says create my SMTP credentials. All right. Now you will get a form which says this form lets you create an IAM user for SMTP authentication with Amazon SES. Enter the name of a new IAM user or accept the default and create to set up your SMTP credentials. So what you're going to do right now is copy your credentials because this password will not be shown to you again. So I'm going to open So my SMTP security credentials are here. You have your SMTP username and password. So either copy it or you can click on download credentials. So I am just going to copy it because I already have a notepad open. All right. So I'm just going to click on download credentials. And then I'm going to close it. So next what we're going to do is we're going to verify an email address. So we're going to add and verify our own email address using a few steps. So I'm going to go on to my Amazon SES console. So this is our SES home. We are going to go to email addresses and click on verify a new email address. So now we'll be presented with a dialog here. We are going to enter the email address that we wish to send messages from. So I'm going to type my address and I'm going to click on verify this email address. So now we have a verification email sent to my particular ID. You should just about now receive a verification message from Amazon SES asking you to confirm that you are the owner of this email address. I'm quickly going to go and click on the verification link in my mail. And voila, you have successfully verified an email address and now you can send emails from this address. So I'm going to go back here to this page and refresh it. I'm going to check the status of the email address. And as you can see, the verification status says verified. Now, all of this is a little bit annoying, but it's a matter of security and high deliverability. And that I have mentioned before. You need to verify all the email identities that you use here using the same process. But remember one thing, that your email addresses are case sensitive, and another important thing in using AWS is its regions. So remember that they are the physical locations of Amazon data centers available to any customer. These regions don't limit the usage of AWS services for you, as their purpose is distributing workloads basically. So when getting started, you don't need to worry about this, but if you want to scale your services, you should remember the corresponding limits. In addition, email verification is connected to the region. The easiest way to verify your email addresses is to use the Amazon SES console. It doesn't require any coding skills, and even if you're not a tech savvy, you will be able to walk through this process within seconds. All you will have to do is enter your email address and then press the link in a confirmation message that you will receive in your inbox. So I'm just going to quickly add like 2 more email addresses. Now, domain verification is a standard procedure as well. You need to add a TXT record to your domain's DNS server. Once your email addresses are successfully verified, you can now start sending emails from them. But note that you need to start in a sandbox mode, which basically means that you can send email to verified email addresses and domains or to the Amazon SES mailbox simulator only, and you can only send up to 200 messages in 24 hours and only 1 message per second. Sounds complicated, right? A bit, but this is the price you pay for security and sender reputation. However, in my opinion, for experimenting with Amazon SES and understanding how it works, just the basic bare minimum, the sandbox mode is enough. But then again, to move forward and start sending messages to your customers without a need to verify recipients, inboxes, domains, you should basically need to submit a request via the AWS Management Console. In your request, you should describe how you or your enterprise is going to use Amazon SES, build your mailing lists, handle bounces, etc. Now, once you have successfully completed verification, reviewed main AWS definitions, and figured out how all of this actually works, you can move to the email sending. As we have already discussed, you can use SMTP or API. In this particular step, you should define exactly how you would like to send your emails. With SMTP, you can send an email from your application if you are using a framework that supports the SMTP authentication. You can also send messages from software packages you already use, such as your blogging platform, your workflow system, etc. You can also send emails right from your email client and finally integrate it with a server where you host your app. Servers such as your Postfix, Exim, and other such examples. Now, obtaining the Amazon SES SMTP credentials are fairly easy. We saw it a while ago. These are mine in my notepad, as well as integrating your email client or software package. These options might be a good fit for non-developers as well. API integration, however, requires definite technical skills and can be used to make raw query requests and responses, use an AWS SDK, as well as use the CLI or the command line interface. Now, it's time for you to go from theory to practice. Let's review one of the widely used types of integration, sending emails using Amazon SES. Now, I assume you have already obtained your SMTP credentials and switched your Amazon SES instance to the production mode. If you already haven't, you can just, in your left navigation bar, under email sending, go to sending statistics, edit your account details, and enable production access. You can also do this straight out of your sandbox. Yeah? The good news is that the most complicated and time-consuming part is now behind us. All we have to do is integrate our WordPress with Amazon SES for sending notifications or even newsletters. Now for this, you have 2 options. So now what we are going to do is we are going to send a test email using Amazon SES. So I'm going to go to email addresses. I am going to send a test email from one address to another. You can also send it from one address to itself because that address is verified by us. So I'm going to click on this and I'm going to click on send a test email. From this address of mine to this one, I'm going to select formatted and something simple. Maybe this is a test email. And the email has been sent. All you have to do is go ahead and refresh. And now as you can see, we have our test email saying this is a test email. Okay, now we are going to go back here again, send another test email from the same email address and the same recipient, except for now we are going to use the raw email format. Now, one thing you must have directly noticed is that you have no options in your subject line here. In your formatted email, you have a lot of these options, but when you click on draw, you have no such options. So I'm going to go this, put in your recipient address and your sender's address, and this is a little piece of code. So here I'm going to paste some sample formatted text for this particular email, and you can go ahead and put in your body as well. Now the raw message is a JSON data structure saved in a file named message.json in the current directory. And as you can see, the data is one long string that contains an entire raw email content in MIME format, including an attachment called attachment.txt, which is right here. So I'm going to go ahead and send the test email. And here is the email I sent to myself. It has the sender address and it has the address of the recipient and everything that was there in the email. So alright, that was sending a simple email using the Amazon Simple Email service.
Our first topic is, what is Amazon Honeycode? Amazon Honeycode is a fully managed service that allows individuals to quickly build powerful mobile and web application. This can be used by individuals who need application to track and manage things like process approvals, event scheduling, customer relationship management, for user surveys, or it can be as simple as making a to-do list or even content and inventory tracking. This service would be right for them because they no longer have to do so by error-prone methods like emailing spreadsheet or documents, or hiring and waiting for developer to build them a costly custom application. Now this application is only available in the beta version. Beta version is nothing but a pre-release of software that is given out to a large group of users to try it under real conditions. Now that you people know what is Amazon Honeycode, let us move on to the next topic and see an overview on Amazon Honeycode. So in this session, we will take a look at what are the features available in Honeycode in order to build our application. Firstly, we have the Honeycode table. This table looks exactly like a spreadsheet table, but acts as a database table. The values you enter here are stored in the database. You can enter your own data, or you can also transfer CSV file from Amazon S3 to Honeycode. And you can do this with the help of Amazon AppFlow. Honeycode table supports pick lists and checkboxes, and you can also relate data across multiple tables. Your data format can be either text, number, contact, which could include name, phone number, email ID of a person, or it could be currency, percentage, or date and time. So the next part of Amazon Honeycode is the app build, which is usually used to build your application screen or the user interface. Now this is where you connect your data from the tables to an app interface. You can either choose to build your application from scratch or use the existing app wizard to start with a set of pre-configured app screens. You can add a lot of features such as switches, buttons, forms, radio buttons, and many more. If you want, you can also add objects for user inputs in the app. You can experiment a lot and choose the right one for your application. And with app build, you can also build separate layout for mobile and web applications. After the app builder, we have automation. Now automation, as the name suggests, will allow you to add immediate actions after a particular instance happen. The automation available in Honeycode are send notification, which will notify a particular member of your team that a task is assigned. Then you can also add, delete, or update any row in the database table. You can also override some of the values in the table. For example, if a task is completed, you can just update a table with a click of a button. Then we also have navigate, which will navigate the user to a particular page. Now that you have an overview of Amazon Honeycode, let us move on to our next topic and see some of the benefits of using Honeycode. One of the main advantages, in order to build your application, no programming knowledge is required. So anyone can be an app builder. The second advantage is you can build web and mobile application that works on your desktop browser, iOS, or even Android. You can also change the interface for web and mobile application, which means you can have a different interface for desktop browser and different for your mobile phones. Honeycode application helps teams stay in the loop. This is because all teammates have access to the same data, which can be updated in real time. It can also help your team members stay focused because the app can be personalized to show data that's relevant to each individual team member. With HoneyCode, you can also automate manual steps, and you can notify the team about updates or remind people when it's their turn to take action. The fourth advantage is you can customize this application at any time, and the changes will be deployed immediately. Also, you can access this application from anywhere across the globe. These were some of the benefits of using Amazon HoneyCode. Now let us move on to the next topic and see a case study on Amazon HoneyCode. So in today's session, we'll discuss a testimonial by Laura Otalora. So Laura and her sister started selling colorful face masks using social channels such as Instagram and Facebook. So when the orders started flooding in, it was difficult for them to stay organized as they were coordinating orders across multiple social accounts while managing their inventory levels. They were operating in both the US and Colombia. Initially, they tried emailing spreadsheet back and forth to track the orders, but it was causing a lot of confusion and also wasted a lot of time. So they started using HoneyCode. They built a simple application which was suitable for their business requirement. Their HoneyCode application helped them input orders, track payments, and record when the orders were shipped. As a result, the sales went up to 25% because they were able to spend more time with the customer and less time coordinating orders. Now let us move on to the demo part and build an application for employees' task list. So let's search for Amazon HoneyCode. We click on this link. It should direct us to Amazon HoneyCode page. So if you don't have an account, you can just create one over here. All you have to do is enter your full name, your email address, and create a password. But I already have an account, so let me just sign in. So when you log in for the first time, HoneyCode will guide you how to start. What steps should you take to create an application? So our first step is to create a table. So we'll just click on Create Workbook over here. It will give you a set of options. You can either start from scratch or import a CSV to table, or you can use either one of this template. We'll start from scratch. Let's name our workbook as Team Task and create a workbook. Now you can see the HoneyCode table looks just like a spreadsheet, but actually is a database table that stores your data. Now let's start adding values to a table. First, we'll edit the column names. So first column would be serial number. Second, the name of the task. Third one, assigned to whom. Fourth column would be what is the status of the task. Next, we have the start date and the deadline. Now let's enter the value for our tables. One, name of a task will have Amazon HoneyCode. It will be assigned to, let's say it's assigned to me. And the status is pending. Now the start date, let me give as 10/4/2021. And the deadline, let me say, I'll give it a week time, 17/4/2021. Now we can change the format of the states. Just click on this, go to formats, and just click on date. Now the format is set for start date. Now let us do the same for deadline as well. Format, date. Now let's add another value. 2, let's say Amazon EC2. Let it be assigned to me and the status would be done. Start date 5/4/2021 and the end date will give it as 11/4/2021. As I mentioned in the theory before, this table also supports pick lists and checkboxes. Now let us add a pick list to a status. So we'll select this column, go to format and select pick list from here. So we'll click on the source over here and create a new source. And here we have the table name as table1 status. Like this is the column we want to add a pick list to. Then the pick list items will be done and pending. So we'll just save it as another table. Now you can see we can change the pending to done if you want to. So our table is done. Let us now rename our table. So we'll just double click on this and change it to team task. Another thing, you cannot add space over here. Spaces aren't allowed here. So we'll just make it team task and it's done. Now let us move on to the next step, which is building our app. So click on App Builder over here, and you can click on the plus sign over here. So it'll give you two options. You can either use the App Wizard or you can build from scratch. With App Wizard, you can just start with a set of pre-configured app screen. All you have to do is just add data. So let's just start with an App Wizard. Here you get a message saying a new table was created from your source. So here it'll ask you to choose your table. You can just click over here and you can select your team task table. It will make your application within a few seconds. Then it will ask you to review your details. You can scroll down and see what are the column names. So this is what your app would look like. Now after you've reviewed it, you can just click on next over here. When you click on next, you will see the detailed view of your row. This is how it will look like. Now if you want to change the column value, you can click on edit over here. For example, assign to. If only the work is assigned to me, then I wouldn't edit this. But if I want to assign the work to somebody else, I'll just edit assign to. So I can assign the work to anybody else other than me. So we'll just edit everything because the name of the task will change, the serial number will change, the status will change, so even the start date and the deadline would change. So after we have reviewed our information, let's click on next. Next we will have the form. So if you want to enter any details, you can enter over here. So you can see serial number, name, assigned to, status you can select, the start date and the deadline. So after we review this, let's click on done. And in a few seconds, our app will be created. We'll just click on view app over here. And here our app is created. You can search for any values over here. With Amazon Honeycode, you can use up to 10,000 rows for free. Also, 20 users can access the app for free. So if you want to search for a particular keyword within the 10,000 rows, you can just enter your keyword over here. Now, if you want to add any values, you can click on the plus sign and this form page will open where you can enter all the values. So let's not add any values over here. Now, if you want to change the status from pending to done, I'll just click on this and change it to done. And it will get updated in the application. See, you can see done over here. You see, it is so simple to create an application using Amazon Honeycode. Now you can also add automation if you want to. Let us take a look at automation now. So we'll cancel this. Yes. And click on automation. So you can see the information about automation over here. So the type of automation which is supported in Honeycode are notify, which will send notification to a particular member of your team. Then we have add a row or delete a row from the table. Or you can also overwrite a value in the table. You can update or insert a row in the table as well. And finally, you have the webhook. Now a webhook is a method of altering behavior of a web page with custom callings. So you can add any of this automation to your app according to your convenience. Now I do not want to add any automation to my application, so I'll let it be that way. Now let us view our application again. You see, it is so simple to create an application in Amazon Honeycode. You can also share your application with your team members by just clicking on share apps over here. Now if you enter any email ID over here, the person will get invitation to join your team and access your application. You can also add that person to your team and give him or her access to make changes in your application.
AWS IoT integrates with AI services, so you can make devices smarter even without internet connectivity. Built on AWS, which is used by industry-leading customers around the world, AWS IoT can easily scale as your device fleet grows and your business requirements evolve. AWS IoT also offers the most comprehensive security features, so you can create preventative security policies and respond immediately to potential security issues. Basically, AWS IoT is everywhere. Now talking about what is this AWS IoT. So Amazon Web Services Internet of Things is an Amazon Web Services platform that collects and analyzes data from internet-connected devices and sensors and connects that data to AWS cloud applications. Now, AWS IoT can collect data from billions of devices and also connect them to endpoints for other AWS tools and services, allowing a developer to tie that data into an application. Now, an AWS user accesses AWS IoT with the AWS Management Console, Software Development Kits, or the AWS Command Line interface. Now, an application accesses the service through AWS SDKs. AWS IoT APIs are divided into the control plane, which includes service configuration, device registration, and logging, and the data plane, which includes data ingestion. Now, for the IoT service, it includes a rules engine feature that enables an AWS customer to continuously ingest, filter, process, and route data that is streamed from connected devices. A developer can configure rules in a syntax that's similar to SQL to transform and also organize the data. The feature also allows the user to configure how data interacts with other big data and automation services, such as AWS Lambda. Then there's Amazon Kinesis, Amazon Machine Learning, Amazon DynamoDB, and Amazon Elasticsearch service. Now, each rule consists of an SQL statement and an action list that defines and executes the rule using an editable JSON-based schema. Then we also have a device shadow, which is an optional rule that enables an application to query data from devices and send commands through REST APIs. Now, device shadows provide a uniform interface for all devices, regardless of limitations to connectivity, bandwidth, computing ability, or power. So this was about what is AWS IoT, but why do we actually need it? Now, talking about the reasons why AWS IoT is important, the first reason is that it's broad and deep. Now, AWS has broad and deep IoT services from the edge to the cloud. Device software, Amazon Free RTOS, and AWS IoT Greengrass provides local data collection and analysis. Now, in the cloud, AWS IoT is the only vendor to bring together data management and rich analytics in easy-to-use services designed specifically for noisy IoT data. Not just that, it also has multi-layered security. Now, AWS IoT offers services for all layers of security. AWS IoT includes preventative security mechanisms such as encryption and access control to device data. AWS IoT also offers a service to continuously monitor and audit security configurations. You will receive alerts so you can mitigate potential issues such as pushing a security fix to a device. Apart from that, it also has superior AI integration. Now, AWS is bringing AI and IoT together to make devices more intelligent. You can create models in the cloud and then deploy them to devices where they run 2 times faster compared to other offerings. AWS IoT sends data back to the cloud for continuous improvement of models. And also, AWS IoT supports more machine learning frameworks compared to other offerings. And finally, it's also proven at scale. Now, AWS IoT is built on a scalable, secure, and proven cloud infrastructure and scales to billions of different devices and trillions of messages. AWS IoT integrates with services such as AWS Lambda, Amazon S3, and Amazon SageMaker. So you can build complete solutions such as an application that uses AWS IoT to manage cameras and Amazon Kinesis for machine learning. So this was about what is AWS IoT and why do we actually need it, or what's the importance. Now let's move on and see how does AWS IoT work. Now, AWS IoT enables internet-connected devices to connect to the AWS cloud and lets applications in the cloud interact with internet-connected devices. Common IoT applications either collect and process telemetry from devices or enable users to control a device remotely. Now, for the working of the AWS IoT, we have certain components such as we have the devices and the IoT applications, then the message broker, device shadows, rules engine, and security and identity works as the middleman of this entire working process. And then it's connected to the Amazon DynamoDB, Kinesis, AWS Lambda, Amazon S3, Amazon SNS, Amazon SQS, etc. Now, talking about the working, the state of each device connected to AWS IoT is stored in a device shadow. The device shadow service manages device shadows by responding to requests to retrieve or update device state data.
The device shadow service makes it possible for devices to communicate with applications and for applications to communicate with devices. Now, communication between a device and AWS IoT is protected through the use of X.509 certificates. Now, AWS IoT can generate a certificate for you, or you can use your own. In either case, the certificate must be registered and activated with AWS IoT and then copied onto your device. When your device communicates with AWS IoT, it presents the certificate to AWS IoT as a credential. Now, we recommend that all devices that connect to AWS IoT have an entry in the registry. The registry stores information about a device and the certificates that are used by the device to secure communication with AWS IoT. Also, you can create rules that define one or more actions to perform based on the data in a message. For example, you can insert, update, or query a DynamoDB table or even invoke a Lambda function. Now, rules use these expressions to filter messages. When a rule matches a message, the rules engine triggers the action using the selected properties. Rules also contain an IAM role that grants AWS IoT permission to the AWS resources used to perform the action. So these are the different components involved in the working of the AWS IoT, and also these are the steps required for the working of AWS IoT. Now let's move on and talk about the various features of AWS IoT. Now talking about the first feature, we have AWS IoT Device SDK. Now the AWS IoT Device SDK helps you easily and quickly connect your hardware device or your mobile application to AWS IoT Core. Now the AWS IoT Device SDK enables your devices to connect, authenticate, and exchange messages with AWS IoT Core using the MQTT, HTTP, or WebSockets protocols. Now the AWS IoT Device SDK supports C, JavaScript, etc. and includes the client libraries, the developer guide, and the porting guide for manufacturers. You can also use an open source alternative or write your own SDK. The next feature includes the device gateway. Now the device gateway serves as the entry point for IoT devices connecting to AWS. The device gateway manages all active device connections and implements semantics for multiple protocols to ensure that devices are able to securely and efficiently communicate with AWS IoT Core. Currently, the device gateway supports the MQTT, WebSockets, and HTTP 1.1 protocols. For devices that connect using MQTT or WebSockets, the device gateway will maintain long-lived bidirectional connections, enabling these devices to send and receive messages at any time with low latency. The device gateway is fully managed and scales automatically to support over 1 billion devices without requiring you to manage any infrastructure. For customers migrating to AWS IoT, the device gateway offers capabilities to transition infrastructures with minimal impact to existing architectures and IoT devices. The next feature includes the message broker. Now, the message broker is a high throughput pub or sub message broker that securely transmits messages to and from all of your IoT devices and applications with low latency. The flexible nature of the message broker's topic structure allows you to send messages to or receive messages from as many devices as you would like. It supports messaging patterns ranging from one-to-one command and control messaging to one-to-1 million broadcast notification systems and everything in between. In addition, you can also set up fine-grained access controls that enable you to manage the permissions of individual connections at the topic level, ensuring that your devices and applications will only send and receive the data that you want them to. Then next we have authentication and authorization. Now, AWS IoT Core provides mutual authentication and encryption at all points of connection so that data is never exchanged between devices and AWS IoT Core without a proven identity. AWS IoT Core supports the AWS method of authentication, that is the X.509 certificate-based authentication, and customer-created token-based authentication. Now, connections using the HTTP can use any of these methods, while connections using the MQTT use certificate-based authentication, and connections using WebSockets can use SIGV4 or custom authorizers. You can create, deploy, and manage certificates and policies for the devices from the console or even using the API. Now, the next feature is registry. The registry basically establishes an identity for devices and tracks metadata such as the device's attributes and capabilities. The registry assigns a unique identity to each device that is consistently formatted regardless of the type of device or how it connects. It also supports metadata that describes the capabilities of a device. For example, whether a sensor reports temperature and if the data are Fahrenheit or Celsius. Then the next feature is device shadow. Now with AWS IoT Core, you can create a persistent virtual version or device shadow of each device. That includes the device's latest state so that applications or other devices can read messages and interact with the device. Now the device shadow persists the last reported state and desired future state of each device even when it is offline. So you can retrieve the last reported state of a device or set a desired future state through the API or using the rules engine. Now basically this device shadow makes it easier to build applications that interact with your devices by providing always available REST APIs. It also lets you store the state of your devices for up to a year for free. Now finally we have the rules engine. Now the rules engine makes it possible to build IoT applications that gather, process, analyze and act on data generated by connected devices at global scale without having to manage any infrastructure. Now the rules engine evaluates inbound messages published into AWS IoT Core and also transforms and delivers them to another device or a cloud service based on the business rules you define. A rule can apply to data from one or many devices and it can take one or many actions in parallel. Now the rules engine can also route messages to AWS endpoints, including the AWS IoT Analytics, AWS IoT Events, AWS Lambda, Amazon Kinesis, then there's Amazon S3, DynamoDB, CloudWatch, Simple Notification Service, Simple Queue Service, etc. Now, external endpoints can be reached using the AWS Lambda, Kinesis, Amazon SNS, and Rules Engine's native HTTP action. Also, the Rules Engine provides dozens of available functions that can be used to transform your data, and it's possible to create infinitely more via the AWS Lambda. So this was about the different features of AWS IoT and how it actually helps in the working of AWS IoT. Now let's move on and talk about some of the AWS IoT solutions. Now talking about the IoT solutions, it covers different sectors in our everyday life. So first, it's about the industrial sector. AWS IoT customers are building industrial IoT applications for predictive quality and maintenance and to remotely monitor operations. Then we also have the connected home sectors. For AWS IoT customers are building connected home applications for home automation, home security and monitoring, and also home networking. And finally, we have the commercial sector. AWS IoT customers are building commercial applications for traffic monitoring, public safety, and also health monitoring. So these were the different solutions provided by AWS IoT. Now let's get into the details of these solutions and find out what are the different AWS IoT services. Now industrial IoT brings machines, cloud computing, analytics, and people together to improve the performance and productivity of industrial processes. So with IIoT, industrial companies can digitize processes, transform business models, and improve performance and productivity while decreasing the waste. Now talking about the industrial IoT use cases, we have the predictive quality. Now predictive quality analytics attracts actionable insights from industrial data sources such as manufacturing equipment, environmental conditions, and human observations to optimize the quality of factory output. So using AWS IoT, industrial manufacturers can build predictive quality models which help them build better products. Higher quality products increase customer satisfaction and also reduce product recalls. Then we also have the asset condition monitoring. Now, asset condition monitoring captures the state of your machines and equipment to determine asset performance. With AWS IoT, you can capture all IoT data such as the temperature, vibration, and error codes indicate if equipment is performing optimally. Now, with increased visibility, you can maximize asset utilization and fully exploit your investment. And finally, we have the predictive maintenance. Now, predictive maintenance analytics captures the state of industrial equipment to identify potential breakdowns before they impact production, resulting in an increase in equipment lifespan, worker safety, and the supply chain optimization. Now, with AWS IoT, you can continuously monitor and infer equipment status, health, and performance to detect issues in real time. Now, talking about the working, we have various components here. So we have the industrial equipment, the OPC UA data server. Then we have the free RTOS where we program, deploy, secure, connect, and manage all small low power devices. Now from these equipments, we go to the AWS IoT site-wise gateway and also the AWS IoT Greengrass. Now the gateway collects data from on-premises equipment and historian databases, and the Greengrass runs application code at the edge. Then the next section is the data management part where we have the AWS IoT site-wise that collects, organizes, and analyzes industrial data at scale. And for the device connectivity and control, we have AWS IoT Things Graph, which connect devices and web services. And we have the AWS IoT Core, which is used to secure device connectivity and messaging. And then AWS IoT Device Management, which is used for fleet onboarding, management, and software updates. And finally, there's the AWS IoT Device Defender, which fleet audits and protection. Now, after all of these, the final section is the analytics and event detection. Now, here we have the AWS IoT events, which detect and respond to events from IoT sensors and applications. And then we also have the AWS IoT Analytics, which process and prepare data for analytics and machine learning. So this was the working of the industrial AWS IoT. Now let's take a case study and understand this better. Now the CAF increases train safety with the help of AWS IoT. So basically, CAF is a leading designer and manufacturer of trains and railway signaling systems. The Rail Services Unit reduces maintenance costs over the life cycle of a train using predictive maintenance, a process that schedules repairs by interpreting real-time operational data. So CAF launched a new initiative called the Digital Train, which led to the development of the LeadMind platform. And LeadMind utilizes Internet of Things technology to deliver predictive maintenance using data captured by sensors on trains in real time. The LeadMind platform securely connects its train-based sensors using the AWS IoT Core. Now, because of this, we have safer trains with reliable data analysis. And Amazon Kinesis ingests the IoT data in real time and sends it to Amazon Redshift, which acts as a data warehouse while also integrating with CAF's business intelligence tools for data analysis. So this was just one example out of the many how AWS IoT is implemented in industries. Now talking about the connected home AWS IoT, it helps the connected home device manufacturers easily, quickly, and securely to build differentiated connected home products at scale. And as the use of connected home devices continue to grow, more and more data is being pushed to the cloud where the latest IoT and machine learning technologies are enabling new innovations in connected home applications. Now talking about the various connected home IoT use cases, we have the home automation. Now using AWS IoT, you can enable any device to connect to the internet and perform a desired action quickly, reliably, and easily. Now these devices can work alone or together with other devices or hubs for an integrated smart home experience. Additionally, devices can also benefit from using voice services like Alexa for a seamless customer experience. Then we also have the home security and monitoring. Now, devices like door locks, security cameras, and water leak detectors built with AWS IoT can use machine learning to automatically detect threats, take action, and send alerts to homeowners. AWS IoT also enables devices to run with low latency and compute data locally without internet connectivity. And finally, we also have the home network management. Now, network operators are looking for new ways to help customers quickly discover, troubleshoot, and fix home network issues, including Wi-Fi and cable TV connectivity. AWS IoT-enabled set-top boxes can automatically log network diagnostics and send to the customer service center proactively, or allow customers to monitor and troubleshoot their network health through a mobile app. So these were the different use cases. Now let's take an example and understand this better. So talking about the examples of connected homes, we can take the example of LG Electronics. Now in December 2017, LG Electronics announced the launch of its LG 𝐵𝐾 brand to categorize all its upcoming smart products and services which feature artificial intelligence technology. The concept of 𝐵𝐾 is to embed Wi-Fi chips in LG products, which allows these products to communicate with each other while learning about their users' behavioral patterns and environments. Now, because of the managed services and AWS IoT Core, LG was able to relaunch its IoT platform with a modest number of development resources. Now, by using AWS for the IoT platform, it could save 80% in development cost. It also enabled the developers to focus on writing business logic for LG service scenarios. LG is also using AWS IoT and a serverless architecture for air quality monitoring services, customer service chatbots, and energy solutions. Since March 2018, a chatbot service for customer support that was developed using serverless services has been running in Korea and the United States. So these were the different use cases. Now talking about the working, so here you can see that how AWS IoT works for connected homes. So we have the Amazon free RTOS, which includes the door lock, light bulb, white goods, and small appliances. Then we have the AWS Greengrass, which involves the security camera, Wi-Fi router, and home controller, which is then connected to the cloud, where we have the AWS IoT Core, AWS IoT Device Management, AWS IoT Device Defender, AWS IoT Analytics, which comes under the Internet of Things, that is the IoT. Then we have the AWS products and services, which includes the machine learning, database, and computation. And finally, it's all connected to the mobile apps, dashboards, or customers or Alexa devices. Now let's take an example for connected homes and understand this better. So this was about connected homes. Now let's move on and understand how AWS IoT works for any enterprise or any commercial purpose. Now most enterprise customers across industries choose AWS as their cloud platform. They choose AWS to become more agile, innovative, and efficient. With AWS, you benefit from the fastest pace of innovation, the broadest and deepest functionality, the most secure computing environment, and the most proven operational expertise. Now you can achieve your business goals with the help of AWS IoT as it grows new revenue streams. Now it quickly responds to new business insights, customer demands, and changing market conditions to grow new revenue streams. With AWS, you can rapidly test and iterate on ideas in an agile environment and then quickly scale the new business ideas that show the most promise. Then there's also the increased operational efficiency. When you move to AWS, you get benefits beyond IT cost savings. With AWS, you improve workforce productivity with agile development teams, accelerate development cycles to get to market more quickly, and increase operational resilience to improve uptime. Then finally, we also have the lower business risk. Now, protecting your data and maintaining customer and stakeholder trust is critical to your business. AWS gives you the most flexible and secure cloud platform, backed by a deep set of security, compliance, and governance services that help you minimize risk without compromising time to market, scale, and business agility. Now let's take an example. So McDonald's has been using AWS IoT for their home deliveries. Now McDonald's is the world's largest restaurant company with 37,000 locations serving 64 million people per day. Now using AWS, McDonald's built Home Delivery, a platform that integrates local restaurants with delivery partners such as Uber Eats. McDonald's built and launched the home delivery platform in less than 4 months using a microservices architecture running on Amazon Elastic Container Service, Amazon Elastic Container Registry, Application Load Balancer, Amazon Elastic Cache, then Amazon SQS, Amazon RDS, and Amazon S3. Now, the cloud-native microservices architecture allows the platform to scale to 20,000 orders per second with less than 100 millisecond latency, and open APIs allow McDonald's to easily integrate with multiple global delivery partners. And using AWS also means the system provides McDonald's with a return on its investment even for its average $2 to $5 order value. So this is how AWS IoT is being used and implemented in various sectors. It's used for different enterprises or commercial purposes, and then it is used for smart homes as well, and also various industrial sectors. So this was all about the AWS IoT and how it is involved in our everyday lives.
I'm sure you know what a data warehouse is. You can think of data warehouse as a repository where data generated from your organization's operational systems and many other external sources is collected, transformed, and then stored. You can host this data warehouse on your organization's mainframe server or on cloud. But these days, companies are increasingly moving towards cloud-based data warehouses instead of traditional on-premise systems. And to know why, we need to understand the underlying architecture and the disadvantages of using traditional data warehouses. So let's begin by looking at architecture part. It is important to understand where the data comes from. Traditionally, data sources are divided into two groups. First, we have internal data, that is, the data which is being generated and consolidated from different departments within your organization. And then we have external data, that is, the data which is not getting generated in your organization. In other words, that is the data which is coming from external sources. So this traditional data warehouse follows a simple three-tier architecture. To begin with, we have bottom tier. In bottom tier, we have a warehouse database server, or you can say a relational database system. In this tier, using different kind of backend tools and utilities, we extract data from different sources and then cleanse the data and transform it before loading it into data warehouse. And then comes the middle tier. In middle tier, we have OLAP server. OLAP is an acronym for Online Analytical Processing. This OLAP performs multidimensional analysis of business data and transforms the data into a format such that we can perform complex calculations, trend analysis, and data modeling on this data very comfortably. Finally, we have top tier. This top tier is like a front-end client layer. This tier holds different kind of query and reporting tools using which the client applications can perform data analysis, query reporting, and data mining. So to summarize what we have learned till now, traditional data warehouse as a simple three-tier architecture. In the bottom tier, we have backend tools using which we collect and cleanse the data. And then in middle tier, we have tools, which is OLAP server, using which we transform the data into the way we want. And then finally, top tier, in which using different query and reporting tools, we can perform data analysis and data mining. Moving on to the disadvantages of traditional data warehouse concept, there is this leading US business service company, and this company is running a commercial enterprise data warehouse. This data warehouse has data coming from different sources across different regions. The first problem that this company faced was when it was setting up a traditional data warehouse. As we discussed earlier, the architecture of traditional data warehouse is not very simple. It consists of data models, extract, transform, and load processes, which we call ETL, and you have BI tools sitting on top. So this US-based company had to spend a lot of money and resources to set up a traditional data warehouse. Data warehouse, which was initially 5 terabytes, was growing over 20% year over year. and it was expected that there might be higher growth in future. So to meet this continuously increasing storage and compute needs, the company had to continuously keep upgrading the hardware. Again, this task of upgrading the hardware continuously involves a lot of money, manpower, and too many resources. So, autoscaling in traditional data warehouse is not an easy concept. And since the company could not meet all the storage and compute needs easily, it was facing a lot of performance issues as well. And finally, the company had to deal with increasing costs. Initially, they had to spend a lot on setting up data warehouse, like they had to spend on hardware, manpower, electricity, security, real estate, and deployment costs, and many other. And as their data warehouse grew, they had to spend again to meet storage and compute needs. So to sum it up, setting up a data warehouse and deploying it and managing it later involves a lot of money and resources. Moreover, autoscaling in traditional data warehouse is not an easy concept. Because of all these reasons, many companies are increasingly moving towards cloud-based warehouses instead of traditional on-premise systems. So guys, in this session, we'll be dealing with one of the most famous cloud-based data warehouse provided by Amazon, which is Amazon Redshift. In simple words, Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost-effective for you to analyze all your data across your data warehouse and data lake. Guys, I have a definition which is put up on the screen, and I have few words which I have highlighted over there. So as we progress through the course of this session, we'll know what those words exactly mean. So let's ignore them for now. But there are certain key concepts which you should be aware of when you're dealing with Amazon Redshift. So we'll discuss them now. Amazon Redshift Dataware is a collection of compute resources which we call nodes. And these nodes, when organized into a group, they become clusters. Each of these clusters run an Amazon Redshift engine, and it contains one or more databases. So this cluster has a leader node and one or more compute nodes. As for the leader node, it receives queries from client applications, and then it passes these queries and develops a suitable query execution plan. And then it coordinates the parallel execution of these plans with one or more compute nodes. Once the compute nodes finish executing this plan, again the leader node aggregates the results from all these intermediate compute nodes and then sends it back to client application. Then we have compute nodes. You can think of these compute nodes as a compute resources that execute the query plan which was developed by leader node. And when they are executing this plan, they transmit data among themselves to solve many queries. These compute nodes are further divided into slices, which we call node slices. Each of these node slices receive part of memory and disk space. So the leader node distributes data and part of user query that it receives from client application to these node slices. And all these node slices work in parallel to perform operation and increase the performance of your Redshift data warehouse. So to say, we have leader node, we have compute nodes and node slices. But how do they interact with client application? That is the question here. So I have these client applications, basically BI tools, or it can be any other analytical tools, which communicate with Amazon Redshift using drivers like JDBC and ODBC. JDBC refers to Java Database Connectivity Driver. It is an API for programming language Java. Then we have ODBC. It refers to other database connectivity driver, and it uses SQL to interact with leader node. So basically using these drivers, client application sends a query to leader node. Leader node, on receiving the client application's queries, it passes these queries and develops a suitable execution plan. Once the plan is set up, compute nodes and compute slices start working on this plan. They transmit data among themselves to solve these queries. So once the execution is done, leader node again aggregates the results from all these intermediate nodes and sends it back to client application. So this is the simple explanation of Amazon Redshift concepts. Moving on, when you launch a cluster, you need to specify the node type. Basically, we have two types of nodes. Dense storage nodes. These are storage optimized and are used to handle huge data workloads. And basically, they use hard disk drive or HDD type of storage. And then we have dense compute. These dense compute nodes are compute optimized and they are used to handle high performance intensive workloads. And they mainly use solid state drive or SSD kind of storage. But there are three things that you should keep in mind when choosing one among them. Firstly, you should be aware of the amount of data that you want to import into your Amazon Redshift, and then the complexity of the queries that you run on your database. and the need of downstream systems that depends on the results of these queries. So, keeping these three things in mind, you can choose either dense storage nodes or dense compute nodes. So guys, that was the architecture and its key concepts. Now, we'll take a look at few reasons as to why Amazon Redshift is very popular. As we discussed earlier, setting up a traditional data warehouse involves a lot of money and resources. But it's very easy to set up, deploy, and manage a suitable data warehouse using Amazon Redshift. On Amazon Redshift console, you will find Create a Cluster option. When you click on that option, Amazon Redshift asks you for certain details like the type of node you want to choose, the number of nodes, the VPC in which you want to create your data warehouse, user ID, password, and many other details. Once you feel that you have given the right set of details, you have an option which says Launch the cluster. And one click, your data warehouse is just created. So with one click, you can easily create a data warehouse in Amazon Redshift. Once your data warehouse is set up, Amazon Redshift automates most of the common administrative tasks like managing, monitoring, and scaling your database. So you don't have to worry about managing or scaling your database needs. So that's how easy it is to develop or set up a data warehouse using Amazon Redshift. We also learned that auto-scaling is difficult in traditional data warehouse, but you can scale quickly to meet your needs in Amazon Redshift. Well, we already know that a cluster node has a leader node and one or more compute nodes. So if you want to auto-scale in Amazon Redshift, all you have to do is resize your cluster size. As we know, these compute nodes are like compute resources. So if you want to scale up, you can increase the number of compute nodes. Similarly, if you want to scale down, you just have to decrease the amount of compute nodes. Alternatively, we have something called single node and multiple node. In single node cluster, one node takes the responsibilities of both leader and compute functionalities. And the multi-node cluster contains one leader node and user-specified number of compute nodes. So suppose you want to resize your cluster and you are using a single node cluster, then you can change from single node cluster to multi-node cluster. Similarly, you can change from multiple node cluster to single node cluster when needed. So that's how easy it is to scale up and down in Amazon Redshift. Moving on, we learned earlier that while using traditional data warehouses, it's possible that the performance of your data warehouse might decrease. But with Amazon Redshift, you can get 10 times better performance than any other traditional data warehouse. It uses a combination of different strategies like columnar storage and massively parallel processing strategies to deliver high throughput and response times. So let's discuss these strategies one by one. Well, first we have columnar data storage. To understand what that is, first we should know row storage. Most of the traditional data warehouse and databases use this row storage. In row storage, all the data about a record is stored in one row. Okay, so let's say I have this database here. I have 3 columns and 2 rows. The first column contains the unique number associated with student. The second column contains the name of a student and the third column contains the age. As we already know, data is stored in form of blocks in databases or data warehouses. So as you can see in row storage, the block 1 contains all information there is about a particular student, his SSN, his name, and then age. So basically, it stores all the information that there is in a single row. So in the first block, you have information about first student, and in the second block, you have information about second student, and it goes on. Now the columnar storage. Again, I'm using the same database. Again, I have 3 columns and 2 rows. But column storage stores data by columns, with data for each column stored together. So again, we have blocks, but the first block here has all the data that is there in first column. So you have all the SSN stored in first block and all names stored in second block and all the ages stored in third block. So it goes on. There are a lot of advantages of using this column storage. Firstly, since in column storage, a single block contains same type of data, you can achieve better data compression. As you can see, columnar storage can hold values 3 times the records as row-based storage. Because of this, the number of input-output operations decreases. And thirdly, by storing all the records for one field together, columnar database can query and perform analysis on similar type of data far quicker than row storage. So this is how the concept of columnar storage, which is used by Amazon Redshift, provides us a better performance. And then we have massively parallel processing. I'm sure you might have heard of parallel processing in computer science. It's just that number of different processors work together or compute together or in parallel. Similarly, massive parallel processing in Amazon Redshift is nothing but clustering. We have already discussed this earlier. We have a cluster, and this cluster has a leader node and one or more compute nodes. And this compute nodes is further divided into something called node slices. So when this leader node receives a query, it develops an execution plan, and this compute nodes and compute slices work together or in parallel to execute this plan. And later, this leader node sends the results back to client application. So basically, this compute slices and compute nodes work in parallel to achieve better performance. Moreover, Amazon Redshift is also able to smartly recognize the data on nodes before running a query, which dramatically boosts the performance. So that's how we can get a 10 times better performance using Amazon Redshift. And then the cost. In traditional data warehouses, people had to spend a lot of money to set up and then later to maintain the data warehouse. But Amazon Redshift is the most cost-effective cloud-based data warehouse. If you remember, in traditional data warehouse, they had to spend on hardware, real estate, manpower, electricity, and deployment cost and many others. And as their data warehouse grew, they had to spend again on meeting the storage and compute needs. But in Amazon Redshift, we don't have to pay any upfront cost. So Amazon Redshift is most cost effective and it costs 1/10 of traditional data warehouse. You can start small for just $0.25 per hour without any commitments, and you can gradually scale up later if you need. In addition to all those advantages, Amazon Redshift allows you to query data from Data Lake. Data Lake is a storage repository that holds a vast amount of raw data in its native format until it is needed. So in Data Lake, you have data in different formats. You can load data from Amazon S3 into your Amazon Redshift cluster for analysis very easily. That is, from Data Lake, you can store easily into your Amazon Redshift. But it needs more effort and cost. Effort because loading data into Amazon Redshift cluster involves extract, transform, and load, which we simply call ETL process. And this process is very time consuming and compute intensive. And it's costly because uploading lots of data, cold data from Amazon S3 for analysis requires growing your clusters, which is again costly and requires a lot of resources. So as a solution, we have something called Amazon Redshift Spectrum, which acts as an interface between your Amazon S3 or Data Lake and Amazon Redshift. So you can directly query data stored in Amazon S3 or Data Lake with this Redshift Spectrum without need for unnecessary data movement. I hope that was clear. And finally, with Amazon Redshift, your data is safe and secure. It offers backup and recovery. So as soon as data is created or stored in Amazon Redshift, a copy of that data is made, and through secure connections, a snapshot of it is sent to Amazon S3 for later. So suppose you lose your data, or if you have deleted the data from Amazon Redshift by mistake, you can restore the data easily from Amazon S3 service. Amazon Redshift also provides you with an option to encrypt your data. So when you enable this encrypt option, all the data in your cluster, in your leader node and your compute nodes and node slices is encrypted, and this way your data is very safe and secure. So guys, these are all the advantages of using Amazon Redshift. So now you have a basic idea of its architecture, its various key concepts like clusters, nodes, leader node, node slices. Now it's time to work on a demo. In this demo, we'll see how to transport data from Amazon S3 to Amazon Redshift data warehouse and perform simple queries. So I hope that was clear to you guys. Let's get started. But the first thing, there are certain softwares which you need to pre-install so that you can start working on Amazon Redshift. First, suppose you want to perform queries on the data on Amazon Redshift, then you need a SQL workbench where you can perform your queries. And as we learned earlier, the client application need a connection to communicate with Redshift. So we need to install a JDBC driver. And for that JDBC driver to run, we need to have a Java runtime environment. So we have 3 things to install here now. I'll show you how to install each of them. And I have this Java runtime environment download link by softonic.com. So it says free download, and you click on that, it'll be downloaded. You can store it anywhere. And once you're done with that, search for Amazon Redshift documentation. So here it is. Okay, not that. This one. And when you scroll down, it says Amazon Redshift get started. Click on that. And in the step 1, we have prerequisites. Okay. Scroll down and it says In the step 2, you have an option where you can download or go to SQL Workbench website and download it. So click on that. And here it says build current version. And you have download generic packages for all systems. You can download it. Once you click on that, it'll start downloading. And there is one more thing, which is JDBC driver. Go back to documentation part, scroll down, and the step 4, you can see configure a JDBC connection. Click on that. It'll take to your page where you have JDBC drivers of different version. You can download the first one. Click on this and it'll be downloaded. So once all these 3 things are downloaded, store them in a file of your choice. Well, I have stored them on my desktop. I have this AWS folder and in that Redshift. So here's my workbench, a zip file. It was a zip file, so I extracted all the files. And then I have my JDBC driver here. Well, Java runtime environment isn't download, so that's okay. So I hope that was easy. So just install all these things and you're set to go. And we're back to our Amazon Management Console. I have previously used Amazon Redshift, so I have this Amazon Redshift in recently visited services. Anyway, you can search for Amazon Redshift here. Here it is. Well, it's taking time to load. Okay, this is my Amazon Redshift console page. And you have different kind of options on your navigation pane on the left side. And there are 2 ways to create or launch a cluster. First, you have quick launch cluster option and launch cluster option. This is the very easy way to launch a cluster. But suppose you want the freedom to specify all the details as in the VPCs, the security groups, different type of nodes, username, password, and all that, you can go for launch cluster option. Let's go ahead and explore that. So first it asks for a name, let's say my cluster, and database, DAT1, and the port, this is default port, 5439 is the default port which will be handled by Amazon Redshift. Then the master username, let's say AWS user, and password. That's it. And confirm your password and click on continue option. So cluster details are done and dusted. Then you have node configurations. Well, for the free tier, you only have DC2 large. But suppose you have a premium membership, then you can choose any of this. For this DC2 large, this is the CPU capacity, memory, and storage. And the input-output performance is moderate. You can go ahead and choose the cluster type. We discussed this. We have multi-node and single node. In single node, we have both the leader and the compute node responsibilities handled by single node. The multi-node, we have a single leader node and user-specified number of compute nodes. Click on continue. And then here it asks for the VPC details, parameter group, and suppose you want encryption or not, and all the details. So basically, in this launch cluster option, you have the freedom to specify all the details. But for this demo, I'm going to use quick launch cluster option. So again, as for the free tier, I'm using DC2 large. And again, for the free tier, I'm using DC2 large type. It says there are 2 compute nodes. And let's retain the same cluster name. As for the master user, AWS user. Now let me give the password. And the default port is 5439. And last option, we have to choose among the available IAM users or IAM roles. But the question is why we need an IAM role here. In this demo, I said that we're trying to import data from Amazon S3, but you need certain set of permissions to access data which is stored in Amazon S3. For that, we need to create an IAM role. So let's go back to IAM service. Let me close all these tabs. Okay. Here you have roles option. You can click on that and click create role. And since we're dealing with Amazon Redshift, select Redshift, Redshift customizable, and click on next permissions. So we want Amazon Redshift to access data from Amazon S3. So search for S3 here. And you have a permission which says Amazon S3 read-only access. Well, for this demo, this is an if, but there is one more permission which says Amazon S3 full access. So you can perform read and write operations as well. As for this demo, I'm going to choose this permission which says Amazon S3 read-only access provides read-only access to all the buckets in Amazon S3. And click on next review. Give your role a name. Let's say my Redshift role 2. And click on create role. So now our Amazon Redshift database has permission to access data from Amazon S3. Let's go back to Redshift console. Okay, let me refresh this. And now it's showing the role which has been created is showing here. So as you can see, unlike other launch option, in this, I didn't have to specify much details, just the node type, the number of nodes, and then the master username, cluster identifier, and password, and the default database port. And you can click on launch cluster option. So with one click, you've easily deployed a database on Amazon Redshift. If you remember, when we tried to use this launch cluster option, we had option to select a default database or use or create our own database. But when you use this quick launch cluster option, a default database called dev will be created for us. So guys, this cluster has been created. So before we connect it to your SQL Workbench, let's try to explore here. You need to make sure that the database health status and in maintenance status, everything is in green color. As for the cluster status, it should be available. And for the database health, it should be healthy. Only then you can make a perfect connection with your SQL Workbench. So you have this icon here, click on that. Well, you get all the information there is about your cluster. Or you can just go ahead and click on this cluster. So this is the endpoint. This tells me all about how to make a connection with this cluster. I have this. When I click on that, it says publicly accessible, yes. And the username is AWS user. And the security groups, apparently it just shows the TCP rules which are set. So that's about the endpoint. Then the cluster name, you have cluster type, node type, and it shows the nodes and the zone and the date and time when it was created. And you have cluster version as well. On the right side, you have cluster status, which is available, database health healthy. So is it currently in maintenance mode? No. And then you have parameter group apply status, which is in sync with your database. And there are a few other features as well. But here you can see this VPC group. Click on that. Go for inbound and make sure it is set for TCP. Okay, edit. Make this custom TCP rule. And here 5439. Custom. That's it. And click on save option. So that's the default port with which you can access the Redshift. And let's go back. Clusters. Okay, where were we? We changed the default group of VPC. So this is the URL with which you can connect to the SQL Workbench. So let's copy this and paste it in our text file. I've pasted it over there. Well, if you're using ODBC connection, then you can use this URL. When you scroll down, you have capacity details of your entire cluster. It's DC2 large. So 7 EC2 compute units, total memory, storage, and platform. Okay. Let's go back to this IAM role. But I should have an IAM role option here. Let me see. Check it out. Okay. There's an option which says see IAM roles. You can copy this entire thing and paste it again in the editor so that while connecting it, it'll be easy for us to find it. Okay. Then, so now your cluster is created, your database or data warehouse is set up. Now you can just connect it with SQL Workbench and start working on it. So let's go back to the folder where I've stored my Workbench. Here it is. When you scroll down, there's a file which says SQL Workbench executable jar file. Open. So here it is. It's asking for a default profile name. Let's say new profile 1. Okay. Then driver. That was Amazon Redshift driver only, JDBC driver. And this was the URL. We copied it earlier in the editor. So I'm going to paste it over here now. This is the URL. Control C and paste it. AWS user in the password. Okay, that should work. Make sure that you select this auto commit, save it, and then click on OK. It says connecting to the database. Now it's successfully connected. So I can easily perform queries now. First, let's create some tables. Well, I'm using the sample database from Amazon S3. So you have this AWS Redshift documentation. Go back to that. And here it says get started. And in the step 6, you have this default SQL queries and tables provided. So you can go ahead and use that. I have it stored in my editor. So I'm going to copy. First, I'm going to create all the tables. Control C and paste it over there. Let's check what tables are there. First, we have user table. Well, this is like an auction data schema. So you have user table, many users, and you have category users, the category, different categories to which users belong to. And then you have date on which a particular event occurred. Then you have event table, all the details regarding an event. Listing, as in the items which are being sold are listed here, all the details about the items. Then you have sales, as in which user is buying, how much, which item, and all that details. So basically we have 6 to 7 tables. I'm going to select all that and say run option. So here it says table users created, table venue created, category, date, event, listing, and sales. So all the tables are easily created now. As for the next part, we need to copy the data or the data for the database from Amazon S3 to Amazon Redshift. Let's go back to the editor. And I have this copy command. I'll explain you the format. Control C. And let's pasted it here. Okay, let's explore this copy command. It says copy to the table users which you just created from this path. That is from the file which is stored in S3 bucket. But this is the credentials AWS IAM role which we copied to the editor earlier. Apparently, we're just giving a permission to access the data from S3. So we need to copy this IAM role here. And then we have delimiter. As in, let me go back to editor and show you an example. Okay. Let's say I have a data. Let's say I have name, Archana, space, some age, B, hobbies. So you can see this straight line. This is the delimiter, as in the thing which you're using to separate all the fields or the columns. So going back. So that's delimiter which separates the data. And this is region in which your S3 bucket is located. So that's it. But we have to replace the IAM role. This is the ARN of the role. I'm going to copy it. And wherever this is, you need to just paste it. Control V. Okay. We're done. Last one. So select everything and click on this execute button. It might take a while because the data set which was stored in Amazon S3 might contain large number of rows. So it might take a while. So as you can see, it states executing statement here. It says 1 out of 7 finished. So we have 6 more to go. So this SQL workbench has successfully executed all the script which we have written here. Let's go and start performing some simple queries. Let's say I want to extract the metadata of user table. I have this query. Okay, select star from page table definition. So since we are extracting metadata from table name, let's say users, and click on execute option. So you have so many columns. Here it says first column user ID of type integer, encoding delta. Then you have username, first name, last name, city, state, email. So basically that's the metadata or the structure of user table. So we have sales ID, list ID, seller ID, buyer ID, and many other details. Let's execute some other command. Let's say I want to find total sales on a given date. Okay. Sum the count. Here I have some function which will count the number of sales from sales and date, where the sales date ID is date ID. And the date on which I want to calculate, I've specified it here, and then click. Okay, the sum error, it should show a number here. Rest is working, only that is not working. I've selected the user table and I've asked them to display all that there is in the user table. So this is the data. Okay, select star from users. So I want to extract the names of people who are from, let's say some states. Let's consider some state. Let's take NH. So STATE like NH. It should work now. It says executing statement. So these are the people who are from state NH. So basically, once you have the perfect connection from your SQL workbench to your Amazon Redshift, you can perform whatever queries you like. So let's go back to our Amazon Redshift console. Well, so this is the cluster. I'm going to click on this. Here you have queries. When you click on that, all the queries which you performed till now will be shown. So this is the query. So it says first name from users who was from state NH. This was the query which we performed earlier. So you have all the data or all the information regarding the queries which you executed. Well, that's all about Amazon Redshift. So guys, this is how easy it is to create a data warehouse using Amazon Redshift. Go ahead and explore many other features of Amazon Redshift. Well, I've just showed a part of them here. So go ahead and create a database, perform various queries, and have fun.
What is AWS Kinesis? So Amazon Kinesis is one of the best managed services which particularly scales elastically, especially for real-time processing of the data at a massive point. These services can be used to collect large streams of data records which are especially consumed by the application process that runs on Amazon EC2 instances. This Amazon Kinesis is used to collect, streamline the process, and analyze the data so that easily we can get the perfect insights as well as the quick response with respect to the information. It is also offering the key capabilities at a cost-effective price in order to process the streamlined data at a particular scale with the help of flexible tools according to the needs and requirements. Through the Amazon Kinesis, you can also get the real-time data like the video, audio, application logs, as well as the website click streams, machine learning, and other applications too. This new technique by the Amazon will help you to analyze and process the data instantly instead of waiting for long hours after collecting the data. So this was a quick overview of AWS Kinesis. So now let us move on to the next part here, which is the advantages. So basically the first and foremost advantage of Kinesis is that it is real time. Amazon Kinesis enables you to ingest, buffer, and process streaming data in real time so that you can derive insights in seconds or minutes instead of hours or days. The next point here is that it is fully managed. Amazon Kinesis is fully managed and runs your streaming applications without requiring you to manage any complex infrastructure. And the third point here is the scalability. Amazon Kinesis can handle any amount of streaming data and process data from hundreds of thousands of sources with very low or minimal latency. So these were a few advantages of using Amazon Kinesis. And now let us talk about the next part here, which is the Amazon Kinesis capabilities. So the first service or the capability of Amazon Kinesis is the Kinesis video streams. The Amazon Kinesis video streams are used to secure all the stream data like videos, photos, and the connected devices to the AWS for machine learning, analytics, and other processing, which can give access to all the video fragments and encrypts the saved data without any problem. So you can refer to the diagram that is present on your screen right now. The next point here is Kinesis data streams. So this Amazon Kinesis data streams in the Amazon is specifically used to build the real-time custom model applications by preceding the data stream process by using the most popular frameworks. It can easily ingest all the stored data with all the data streaming prices by using the best tools like Apache Spark that can be successfully run on the EC2 instances. So the next point here is Kinesis Data Firehose. In order to capture, load, and transform the data streams into the respective data streams, this Kinesis data firehose is used to store in the AWS data store near all the analytics with all the existing intelligence tools. These tools can be used to prepare all the loads of the data continuously according to the destination with the durable for analytics, which gives an output like analyzing the streaming data. And the last point here is the Kinesis data analytics. The Kinesis data analytics in the Amazon Kinesis is one of the easiest ways in order to process all the real-time technique with SQL that has to learn all the programming languages with processing frameworks. This Kinesis data analytics is used to capture the streamed data that can run with all the standard queries against the data streams in order to precede the analytical tools for creating alerts by responding it in real time. So these were the capabilities of AWS Kinesis. So now let us discuss the use cases of Amazon Kinesis. So the first point here is the video analytical applications. This Amazon Kinesis in the application is also used to secure all the streaming video for the camera equipped devices which are placed in factories, public places, offices, and the homes to AWS account. This video streaming process is also used to play the video, monitor the security, machine learning, and face detection along with other analytics. The second point here is batch to real-time analytics. Using Amazon Kinesis, you can also easily perform all the real-time analytical steps on the respective data to analyze the batch processing from the data warehouses through Hadoop frameworks. Data lakes, data sciences, and machine learning are one of the most common methods used in such cases. In order to load the data continuously, you make the use of Kinesis Firehouse to update all the machine learning models more frequently for the new and accurate data outputs. The third point here is building real-time applications. If you want to build the real-time applications, you can also use this Amazon Kinesis in order to monitor the fraud detection along with the live leader results. This process can be used to ingest all the streaming data easily to the Kinesis streams with the analytics and the data that is stored in the application itself with the end-to-end latency. All these processes can help to learn more about the clients, products, services, and the applications to react immediately. And the last point here is analyzing the IoT devices. This Amazon Kinesis is used to process the streaming data directly from the IoT devices like the embedded sensors, TV setup boxes, and consumer appliances. You can also use this data in order to send the real-time alerts to the actions programmatically when the sensors exceed the entire threshold operating. It is better to use the sample of IoT analytics codes while building an application. So these were the use cases of Amazon Kinesis. And now we will move to the next part here, which is the comparison between Kinesis and SQS. Amazon Kinesis is differentiated from Amazon's simple queue service, that is SQS, in that Kinesis is used to enable real-time processing of the streaming big data. SQS, on the other hand, is used as a message queue to store the messages transmitted between distributed application components. Kinesis provides routing of records using a given key, ordering of records, the ability for multiple clients to read messages from the same stream concurrently, replay of messages up to as long as 7 days in the past, and the ability for a client to consume records at a later time. Kinesis streams will not dynamically scale in the response to an increased demand. So you must provision enough streams ahead of time to meet the anticipated demand of both your data producers and the data consumers. SQS provides for messaging semantics so that your application can track the successful completion of work items in a queue, and you can schedule a delay in messages of up to 15 minutes. Unlike Kinesis streams, SQS will scale automatically to meet application demand. SQS has lower limits to the number of messages that can be read or written at one time compared to Kinesis, so applications using Kinesis can work with messages in larger batches than when using SQS. So this was a comparison between Amazon Kinesis and Amazon SQS. So the next part here is to understand how does it work. So here I'm going to discuss the Amazon Kinesis data stream, which is one of the capability of Amazon Kinesis. So you can use Amazon Kinesis data streams to collect and process large streams of data records in real time. You can create data processing applications known as Kinesis data streams applications. A typical Kinesis data stream application reads data from a data stream as data records. These applications can use the Kinesis client library, and they can run on Amazon EC2 instances. You can send the processed records to dashboards, use them to generate alerts, dynamically change pricing and advertising strategies, or send data to a wide variety of AWS services. Kinesis data streams is a part of Kinesis data streaming platform, along with other components as we previously discussed, such as Kinesis data firehose, Kinesis video streams, and Kinesis data analytics. So before discussing the architecture, let us have a look at the few of the terminologies that are used very frequently with Kinesis data stream. First term here is, what is a Kinesis data stream? A Kinesis data stream is a set of shards. Each shard has a sequence of data records, and each data record has a sequence number that is assigned by Kinesis data streams. So we will discuss shards and sequence in the later part of this session. The next term here is a data record. A data record is the unit of data stored in the Kinesis data stream. Data records are composed of a sequence number, a partition key, and a data blob, which is an immutable sequence of bytes. Kinesis data streams does not inspect, interpret, or change the data in the blob in any way. A data blob can be up to 1 MB in size. The next term here is the retention period. The retention period is the length of the time that the data records are accessible after they are added to the stream. A stream's retention period is set to a default of 24 hours after creation. You can increase the retention period up to 168 hours, that is 7 days, using the increase stream retention period operation, and decrease the retention period down to a minimum of 24 hours using the decrease stream retention period operation. So additional charges apply for streams with a retention period set to more than 24 hours. The next term here is the producer. So producers put the records into Amazon Kinesis data streams. So say for example, a web server which sends log data to a stream can be called a producer. And next term here is the consumer. Consumer gets the records from the Amazon Kinesis data streams and processes them. These consumers are known as Amazon Kinesis data streams application. The next term here is Amazon Kinesis data streams application. An Amazon Kinesis data streams application is a consumer of a stream that commonly runs on a fleet of EC2 instances. So there are two types of consumers here. So the first one is the shared fan-out consumer, and the second one is the enhanced fan-out consumers. The output of Kinesis data streams application can be an input to another stream, which enables you to create complex topologies that process the data in real time. An application can also send data to a variety of other AWS services. There can be multiple applications for one stream, and each application can consume data from the other stream independently and concurrently. So the next term here is a shard. A shard is a uniquely identified sequence of data records in a stream. A stream is composed of one or more shards, each of which provides a fixed unit of capacity. Each shard can support up to 5 transactions per second for reads and up to 1000 records per second for writes. The data capacity of your stream is a function of the number of shards that you specify for the stream. The total capacity of the stream is the sum of the capacities of its shards. If your data rate increases, you can increase or decrease the number of shards allocated to your stream. The next point here is the partition key. A partition key is used to group data by a shard within a stream. Kinesis data streams segregates the data records belonging to a stream into multiple shards. It uses a partition key that is associated with each data record to determine which shard a given data record belongs to. Partition keys are Unicode strings with a maximum length limit of 256 characters for each key. An MD5 hash function is used to map partition keys to 128-bit integer values and to map associated data records to shards using the hash key ranges of the shards. When an application puts data into a stream, it must specify a partition key. So the next term here is the sequence number. So each data record has a sequence number that is unique per partition key within its shard. Kinesis data streams assign the sequence number after you write to the stream with client.putRecords or client.putRecord. Sequence number for the same partition key generally increase over time. The longer the time period between the write requests, the larger the sequence numbers become. The next term here is the Kinesis client library. The Kinesis client library is compiled into your application to enable fault-tolerant consumption of data from the stream. The Kinesis client library ensures that for every shard, there is a record processor running and processing that shard. The library also simplifies reading data from the stream. The Kinesis client library uses an Amazon DynamoDB table to store the control data. It creates one table per application that is processing the data. So these were some of the terms that you must be aware of before moving on to the architecture part. So the next part here is the architecture of how does Amazon Kinesis data streams work. So what happens here is, as you can see the diagram that is present on your screen right now, the producers continuously push data into the Kinesis data streams. So as you can see here, these are the producers which produce the data. So for example, EC2 instances, client, mobile client, or the traditional servers. So these devices produce the data here, and the consumers process the data in real time. So as you can see here, this data produced by the producers is processed using the Kinesis data stream here. So these are the number of shards that are required for this data here. And these are the consumers which consume the processed data. So say for example, here it is shown that EC2 instances are the consumers. So consumers can store their results using an AWS service such as Amazon S3, DynamoDB, Redshift, EMR, Kinesis Firehose, and so on. So this is the overall working of Amazon Kinesis data streams. So now let us just move on to the last part of this session here, which is the demo. So as far as demo part is concerned, I will show you how do you create a Kinesis data stream and how do you add data to that stream and how do you read that data. So let us just move on to the Amazon console here. So for that, you have to log into your Amazon console here. And once you log in, you will see this main page here, and here you have to click on services. So in the services part, in the analytics section, you have to click on Kinesis. Okay. So once you're done with that, you have to click on get started. So here you can find the documentation part of Amazon Kinesis, which you can read for your further understanding. So let me just click on get started here. So as discussed earlier, these are the 4 capabilities of Kinesis: data stream, delivery stream, which is the fire hose, analytics, and the video streams. Okay, so as of now, I'll click on this create data stream here. So let me just name it. You can name it whatever you want. So let me just name it my Edureka stream. So, and here you have to click on the number of shards. For timing, I'm just writing here 1. So this is the bare minimum value that you can enter here. And depending upon your account, so in my case, it is a free tier account. So for that, I can enter maximum of 200 shards. So the write capacity is 1 MB per second, that is 1000 records per second. And the read capacity is 2 MB per second. So click on 𝐾 stream here. So creating a stream takes only a few seconds. So as you can see here, you get this message here, stream, my Edureka stream has been created and the status is active. So now what we will do, we'll go to the command prompt here and we will try and execute a few commands. So the first command here is the describe stream command. So the command for describing an already created stream is AWS Kinesis described-stream here. And then you provide the name of the stream using this parameter stream name, that is my Edureka stream. And then you just have to specify the region here. Okay, so the region here in my case is Asia Pacific South 1. Okay, once you do that, just hit enter here. Okay, so as you can see here, you get the description or the information of the stream that you just created. And for this, we have one shard ID here, as you can see here, this part. So we will see how to use this shard ID here. So this is the description of the stream that we just created. So the next command that we are going to see is, you have to put the data in this stream, data, or you can see the record. So the command for that is AWS Kinesis put record, stream name, the name of the stream, the partition key, I've just specified it to 1, and the data. So data, you can enter whatever value that you want here. For time being, or for this example, I have entered here 1, and then you have to specify the region here. So just hit enter here. So for this record here, you have the shard ID and the sequence number. So similarly, let me just enter one more record here. So let me just enter the data 11, and the partition key should be different. So it's 2 here. Again, hit enter here. So one more record has been added. Just let's add one more record here. Data is 111 and partition key is 3. Okay, so just hit enter here, and you'll see this record has also been entered with a shard ID and sequence number. So the next command that we're going to see here is the command to get the shard iterator. Okay, so what a shard iterator will do, so let me just brief you regarding that. So a shard iterator will iterate through a set of records here. So if you just had to iterate through the number of records that you have in your data stream, so for that purpose we use shard iterator here. So the command for that is very simple, as you can see on the screen. AWS Kinesis get shard iterator type, which is trim horizon here in this case, and then you have to enter the shard ID here. So for these records, so say for example for the first record here, the shard ID is this one. Okay, so let me just copy it and paste it here. So once you do that, you just have to hit enter here, and after this command gets executed, you will get a shard iterator. So this is the shard iterator that we have just got. Okay, so this lengthy thing here, so let me just copy it. So now once you have the shard iterator, what you have to do is you have to get the number of records here. So for that, the command is AWS Kinesis get records shard iterator, and then you have to copy this iterator here, copy it, you can just paste it here, and you have to enter the limit here. So say for example, if you want only 2 records, so you can do that using this flag or parameter called limit here. So let me just enter the limit for 3 here, since we have entered 3 records. So if you just hit enter here, so as you can see here, you have got 3 records here. Okay, so this is the data and this is the partition key. So data is in encoded form here, this MQ equal to, okay, and the partition key is 1. So similarly, we have another data, and the partition key for that is 2. Okay, so this was 1, this was 11, and this was 111. So you can also decode this data if you want. And for the third record here, the partition key is 3, and this is the data here. So this is how you write data and you get records from the Kinesis data stream here. So I hope this demo here, it is good enough to get you started with Amazon Kinesis here. Similarly, you can get started with other Amazon Kinesis services here, such as the Firehose, Analytics, and the video streams. So this was the demo part here that I've just covered.
What are containers? Containers are an executable unit of software in which application code is packaged along with its libraries and dependencies. So it can be run anywhere, whether it is a desktop, traditional IT, or the cloud. Containers are small, fast, and portable because, unlike a virtual machine, containers do not include a guest OS in every instance. Now, as I've mentioned about virtual machine, let us take a look at container and virtual machine's architecture. Here, virtual machine has a host operating system, its infrastructure, and a layer called the hypervisor, which is a software that creates and runs the virtual machine. Then it contains the guest operating system, which is the virtual copy of the hardware that the OS requires to run, along with that application and its associated libraries and dependencies. Now, when you look at containers, instead of virtualizing the underlying hardware, containers virtualize the operating system. So each individual container contains only the application and its libraries and dependencies. The absence of the guest OS is why containers are so lightweight and thus fast and portable. And also, container runtime is a software that executes the containers. Now that you have an understanding about what are containers, let us move on to the next topic and see containers on AWS. Containers on AWS can be divided into three categories: registry to store container images, orchestration that manages when and where the containers are run, and the third category is flexible compute engines to power the containers. Now let us discuss about these one by one in details now. First, in orchestration, we have Amazon ECS. Amazon Elastic Container Service is a highly scalable container management service that makes it easier for you to run, stop, and manage containers on a cluster. The containers in ECS are defined in a task definition that are used to run individual tasks or various tasks within a service. The task definition can be thought as a blueprint for your application. Now, to run your application on Amazon ECS, you must create a task definition. The task definition is nothing but a text file in JSON format that describes one or more containers that form your application. And here you can have only up to 10 containers. Now let us take a look at the working of Amazon ECS. Now you can see Amazon ECS schedules your task, which is usually done by Amazon ECS Task Scheduler. They are responsible for scheduling or placing your task within the cluster. Now you can see all the containers run within the ECS cluster. An ECS cluster is nothing but a logical grouping of tasks or services. And when you first start using ECS, a default cluster is created for you. Now you can see the container agent or the ECS agent runs on each container instances within an Amazon ECS cluster. The agent sends information about the resource's current running task and resource utilization to Amazon ECS. Now the container images are then downloaded and stored in the container registry. The container registry could be Amazon ECR, Docker Hub, or a self-hosted registry. Now let us move on and take a look at Amazon EKS. Amazon Elastic Kubernetes Service is a managed service that can be used to run Kubernetes on AWS. And you can do this without needing to install, operate, or maintain your own Kubernetes control plane or nodes. Now let us first understand what is Kubernetes, then we can see what are the control plane or nodes. Kubernetes is an open source system for automating the deployment, scaling, and management of containerized applications. Kubernetes works by managing a cluster of compute instances and scheduling containers to run on the cluster. So in Kubernetes, containers run in logical grouping called pods. So you can run and scale one or many containers together as a pod. Now, Kubernetes control plane software is a software which decides when and where to run your pods. They also manage your traffic routing and scale your pods based on utilization or other metrics that you define. Kubernetes will automatically start pods on your cluster based on the resource requirements and automatically restart pods if there are any instances that are running on fail. Now, the advantages of using Kubernetes is because it is an open source project, you can use it to run your containerized applications anywhere without needing to change your operational tooling. These were the orchestration management tools. Now let us have a look at Amazon Elastic Container Registry. Now this is a fully managed container registry that makes it easier for you to store, manage, share and deploy your container images. Now if you're wondering what is a container image, it is an immutable file that contains the source code, libraries, dependencies, tools and other files needed for an application to run. Now due to its read-only quality, these images are also sometimes referred to as snapshots. Now the advantages of using Amazon ECR is you do not have to worry about operating your own container repository or scaling the underlying infrastructure. Amazon ECR will host your images in a highly available and high-performing architecture, which will allow you to reliably deploy images for your containerized applications. You can also share your container software privately within your organization or publicly worldwide for anyone to discover and download. Now let us move on to the next management tools, which are Amazon EC2 instances and Amazon Fargate. Amazon Elastic Compute Cloud, or EC2, is a web service that provides secure, resizable compute capacity in the cloud. The advantages of running your containers on EC2 instances is you have complete control on the compute platform. You can select the operating system, the memory required, the CPU, and many more. The billing is based on the cost of underlying EC2 instances. It allows you to optimize the process by taking advantages of billing models like spot instances or reserved instances. And you can also increase or decrease your computing capacities within minutes. Now on the other hand, we have AWS Fargate. Fargate makes it easier for you to focus on building your application. It removes the need to provision and manage servers. It will let you specify and pay for resources per application. And it also improves security through application isolation. The advantage of using Fargate is it will allocate the right amount of compute, eliminating the need for you to choose instances and scale cluster capacity. In Fargate, the billing is based on CPU or memory requirements per second. These were the container management tools on AWS. Now let us move on to the next topic and see some of the advantages of running containers on AWS. The first advantage is security. AWS offers 210 security, compliance, services, and key feature, which is 40 times more than the next largest cloud provider. It also provides strong security isolation between your containers, which will ensure you're running on the latest security update and give you the ability to set access permission for every container. The second advantage is it is reliable. AWS Container Services run on the best global infrastructure with 77 availability zones across 24 regions. They also have service level agreements for all their container services. The next advantages would be it gives you a variety of choices. It offers choices of services to run your containers. You can choose AWS Fargate if you want serverless compute for containers, or Amazon EC2 if you need complete control over a compute environment. You can also choose from ECS or EKS for container orchestration. AWS Container Services are deeply integrated with AWS by design. So you can use various AWS services. For example, for load balancing, you can use Amazon Elastic Load Balancing. For monitoring, you can use CloudWatch. For networking, you can use VPC and so on. These were just some of the advantages of running containers on AWS. Now let us move on to the next topic and see some of the use cases for containers on AWS. The first use case is microservices. Containers provides process isolation that makes it easier for you to break apart and run application as individual components called microservices. The next use case is batch processing. You can pack batch processing and ETL jobs into containers. Now if you're wondering what is ETL, ETL stands for three different terms, which is extract, transform, and load. This will allow you to start your job quickly and scale them dynamically in response to demand. The next use case is machine learning. You can use containers to quickly scale machine learning models for training and run them close to your data source on any platform. Moving on to a fourth use case, which is hybrid applications. Container lets you standardize how code is deployed, making it easier for you to build workflows for applications that run between on-premises and cloud environments. The final use case for today is application migration to the cloud. Now, container makes it easier for you to package the entire application and move them to the cloud without needing to make any code changes. These were some of the use cases for running containers on AWS. Now let us move on to the demo part and see how can you deploy a container on AWS. Now for the demo, let me switch to the AWS console. Now we'll start by searching ECS. Here it is. Now this is what the Amazon Elastic Container Service page looks like. So when we scroll down, we can see some of the advantages of ECS. It says you can run containers at scale, it provides flexible container placement, and it is integrated and extensible. Oh, let's get started. Here we can see a diagram of ECS object which contains the container definition, task definition, service, and cluster. We will look into this one by one. So first we have container definition. So container definition is choosing an image for your container. So you can start quickly and define your container images. So these are some of the sample container images. You can edit it from here. You can change your container name and also the container image. Next we have private repository authentication. It is an authentication for your private repository. So if there is a container image you want to pull from it, you should mention your secret manager ARN or the name of it. Next we have the memory limit, which is set to 512 MB. And after that we have port mapping. Port mapping is nothing but which allows your container to access port on the host container. Let us not make any changes in that and move on to the task definition. As I've mentioned before, task definition is a blueprint for your application. So here we have the task definition name and the network mode. The network mode is the Docker networking mode used for the container. Next we have the task execution role, which is the IAM role used by your task. The compatibility is the launch type you use. In this case it is Fargate. You can also use EC2 instances. Next we have the task memory, which is 0.5 GB, and the task CPU, which is 0.25 virtual CPUs. Now if you want to make any changes in this, you can just click on edit and you can make some changes. But now I do not want to make any changes, so let me click on next. The next step is you define your service. A service allows you to run and maintain specified number of instances of task definition. For example, you can run and maintain 3 instances of task definition in an ECS cluster. Here you have your service name, which is sample app service, and the number of desired tasks is 1. Application load balancer distributes the incoming traffic across the various tasks running in your service. Now if you do not want to use a load balancer, a security group is created to allow all the public traffic to your service only on the container port specified in the previous step. But if you want to use an application load balancer, 2 security groups are created to secure your service. In today's demo, let us not create any load balancer, and we'll click on next now. The last step is to configure your cluster. As I've mentioned before, clusters are logical grouping of tasks or services. First we have the cluster name. Now let us change it into Edureka ECS. Next we have the VPC ID and subnet, which will automatically be created. After we set this, now let us click on the next button. We will have to review our details now. Everything looks good. Now let us move forward and create our own container. We click on the create button here. Usually creating a service might take up to 10 minutes. Here you can see your cluster name, your task definition name, and in some time even your service name would be visible over here. And you can also add additional features after your service is created. Now you can see 7 out of 9 is complete. We're just waiting for 2 more. Now the loading is complete. Let us view our service. We click on view service. And here we have the detail of our service. Here we have the cluster name, the status, the task definition. We also have the launch type, which is Fargate, the service role, and is created by whom. As we have not used load balancing, you can see we have no load balancer. Here are the network access details. Now when we click on task, it will show you that there is 1 running task. And when we click on events, the first event is the task is started, the second is deployment is completed, and the third is it has reached a steady state. Now under auto scaling, you can see there is no auto scaling resources configured for this service. So moving on, we'll see what is deployments. Deployment consists of the task placement and the service deployment options. And in metrics, we have the CPU utilization and the memory utilization. as I have not assigned any tags, so even this would be empty. You can click on logs and see at what time what task was running. So now let us go to task and click on our task. Now here we just have to copy our public ID and paste it in a new window. Here, now your application is running on a container in Amazon ECS using Fargate. So this was our demo application. Now let us go back and see how you can delete the service and the cluster. Now just click on cluster over here. So here you have your cluster name and it is running on Fargate, and you can see the running task is 1 over here. So now let us click on the cluster name, and we have an option here to delete our cluster. So we click on this and type in delete me and then click delete. This process might also take a few minutes. Now we get a confirmation message saying deleted cluster, your cluster name successfully. Now this is how you delete your cluster.
So what exactly is Docker? Now first let us take a look at the basic definition, as in what does the definition has to say. Now as far as the definition is concerned, it stands for a tool that basically lets you create, deploy and test applications in different environments. Now the second line here is very interesting. It says that it is nothing but containers which are lightweight alternatives to virtual machines, and they let you do that on one single OS. Yes, now for people who are completely new to Docker, they might wonder what virtual machines are, what containers are, and what am I talking about creating, deploying and running applications in different environments. Well, to understand this particular term or these terms, let us first understand what virtualization is, and probably all these terms would make a lot more sense to you people. So let us first understand what virtualization is. Now guys, if you talk about virtualization, this is the scenario that existed before virtualization actually came into picture. Now to consider computing or to consider software usage or development, we all know that we need a hardware on top of which we have a software, and on top of which we run our applications, right? As simple as that. We all use laptops, computers, systems. So what we do is we probably have a system which is your hardware, on top of which you have an operating system which is a software, or basically an operating system which actually lets you go ahead and use your applications, whether it's your Java application, playing some games, playing music, whatever it is. For that you need a basic operating system which is a software. So when you talk about software development, this is what you need. You need a basic infrastructure, a hardware, on top of which you have an operating system, and on which you basically run applications. But when you talk about software development, it is not that simple. I mean, you're talking about n number of applications, n number of processes. Let us consider Amazon. Now when you talk about Amazon, whether it's the e-commerce website, whether you're talking about Amazon Web Services, or the various applications they host on top of their platforms. Now all these applications, they basically have so many parallel applications or small applications running. I mean, e-commerce website, for example, there you have your billing section, you have your different product section, you have customer service, and a number of other sections, right? So having a monolithic application actually makes our architecture very difficult to use, and also for the people who are monitoring it, maintaining it, it is a tedious task for them. The other disadvantage of this particular architecture is that the fact that there are multiple applications or multiple processes running on a single architecture, what it does is it kind of makes all those applications dependent on that particular infrastructure. Suppose if I wanted to use like multiple operating systems or different operating systems to run different kind of softwares. So if I was bound to a particular infrastructure, I wouldn't be able to do that. So what virtualization does is it basically lets you use one infrastructure on which you can run virtual softwares or have virtual environments running parallelly, so that you can run different operating systems. To give you a very simple example, we have our laptops, right, in which we have operating systems. What if I wanted to run multiple operating systems? Probably if I can install a particular software, something like a virtualization software, what that would do is that would basically let me run multiple applications on that particular hardware. So this is what virtualization does. It lets me run multiple operating systems, multiple kind of applications in a single environment. But the best part about it is when I'm using it as an individual, I do not realize that I'm working on a virtual environment. Instead, it feels like I'm working on a single system. That means if I'm using an operating system, say Windows, and running a particular software on it, parallelly if I have one more instance on which I'm running maybe a Mac OS, what I would feel is my Windows OS is running on a different system and my Mac OS is running on a different system. But that is not the case with virtualization. It is actually giving you that feel, but the underlying architecture is one, on top of which you are running multiple operating systems and multiple softwares on top of that. Now, if you actually go ahead and take a look at the architecture, this is what it looks like, virtualization in particular. Now, if you talk about a particular virtual machine which runs or is based on virtualization, you would be having a server host, that is your basic hardware, on top of which you'd be having a host operating system, and then a hypervisor. Now, what is a hypervisor? Your hypervisor is a middleware or a middle layer. Now, this hypervisor, basically it acts as a middleware that communicates with your host applications, not host applications, your host infrastructure basically, and it also communicates with the operating systems or the applications that you want to run on top of it. So what a virtual machine does is it gives you the basic infrastructure, which is must. I mean, no matter what kind of application you are running, you need a basic infrastructure, that is your server, where you can actually go ahead and host your applications, and on top of it you have your host operating system. So what virtual machines do is, using this hypervisor, they let you run n number of different virtual machines which would have their own guest OS, which would have their own binaries, libraries, and applications that run on it. So what this approach does is, this basically helps you in to a certain extent where you can actually save in some money and some time as well. I mean, instead of having n number of machines running parallelly, you can have one machine, and on top of that machine you can have various virtual machines. So you're actually saving up costs for running various hardwares or various servers. Instead, on one server you can have various virtual machines. So yes, you're saving costs as well, and the fact that you can switch between different OSs and different instances or environments, that also helps you save time. But again, is this the most efficient way? For certain applications, definitely yes. If you need privatization, you need more private approach towards your applications, towards your operating systems, towards your binaries, libraries, then yes, virtual machine is a good approach. But in case if time is something that is very important to you, probably you wish to save more space, in that case you have a better option. That option is your containerization. Now take a look at this diagram, and probably I would again get back to virtual machines and have a discussion on these topics. Now when you talk about containers, it is similar to your virtual machines. Yes, so here too you have basically a server and a host OS. I mean, that is understandable. As I've already mentioned, you need an underlying architecture. So that is what you have. But on top of it, you do not have a middleware. Instead, what you have is you have a Docker engine. And the best part here is you do not see a guest OS. Directly what you see is you see containers instead of your virtual machines. And even in those containers, what you see is you see your applications, you see your binaries, you see your libraries, and those things. So how is containerization better? Well, what containerization does is it actually saves you from certain factors, like you do not need a hypervisor, you do not need a guest OS here. So that means the process, that is your virtualization process, in which virtual machines spawn a completely different guest OS, that takes time. But in case of your containers, that time is saved. How? Because you do not have guest OSs here. So if a virtual machine takes, say, certain minutes to launch, your so-called container would take seconds to launch. So yes, you're saving time, and the fact that you're not using extra resources. I mean, if you are spawning a guest OS, some space extra would be consumed and would be occupied. That is not the case with containers. So if you talk about more efficiency, yes, containers in certain aspects are more efficient. But again, guys, do not mistake me for the fact that I'm saying that containers are better than virtual machines. No, that is not the case. It depends upon the applications. What kind of applications are you using? For certain applications, virtual machines are better. For certain applications, containerization is better. So containerization or containers basically are good enough when you talk about speed, or you need faster deployment, faster creation and testing of applications. So in that case, containers serve much better. So again, what are the exact differences? Where should you use virtual machines and where should you use containers? Well, that is not the discussion for today. For some other time, probably we would have discussion on those topics. For now, our main focus is containers and Docker. So this is what a container is, and I believe by now you have a clearer picture as to what a container is, and if you go back, you would be able to relate to this definition in a much better manner. So back then I said that Docker is a tool which is designed to make it easier for you to create, deploy and run your applications. Now using containers, that actually becomes true. And the fact that containers are lightweight alternatives to virtual machines, probably this sentence is making a lot more sense to you people now. So yes, this is what Docker is. It basically lets you spawn these containers using which you can actually create, deploy and run your applications much faster by using containers. So again, what is the other benefit, or what is the anomaly that Docker containers overcome? Now, if you all know what DevOps is, which is an approach that brings in developers and operations team, what DevOps strives at is basically bringing in these two teams. Why? Because developers normally develop softwares and operations team probably maintains those softwares. So when you talk about maintaining that particular software, what happens is the software that is developed in your development environment might not work in the production environment. And one of the reasons for that is probably the change in environment in which you're running the software. So this is not the case when you use containers. Why? Because a container is nothing but it is a limited object, or think of it as a limited box in which you only have your binaries, in which you only have your application details or code. So basically when you pick up this container and if you run it on any machine that supports Docker, probably your image would run the way it ran. So testing your images, or rather your applications, becomes much easier when you use a container. So this is what Docker is, and this is what it lets you do. So by now we've already discussed what Docker is, we've understood what virtualization is, and we've gone through what containerization is. The fact that we are talking about Docker and we are talking about using it on AWS, let us try to understand AWS a little more so that we can probably relate Docker with AWS a little better. So what exactly is AWS? So when you talk about AWS, it is Amazon Web Services, and it is one of the most popular cloud service vendors that are there in the market. Now, what is a cloud service vendor? I just talked about creating applications, running applications, hosting applications. So if you do it on a private infrastructure, the structure actually becomes little redundant, or I should say little stagnant, because scaling up becomes an issue, maintaining servers becomes an issue, and it becomes a costly affair as well. Instead, if you could rent these services and let somebody else maintain it for you, the affair becomes a lot cheaper. And that is what cloud computing and cloud vendors do. They let you rent these services, that is your compute power, database, storage, content delivery, monitoring, machine learning, and a number of other services, and even container services these days. So why AWS in particular? Now AWS is one of the leading cloud service providers in the market, and it has the highest market share when you talk about cloud computing. So yes, when you talk about containerization as well, it did pick up steam in like last 5 to 10 years, and that is why AWS also decided to incorporate containers or Docker and Kubernetes in their infrastructure. What happened and how did all these things happen? Let us just move further and try to understand, as in how did AWS did take in Docker approach as well. Now these are two of the key services when it comes to containerization or hosting Docker applications basically. So what happens here? If you go back to somewhere around 2013, containers were actually catching steam and people wanted to use containers. At the same time, AWS, as we all know, has been popular for a while now, maybe a decade or so. So yes, people were also using AWS and they wondered, as in, can AWS be used to use containers? And AWS replied in 2013 saying that yes, you can definitely use containers on AWS as well, Docker on AWS as well. And how? The answer to that was Amazon ECS, that is your Elastic Container Service, EC2 container service. Basically, you can call them by any name, both are kind of correct. So when you talk about ECS in particular, what it does is it lets you take care of quite a few things when it comes to containers. I mean, it lets you create clusters readily, it lets you have certain operating systems or certain instances or environments in which you can actually host these clusters, on top of which you can run multiple containers. But then the problem with ECS was there were certain dependencies where the user had to get involved. I mean, when it comes to auto scaling is a process where you want your application to scale automatically. So you had to set up auto scaling so that if the traffic on your applications increase, that can be handled or balanced. But what this did was this actually made a anomaly or created a problem where people were actually dependent on Amazon Web Services or ECS to a certain extent. So people actually wanted something that would take care of this anomaly as well and make the process of only maintaining the applications and creating the applications as the primary task. So this is when they introduced Amazon Fargate, somewhere around 2015-ish, 16-ish. I do not remember the exact year, but this is when it happened. And in that phase, what they did was they actually did go ahead and ensured that you were no longer responsible for taking care of your auto scaling and all those things. And what this did was they actually did use in the environment for Amazon ECS, but using Fargate, what happened was you were not required to worry about the instances that you create and all the underlying architecture that probably required your intervenience or basically your participation. So all you had to do was use Fargate, create clusters, containers, and directly work on your applications without having to worrying about all these pointers. Now, as I move into the demo part, I would be talking about quite a few terms like instances. We would understand what EC2 is, what compute services are, what Amazon Fargate is, what ECS is. So if you've missed out on certain pointers and not understood those, do not worry. As we get into the demo part, all these things would make a lot more sense to you people. So let us not waste any time and quickly just switch into the demo part, shall we? So guys, this is what the AWS console looks like. Now, again, for people who are completely new to Amazon Web Services, let me tell you one thing that Amazon Web Services gives you a free tier account using which you can actually go ahead and do quite a few things. You can understand how cloud computing works. You can actually host your applications. You can load balance those, scale down those applications, and a number of other things. You can set up networks, you can actually create security groups, make sure that all these services are secure, and quite a few other things. So yes, for people who are completely new, I would suggest that you actually go ahead and create a free tier account on Amazon Web Services. Now, these services are made available to you for free for 1 complete year. Yes, what Amazon Web Services does is it probably gives you certain services for free for certain duration, and if you exceed certain limits, only then you're charged. Otherwise, if you stay in the limit, you would not be charged for 1 complete year, and which I believe is more than enough if you just have to go ahead and practice these services or get sufficient hands-on on Amazon Web Services or cloud computing. So again, if you do not have an account, just go ahead and create an account. Do you need any details to create this account? Probably you'd have to visit the console. Just type Amazon Web Services console or Amazon Web Services free tier, and you can click on the first link that is available and you would be redirected to this page. This is not what it would look like. Instead, what would happen is basically a sign up page would come in where you'd have to enter your email ID, maybe what is the purpose that you're visiting this particular website, and probably they would ask you to enter in your credit card or debit card details. Do not worry, AWS won't charge you without your consent, and probably you can set in your alarms as well so that you do not exceed the limits that you use. So having said that, I would want you all to have an account on AWS because it is a very fun and nice platform to work on. So once you do have an account, this is what you have at your disposal. let's have a quick introduction to what are the services that are here and what all can be done with it. Once we are done with it, we'll probably jump into the Docker part and we would see what we can do with Docker on Amazon Web Services. So guys, as you can see, there are quite a few services here. There are compute services. You have your EC2, Lightsail, ECR, ECS. We would be using ECS today, and to some part I would be talking about EC2 as well, which is your elastic cloud compute. I talked about virtualization, right? So what virtualization does is basically we create virtual machines. So cloud computing, or AWS in particular, lets you create virtual machines as well, and instead of calling them virtual machines, we call them instances here. So you can launch multiple instances, or basically environments on top of which you can run applications. So one way to actually go ahead and host your Docker applications or containers is you can actually launch an EC2 instance, and on top of it you can actually go ahead and probably install Docker and then host containers or have containers which you can run to run your applications. So that is the old school method, where your EC2 acts as your system on top of which you're gonna go ahead and play with your containers. The other way is your ECS and AWS Fargate. Now these services, what they do is they completely cut off the process where you have to go ahead and spawn an instance on top of which you have to create security groups and do a number of other things. So in this session we would be doing both the things. First I would show you certain things, as in how do you get started with your Docker in EC2, and then I would switch to Fargate so that you understand Fargate in a better way and you understand why do we actually need to use Fargate. So let us do that. Let us just go ahead and launch a simple virtual machine. Not a virtual machine, rather an instance using EC2. So if you click on EC2, this is what you'd be redirected to. You can launch an instance by clicking on this icon. So as you can see, in the marketplace you have quite a few options. You can choose AMIs. AMIs are nothing but images. Basically when you create a template or create an operating system, it has a by default template which AWS saves as in the form of images. So these images are nothing but templates for your respective environments or operating systems which you might want to use. Now when you talk about Docker, it has to be on Linux. I mean, yes, there is a way you can do it on Windows as well, but preferably it is Linux. So let us just go ahead and launch a Linux instance first. So this is a free tier eligible. That means I won't be charged if I launch this instance. So I do that. And then there are certain details. What is the family of your instance? There are quite a few families. You have T2 micro, you have various other actually families which you can actually go ahead and explore. Now again, if we keep discussing those families, this session would go too long. So let us just stick to the basic or the free tier resources that we have. You can actually go ahead and explore these resources if you want. If I go to the next button and I click on it, it would show me some other settings. For now, my main concern is this part. Yes, the security group. So when I launch an instance, I need to log into my instance to maintain security. So you have certain security groups which ensure that these are the rights users have when they try to access these kind of instances. So we need to actually go ahead and set up a security group to some extent. So there is one rule which says that I allow traffic from SSH. Protocol here is TCP, and this is the port it is using. I can actually go ahead and add one more rule. I can say HTTP. There you go. And allow traffic from anywhere basically. Now I can say review and launch. In order to sign into my instance, I need a key pair, which is a security measure. So I need to create a a key pair rather, and make sure one thing, guys, that if you do create a key pair, you save it properly. So say, let us name it, say Sam new. I'm very bad at naming conventions, guys, so please forgive me for that. Again, guys, you have to take care that this key pair is well maintained. You do not lose this key pair. So if you do create one, you just need to save it somewhere. And then I say launch an instance. So guys, what is happening here is my instance is getting launched. So once this instance gets launched, I can actually go ahead and install Docker on top of it and do quite a few things with it. Now the reason I'm going through this drill is because I want you to understand what is happening here. So this is like basically going ahead and just creating an instance on top of it, running your Docker and doing all those things, which was very relevant say 3-4 years back. Now there are better ways to do this, but first let us see how do we do it in this particular way. So if I go back to services, I go back to EC2, you can see that an instance would be here saying that there is a running instance which I just created. Let us see whether that instance is launched or it is still getting initialized, guys, but that is not a concern. I can connect it to or connect to this instance. So guys, this being a Linux instance, I need to actually go ahead and use a key to log into this instance, and this being a Linux instance, I cannot use this PEM file. It needs to be in PPK format, and to do that we have a software. If you do not have this software, you can install this. It is PuTTY. So you have PuTTY software which lets you use this key or convert this key, and to generate a PPK key you need 𝐵TYGEN as well. This is the other software. So what you do is you just click on load and you select the file that we just actually downloaded. So it is not here because it is in different format. You can see PEM. I say open, and always save a copy of this key, guys. Do you want to save it? Yes. And what should be the name? Let's say sample12. I say save. So the key is saved here. Now I can actually go ahead and launch my instance. First let us confirm whether our instance is up and running, whether it has initialized or not. Okay, it is still initializing. Let it get initialized, and once it is done, probably we can actually go ahead and connect to this instance. At times this can be troublesome. I mean, you have to wait for certain things. So guys, again, as you can see, I've launched an instance. The launching process is taking time. When you talk about virtual machines, which I mentioned, it takes a while. Why? Because it boots in a guest operating system, and hence this time. I mean, the checks, the quality checks, the initialization process, all these things, they can take a little longer while than normal. Okay. So meanwhile, just let me tell you what we have to do. The fact that we have a key now, probably we can actually go ahead and connect to this instance by using this PuTTY configuration. You have to enter in your host name, and you have to enter in that PPK file as well. So let us see whether these status checks are complete or not. Yeah, as you can see, the status checks are complete. So when I say connect, I get certain details. Now these are the important things. This is the stuff I need to copy. There you go. And I paste it here in this host name. Okay. And then I go back to this place. I click on data, and here if I come back, the first part before at, I can copy that and I can just come here and paste it here. Now I need to actually go ahead and select the PPK file which I saved. So to do that, I click on SSH, and in that I click on authorization. I browse, and here is the file. I say open. I say open. Yes. So guys, what it has done is it has launched a virtual machine on top of which I'm gonna install Docker now. How do we do that? First, let us check whether I am the right person or I have signed in as a right person. Yes, EC2 user, this is me. So I should say sudo yum update. Why? It would get in the necessary details that are needed to install Docker on top of it. Okay, it is almost done. It should be done soon. There you go. So next what we do is I say sudo yum install docker. Okay, I made a spelling mistake here. So when I go ahead, guys, what I can do now is I can just say sudo service docker start. Okay, I'm not doing it fairly well today. Sudo service docker start, and there you go, guys. It has configured your Docker service here. So guys, this is about configuration. I mean, back then when containers were new, this was actually still very fast and very effective, but as I've already mentioned, there are faster ways to do it. Now by now what we've done is we've just installed an instance, and on top of that instance I've actually installed Docker. So that is the only thing I've done. But if I do it using certain services, this process can be speed up like anything. I mean, you do not have to worry about anything. Here we haven't created a cluster, we haven't done almost anything. So let us just go ahead and use one of the services, as in your ECS or your 𝐓𝐺𝐻. Let us see what we can do using those services. So let's just close this for now. Yes. Again guys, one more suggestion: if you do have your instances or services, make sure you terminate those, because that actually helps you basically save any costs that you might incur. This being a free instance, that wasn't the case, but still, let me just shut it down. I've done that. Now I'm gonna go to ECS. This is a fresh account, so you do not have any applications running here. So let's just say get started. So guys, this is what we are going to do. We're going to go ahead and create an image that is basically your container definition, as in your basic code, your application, whatever you want to run. In this case, we would be using a sample application. Then we would be having a task definition, where this task definition, what it does is it has some other attributes which are not there in my container definition or in my image, to manage my so-called containers or to run my so-called containers. And then you have your service, which tells your cluster or your Docker daemon rather to run a particular container image and use a particular task to do that. So we would be doing all these things, and we would be creating a cluster, and let us see how long it takes now. So guys, there is a sample application. You can actually go ahead and edit. You can use any kind of container definition you want. You can customize it to meet your needs as well. You see there's an option here which says customize. You can do that as well. For now, let us use the basic application, the sample application. So that is selected by default. Task definition, guys, again, this would be basic or by default. You can make changes here. You can change the name. You can decide what network mode to use. You can decide what execution role you want. If you have any role, you can actually assign that particular role, where you can assign particular properties to it. And what are the compatibilities? In this case, it has to be 𝐓𝐺𝐻, because I would be using 𝐓𝐵𝐺𝐻, and this is the task memory that is allocated by default. So let us stick to those configurations, because we do not want to get charged unnecessarily. So yep, this is what it is. I'm gonna say next. Now it says define a service. A service allows you to run and maintain a specified number of simultaneous instances of a task definition in an ECS cluster, something that I told when we did get started with this particular topic. Number of desired tasks, you can change it, you can edit it, you can have multiple tasks, just to be secure, so that if any of these tasks it goes down, if its health is low, you can actually go ahead and use the other task as well. But in this case, again, let us stick to one task only. Load balancer, if your website experiences high amount of traffic, you can balance that by using a load balancer. Let us create one for sample. So it would be using this port as the listener port and protocol would be HTTP. So I say next. There you go. And then it says configure your cluster. Should I name it something? Let us say today's cluster. Again guys, I'm very bad at naming conventions, please forgive me for that. You have a VPC ID and subnets which it automatically creates. You can let them do it for now, because again this is a basic application. So I say next, and it asks me to review all these things. For now I'm gonna say create, because I know what all details I have entered. So as you can see guys, it is spawning a cluster and a container for me. And now let us see how long it takes to spawn a container. Now guys, there are 10 processes that are happening here, 3 of which are done, and let us see how quickly the other processes also take place. Again guys, in this case we are not worried about anything. I wasn't concerned about probably creating security groups. I wasn't concerned about creating a virtual machine. I wasn't concerned about using EC2. I wasn't concerned about anything. My only concern was what is the cluster I want, what is the application I want to run on top of it, what is the image I'm using, and all those things, the basic information. And once you enter that basic information, your cluster would be created. Again, creating your images won't take that longer time. Yes, creating clusters might take. Now your cluster can hold multiple containers as well. So yes, certain processes might take a while. So in this case, we can see that 7 services are complete out of 10. Probably we are left with 3 more to go, which should be done very quickly, I'm sure. Maybe say half a minute more. One more thing guys, once we are done with all these applications, creation of these applications, ensure that you actually go ahead and delete all the resources that you're using and all the services that you've used. Let us just go back and see that whether it's completed, and you can see that our process is complete and it is up and running. So guys, let us view this service, what it has to offer to us. There you go. These are certain details. You have your task definitions. Again, Amazon EKS is something that you can use for Kubernetes, which is again a container service. This is not the topic of discussion today, so I did not get into details of this particular topic. But when you talk about this particular topic or creating your cluster is concerned, we have one with us, and there are the details, or here are the details about that particular topic. You have your tasks, the tasks that are running. There you go. It is still pending is what it says. Then you have your events. These are the events, your auto scaling groups, your deployments, and all the details that you need. So if I go back here and I click on this particular icon or the link, it would redirect me to this page. And if I scroll down, you can see that I have a load balancer. If I click on it, I have a DNS name here. I copy it and I paste it here. And there you go. It says that I have a sample application and it has been deployed by using a container. So it has created a container. On top of it, it has run this simple application. Now there is nothing much here, basic code, so you don't see anything too real-time or too interactive, but there is enough of an evidence which says that an application has been launched and it is running on my container. So there you go guys. This is what it is. Probably you have all the details. You can just go back and take a look at other things as well. If you wish to explore these services a little more, you can always do that. So let us just say ECS. and now it would show my cluster here, today's cluster. It was a very bad name, but forgive me for that. Yep. So guys, now that we have all these things, again, if you are doing this for experimental basis, I would suggest that you delete all these things. How do you do that? You click on this icon. First thing that you do is you say update. This is just a security measure. Number of tasks, set it to 0 so that even if you miss out on deleting these, you won't incur too much damage. And then say update. Now that I've updated this service, I can go back and I can just say delete. How do you delete it? You say delete me. And then you say delete. There you go. And it has been deleted. Again, what do you need to delete? You need to delete a cluster as well. So say delete, and the cluster would be deleted. It might take a while to delete your cluster. Before that, okay, let's just delete the cluster first. So once the cluster is deleted, guys, your next step is to actually go ahead and delete the load balancer as well, which again is not that difficult of a task. So guys, we are almost nearing the end of today's session. Once we are done with the deletion process, probably we would be bidding adieu to each other. Please let me know in the comment section how did you feel this session was. If you did like this session, please hit the like button and stay tuned with our Edureka channel, because on our Edureka YouTube channel we have quite a few sessions, quite a few videos that go live almost every day. And if you are somebody who likes to learn, who likes to explore new technologies, understand what is up to date in the market, probably you would have a lot of things to digest, a lot of things to learn when you talk about this YouTube channel. So the previous tech probably took a lot of time. As you can see that from 4 to we are just on 5 right now. Probably that was the process which took a longer while to delete. Now we are on 9. Probably we should soon reach 15. There you go. And the cluster is deleted, guys. Now we go back to EC2 console and let us hope that our load balancer is also deleted, because I deleted the application. So with that, the load balancer should also go. If not, we would delete it manually. Yes, it has been deleted. So all our resources have been deleted, guys. We've actually gone ahead and understood what containerization is. We've understood how Docker works and how you can actually go ahead and create a container, a cluster, and launch an application using AWS. And all this happened quickly because of Fargate, and we saw that EC2 took a longer while to do that. So I believe I've talked about quite a few things, and I hope that I've cleared quite a few myths that you people had about Docker and virtualization.
Now, AWS, as we know, is the global leader in terms of cloud computing services. So AWS is always had, and currently still it holds the biggest market share in terms of cloud computing. So currently it has almost 32% of market share, then followed by Microsoft Azure, having a market share of around 18 to 19%, and then followed by GCP, having a market share of around 11%. And then we have multiple other vendors, like we have DigitalOcean, we have IBM, we have VMware, we have Alibaba Cloud Services as well. So there are multiple vendors that we have in terms of Amazon Web Services, right? And these all are different cloud platforms. And AWS, as we know, is a collection of more than 150 plus services. AWS has a collection of more than 150 plus services that we can go ahead and deploy our applications on. So when we talk about 150 plus services, that includes services for computation, for storage, for networking, for IoT, for AR, VR. So there are multiple services on which we can deploy it. All the major companies, they all are customers for AWS, be it Hindustan Unilever, be it Netflix, BMW, Adobe. So they have a long list of clients, those who all have deployed the services on top of Amazon Web Services itself. And they are different domains now. As we had discussed, there are 150 plus services currently offered in AWS. To be precise, it is 157. And it offers services on computation, on migration, security, storage, networking, content delivery, messaging, databases, and management tools. And for getting a detailed view here, so we can simply open up this link called aws.amazon.com. We can see the entire list of all the services that AWS has to offer to us. So based on computation, integration, cost management, on blockchain, on containers, on end-user computing, on media services, on IoT, on databases. There are multiple applications on top of which we can deploy the services or deploy our application here. And then why AWS is such a hit? Because of multiple reasons. Because again, AWS has, first of all, a large collection of different services based on different categories, right? For example, suppose if we talk about the computation, then we have the service called as Amazon EC2, where EC2 is cloud computation service. Then we have Lambda as a part of serverless computing. So EC2 is based on the virtual servers, whereas Lambda is based on serverless computing. Then we have ECS as Elastic Container Service, offered as a service on where it is mostly used as a DevOps tool when we are working on the entire AWS platforms. And then we have Kubernetes. So Kubernetes, as we know, it's an open source container management tool, which is basically used for automation, for automating the container deployment, and then descaling and upscale. We can simply scale it up, and we can also take care of the entire load balancing as well. We can take care of load balancing as well. And basically, Kubernetes, as we know, is one of the most popular container management, or we can say orchestration tool, where if we have a large cluster of containers, that we had deployed, then we also have Docker Swarm, right? But again, Docker Swarm is efficient for small scale application. If we have large number of containers, then Docker Swarm fails, and that's where Kubernetes come into play. As a part of entire setup here. Now, the features, if we talk about the main features of Kubernetes, offers us an automatic bin packing. So now we know that we have the entire, when you talk about containers, containers, they contain the application and all the bins and libraries for that, right? So the application, so any container, they package two things here. They package the application, right? And they also package the entire bins and libraries required for running that particular application as a part of entire container, right? So the entire bin packing is automatically taken care by tools like we have Kubernetes, right? And the entire service discovery and load balancing, that means the traffic. If we have too much of traffic and then we want to distribute the traffic among different containers, then that can be done easily by using Kubernetes. Storage orchestration, as in if we are looking to distribute the storage services, just like we have HDFS, where we can distribute the entire storage. Suppose that if we want to distribute the entire thing based on different networks, right? Based on different nodes, then we can easily do that, right? Same thing is also applicable on top of Kubernetes. And Java 1.3 is offered as a part of self-healing. Then it also offers a secret and configuration management system. It offers us batch execution, horizontal scaling, and automatic rollbacks and rollouts. That is just like we have for Chef and Puppet, right? Where we can roll out and where we can roll back and rollouts easily for n number of containers. Same thing is also applicable for Kubernetes. If we talk about the entire concept for containers, now whenever we want to share any application with the others. Now, for example, let's say we are looking for the application, right? We are looking for sharing any application. Let's understand this by a simple use case. What exactly is the concept for containers? Go to our Picasso mode. Now, let's suppose here we have coders, and then here we have operations team. And kindly excuse for this beautiful calligraphy, guys, because that's what happens when we try to write using the mouse pointers. we have the coders and operations team. Now the coders, they developed a code on top of Java 1.7. They have developed the code for a Java application, right? And they have developed this on suppose on 1.8. And now they, for testing purposes, they have sent this code to the operations team, right? And when the operations team, they try to run this entire Java code, the code did not work, right? So now they simply complain back to the coders that their code is faulty, their code is filled with bugs, and that's why it is not working. Now the coding team checked again, and Java application code was working fine without having any kind of issues, right? So that means once again, when they send the code to operations team, still they were facing issues. Why? Because the operations team had the Java 1.6 version configured. So obviously, if we have a difference in version, then that will create a compatibility issues, right? And that's why we have to make sure we send the exact copy and as well as the environment if we want to maintain the consistency between the coding, that means the development, and the operations team, right? So what we can do is there are two ways of doing this. We can either create the entire VM, as in we can create the entire VM image, as in virtual machine image, where we have to pack the entire operating system, the entire application, the entire data set, and then we can create the image out of it that we can pass this image to the operations team, and then operations team have to use this image to set up the server and then start deploying it. And again, since this entire VM contains the operating system, the applications, the data, and everything packed aside, that's why this will be much more heavier, because if a typical VM can be as less as 1 to 2 GB, right? So if we are continuously making changes, then that requires 1 or 2 GB of VM to be created and downloaded again from the operations department, right? So instead of doing this, instead of working on VM, what we can do, we can take the help of containers. We can take the help of containers as a part of a Docker environment. And these containers, they do not contain the entire operating system. They simply contain the application and all the bins and libraries that is part of dependency for the application. So that if the VM it is for 1 GB, then this will be simply like a small file of max to max up to 20 to 25 MB as well. So this thing simply makes the job much easier for the entire teams to collaborate with each other without worrying about sharing large containers, large virtual machine images. That's why we need to have containers here as a part of entire example. So the traditional VM, it contains the hypervisor, the server, the guest operating system, the bins, libraries, app1. So each VM has an application, necessary binaries, libraries, entire guest operating system. That's how we can simply deploy the entire application on top of it. Whereas in containers, as a part of the entire container, the containers, they contain only the app and the bins and libraries. They do not contain the guest operating system. Hypervisor, server host, these are already pre-configured in containers in the entire container environment. And in each and every individual container, we simply package the app and all the bins and libraries to support that. And a container, it simply comprises just the application and its dependencies. Now let's talk about Docker and Kubernetes. So Docker is as we know, is the most popular application for the containerization. It's the most popular containerization tool available, where we can use it for building and deployment of containers. And how to coordinate and schedule multiple containers, and how do containers communicate, and how to scale container instances, how to deal with failed containers. For these parts, we do have to take care of a container management tool like we have Docker Swarm, right? So just like we have Docker Swarm, we also have Kubernetes. So Docker Swarm is ideal for small scale application where we don't have a large cluster of containers that we have to take care of. If it's a large cluster of containers, then that's where Kubernetes come into play. So Docker is a tool for creating the containers, and Kubernetes is a tool for managing those large number of containers that on which we have deployed the entire application on. And then we have the service named as Amazon Elastic Container Service, called as EKS, right? So Elastic Container Service, or called as EKS, is a fully managed service by AWS, which simply makes it easier for us to run Kubernetes on top of AWS without needing to stand up, or we can say maintain our own Kubernetes control plane. So unlike the conventional method, unlike the conventional requirement, there is no control plane required to manage and it is secured by default. It is compatible with standard Kubernetes, and it works with Kubernetes community. It simply works with the entire community here as well. Now here we can get started with Amazon Elastic Container Service for Kubernetes. Now here, first of all, here we have to provision the Amazon EKS cluster. Then we can deploy the worker nodes as a part of CloudFormation template. And then we can connect to EKS using the kubectl. And then we can run Kubernetes application on the entire EKS cluster. We can do that. What is the advantage of EKS over the normal containers? So again, we cannot compare containers over the EKS. So containers are the containers in which we deploy the application, and Kubernetes is simply used for management of those containers. Just like we set up the Kubernetes on our on-premise servers, right? Same way we can use EKS as a fully managed service offered by AWS, on top of which we can deploy Kubernetes for management of our entire cluster of containers. EKS is a service for deployment of Kubernetes on top of AWS. EKS is chargeable. So not all services are available under free tier, but again, EKS is chargeable. So now let's see how exactly to go around with this one and how to actually start deploying it. So now let's go back to our entire console. All right, so now here we can create the entire cluster here. Now for the implementation of EKS, let's log into the console. Here we can define the root username. Let's define the root username. Now for this, we do need the access to the entire AWS account. Here we can log into to our console here. Now once we log into the console, first of all, we do need to have, now before we can start deploying the EKS here, we do need to have an entire custom VPC created. And we also need to deploy the entire custom VPC along with the entire AWS CloudFormation as well. Because at the end, we will require to deploy the application on top of our own custom VPC. So now in here, we can define the role here. First of all, in order to get started, we have to define the role. So here we can come back to our service called as IAM. IAM is basically used for identity and access management service. So we can open up IAM, let it open up. May take a couple of seconds. It's taking a bit longer than usual. Now, once we are into IAM here, we have to define the roles here. We can open up roles. And then under roles here, we have to create one role for the EKS. So here we can simply click on create role. Here under the service here, we can choose EKS. So here we can choose EKS manage to, because here we have to allow EKS to manage clusters on our behalf. So here we have to define permissions. We can define add permissions. Here we also already have these two policies, EKS cluster policy and service policy. We can define tags, review. We can name this role as EKS review. Just a moment. Now, once we have the entire role created, now here we will be using this entire EKS review has been created that we'll be using here, right? Now, once we are done, next is we do have to have a custom VPC that we have to create. We do need to have a custom VPC that we do have to create here, right? So what we can do, we can use a custom stack template. So let's first of all fetch the entire VPC template in case there is no VPC created from your end. Just a moment. Now, in terms of VPC, we already have a custom VPC created. So for checking for that part, we can come back to VPC. And because again, as a part of our own cluster management, we do need to have a custom VPC deployed. So first of all, we have deployed the entire role, and then in VPC, we need to have a custom VPC deployed. Here we are using the default VPC that is available from our AWS. So let's change our region from North Virginia to Mumbai. And currently we can see we do have a custom VPC created that we will be using as a part of entire cluster management. Check for the roles as well, just a moment. Now, once we have the VPC and role created, now we can come back to our EKS cluster. So here we can, another service here, we can search for service name as EKS as Elastic Kubernetes Service. Let's open this up. And this is a dashboard for Elastic Kubernetes service on top of Amazon EKS service here. And that's how here, now here we have Elastic Kubernetes as a service, which is a fully managed Kubernetes control plane service as a part of service offered by AWS. Now here we have to start by defining a cluster name. Let's suppose here we name it as EKS and review itself, just like the same role that we define here, or we can name it as EKS Edureka. So here we can define EKS Edureka, then we can simply define next step, and then we can define the Kubernetes version. So here we can define Kubernetes version. Which version are we to install here? So by default, it will be set to 1.14, and here we can keep it to 1.13 or 1.15. So by default, it is basically focused on 1.14. And then we can define the role name here, right? Because again, role has to be assigned, because until we have a role defined here, we won't be able to create that. We won't be able, now this entire cluster will not be created, right? So here we can define the entire VPC, that means the custom VPC that we may have created. So we can choose the default one, or we can choose the custom one as well. We can choose default or custom both. We can choose accordingly. So Dilip, so what is the difference between Kubernetes control plane and basic Kubernetes cluster? So it's like now, just like we have a dashboard, Dilip. Now in the default, we have to set up the dashboard, correct? So same way we'll be having the entire control plane with us. And then here we have VPC. So under VPC, we have VPC. In here, we can define the entire subnets one by one. And then we can define the security groups. Let me suppose here we can define in which particular zone and again in which particular subnet we are trying to deploy this one by one. What is a security group? What is the entire security group that we have on which we are looking to deploy us? Right. So here we have the entire security groups having the access to one specific protocol from which we can choose. Just like we have multiple services defined here, we can simply define this one by one. So now, once we have defined this, then we can simply, we have to choose the network group in which we are given the access here, right? And then we can define the private access. If we want to keep it for private within a VPC, then we can define that. And then we can define the public access here by defining the enable. If we want this to be accessed outside our entire current VPC, then we can define the entire VPC endpoint there. And then we can define the entire encryption. If we're looking to encrypt this with our own KMS, then we can simply encrypt that as well. If we are looking to encrypt this with our own KMS, we can do that. And now once we define the entire cluster here, so now in here we can simply define the entire individual clusters one by one. So here we can simply click on create clusters. We can define the cluster templates if we want to start with the entire cluster template based on networking only, or if you want to go for the AWS Fargate, we can simply create the entire cluster templates, and then we can start deploying the cluster, and then we can simply create the entire cluster so that we can start deploying the containers inside this cluster that we can, for which we have deployed on top of AWS. Whatever activity we can do on this console, the same activity can also be done on the entire concept of CLI as well.
Let's have a head-to-head comparison between AWS and Azure. Compute services. Compute is basically a hosting model for resources like CPU, memory, etc. on which the applications actually run. Now, these compute services can be of four types. That is, infrastructure as a service, platform as a service, function as a service, and hybrid services. Infrastructure as a service. This service is based on the concept of an instance or a virtual machine. In other words, an instance is a combination of all resources like servers, networks, and hardware in an indirect way. Subsequently, the virtual machine provided by AWS and Azure are tailored to suit different use cases. Let us discuss AWS EC2 instances and Azure virtual machines. In AWS EC2 instances, the VM is stored in a persistent storage called as EPS. This instance is created using Amazon Machine Image. On the other hand, in Azure virtual machines, VM is stored in persistent storage called as blob storage. And to create the instance, virtual hot disks are used. Platform as a service. This service provides operating systems, applications, and databases. For example, the AWS Elastic Beanstalk and Azure App Service. The AWS Elastic Beanstalk dashboard allows you to monitor the health of the entire application. However, you can only deploy web applications to it. On the other hand is Azure App Service. In Azure App Service, separate products like Azure Monitor are available to monitor the health of an application. You can deploy both mobile and web applications over here. Now moving on towards Function as a Service. This is basically serverless computing. In other words, the enterprise does not have to go through the difficulties of constructing and maintaining the platform. As a result, you can simply develop, execute, and manage application tasks while the service provider handles the server. As far as pricing is concerned, the amount of resources used by the application determines how much the user has to pay. In AWS, this service can be achieved through AWS Lambda. AWS Lambda supports various programming languages such as Java, Go, PowerShell, Python, C#, Ruby, etc. And it also provides a runtime API for others. Serverless compute in Azure can be achieved through Azure Functions. Just like AWS Lambda, Azure Functions also support various programming languages such as Java, C#, JavaScript, PowerShell, Python, etc. Now talking about a hybrid environment. Hybrid cloud architectures help companies merge the on-campus operations with the cloud. Now this in AWS can be achieved through AWS Outpost, and in Azure you can do it through Azure Stack. AWS Outpost is relatively new and it is suitable for on-premise and public cloud. On the other hand, the Azure Stack is old and has many variants. It also supports private and third-party clouds. So now moving on towards the next comparison factor, that is the storage services. Storage, as the name suggests, is used to store data in the cloud with the ability to scale as and when required. This data can be stored anywhere. Both AWS and Azure provide a number of storage services. In AWS, storage services can be achieved through storage types such as the Simple Storage Service or S3 and AWS Glacier. In AWS S3, unstructured data such as media files, log files, etc. are available through server requests. AWS Glacier can be used for data archival and it is cheap as well. However, the retrieval time is relatively more. On the other hand, Azure provides blob storage and Azure Cool Blob Storage. Blob stands for Binary Language Object. It stores documents, multimedia files, or .exe files. You can privately access the data or share it publicly. Azure Cool Blob Storage is used for data archival and it's relatively costly, but the retrieval time is comparatively less. Database services. The database domain is used to provide reliable relational and non-relational database instances. For relational database, AWS provides RDS, whereas Azure provides SQL database. For NoSQL services, AWS supports DynamoDB and Azure supports Cosmos DB. So now moving on towards the pricing structure of these cloud platforms. Both AWS and Azure offer pay-as-you-go model. In AWS, the Windows Server virtual machine is comparatively costly. Virtual machines are charged per hour. The price of the Kinesis Analytics Processing Unit is 0.11 per hour. In Azure, Windows Server Virtual Machine is cheap due to the Azure Hybrid Benefit Plan and free security updates. Virtual machines are charged per second. The price of the Stream Analytics Processing Unit is 7.271 per hour. So now coming towards the licensing. A software license is a legal tool that allows people to use the software and redistribute it. In AWS, the license manager supervises software licenses and it is free of cost. Microsoft software license can be bought with or without software assurance. In Azure, Azure Active Directory supervises software license but has three pricing models, that is free, premium, and pay-as-you-go. You can move licenses to Azure through software assurance only except Windows products. Big data services. Now, big data is a term that is used for a collection of data sets that are large and complex, which is difficult to store and process using available data management tools or traditional data processing applications. Both AWS and Azure provide different big data services to handle both structured and unstructured data. For big data processing, AWS provides Elastic MapReduce, whereas Azure provides HD Insight. For analytics, AWS provides Kinesis Analytics and Azure provides Stream Analytics. For visualization, AWS provides QuickSight and Azure provides Power BI, availability zones. These zones protect the applications and data from the data center failures. They are present within a region which consists of a set of data centers. Currently, AWS has 77 availability zones and 24 launched regions. Azure, on the other hand, has 60 plus regions that exist, with each having 3 availability zones. So now moving on towards the last comparison factor, that is market share and growth rate. When it comes to the market share, AWS leads the market by 32.4%. However, its growth is monotonous. Azure, on the other hand, is 17.4% of the share, but it is rapidly flourishing. To conclude, I would say that it is really difficult to compare AWS and Azure, as both continue to launch new services, new pricing structures, new products, and the current differences may not be relevant in a few months.
Now, in order to choose a company that is best for you, there are two very important criterion. One, how does the company treat an employee? And how likely is an employee to refer his company to his peers or family members or friends? We would be considering these pointers, and based on those, I have jotted down certain companies. The first in this list, we have Potential Best. Now, these companies have very high numbers on the pointers that I just mentioned, but these being fairly new companies, I do not want to jump on conclusion, and I want to see how do these companies fare on the long run. So for now, these companies find the 10th position. Those are now companies like Netskope, Sysdig, Cloudian, DigitalOcean, Rackspace, Zscaler, Zoho, Kony. Now these companies are fairly good. Yes, some of them are fairly new, at least in the cloud computing market, and they have been doing fairly well. If you take a look at the numbers, the likelihood for a person to recommend this company to his peers is somewhere around 95%, and the approval rate of CEO is also 95%, which is fairly good. But as I've already mentioned, these companies are fairly new in the market. I just want to see how do they fare in next 5 years or 10 years, and probably then we can compare them with the bests in the market. Next on this list, we have IBM. Now, IBM, I'm sure, is known to many people out there who are at least watching this session. The reason for that is it has been there in the market for a very long time. Established in 1911, it is highly flexible and it boasts of a number of employees that it has, somewhere around 435,000, which is a huge number. And the fact that if you take a look at the reviews given by employers on popular websites like Indeed, Glassdoor, you'd know that employees are really happy. The benefits given here are great, and there is a very good work-life balance. And when you talk about cloud computing, this company is into developing cutting edge technology or embracing cloud to its best. And that is why we see that the number of employees that have recommended this company is 70%, and they approve of their CEO, at least 72% of them do that. And that is why this company finds 9th place in this list. 8th on this list, we have Oracle. Again, now Oracle is a fairly popular company, and one of the major reasons it finds its place in this list is because it is one of the best when it comes to PaaS, that is platform as a service. It being a global company, it has multicultural outlook and it gives you great work-life balance. One of the important thing that it has seen is it has seen a growth of 270% when you talk about its investment in cloud computing domain. And that is why if you are looking to work for a company that gives you great work-life balance, that gives you good hands-on on cutting edge technology, especially in the cloud domain, definitely this is the company, because if you take a look at the numbers, 70 and 83% for the discussed parameters, I'm sure that you would agree with me equally. So 7th on this list, we have VMware. And when you talk about VMware, it is one of the old horses when it comes to cloud computing. When you talk about virtual machines, they have been doing this for a very long time. Even before the great cloud computing giants came into market, they have a great stronghold when it comes to SaaS and IaaS kind of services. Plus, the work-life balance that the company has to offer is fairly good. Now, the number of employees this company has is comparatively lesser, and that is why they actually focus on their employees a lot more. And that is why we see that 84% of the employees recommending this company and 98% approving their CEO. Next on this list, we have Adobe, and this company is, I'm sure, known to many of you out there. Why does this company holds a great value when it comes to cloud computing? Again, the standard features are there, like there is great work-life balance,
And if you take a look at Glassdoor rating, I mean, these numbers, they directly pop up from Glassdoor. 85% people recommend this company to their peers and 98% approve of the CEO. Apart from that, this company is transitioning into cloud computing like no other company. And that is why you're going to see this company adapting to this atmosphere or to this technology in a much better manner. And that is why if you are looking for a company where you'd have sufficient exposure to other technologies plus cloud computing, definitely it would give you that versatile option to choose from. We are halfway on this list and we find Google here. Now, when I say Google, I'm sure I don't have to tell or talk a lot about this particular company because we all know how good a company this is. And that also ensures one more thing, that they have a lot of data to deal with. So yes, definitely they're going to have their own cloud vendor or their own cloud vending service. It is called as Google Cloud Platform. And if you talk about big data, machine learning, this is one of the best cloud service providers that is there in the market. If you talk about other things, whether you should work for a company like Google, definitely you should. I mean, if you compare the other lists that talk about best companies you can work for as any professional, Google would definitely be there because they have great number of amenities. They take care of a lot of things, whether you talk about your health, your mental fitness, your career needs, your career opportunities, your future growth, and the wide reach it gives you when you talk about yourself and your career development. I mean, it is one of the best companies that is there in the market, and that is why it finds fifth positioning in this list. Now, fourth on this list, we have Salesforce. Now, Salesforce ranks second on Forbes list for the best companies to work for in general. So it speaks volumes for this company in itself. What are the other features that it has to offer to you? It is one of the best for CRM. And apart from that, it is very good when it comes to SaaS and PaaS services. Hence, when you talk about cloud computing, you're going to have great stuff to work on, great domains to work on. And when you talk about work-life balance, yes, it is one of the best companies that is there in the market. And the numbers speak for themselves. I mean, 87% and 97% are great numbers to have for. And the number of employees that work for companies like these is also very large. So these numbers are fairly quantifiable and justifiable. Now we are approaching the end part of our list. So let us take a look at the third company in this list, SAP. Again, you might have heard about this company because again, it is one of the world leaders or one of the best companies that is there in the market. Again, are they good for cloud computing? Well, they have done great work when you talk about cloud integration and the fact that cloud is booming these days. They have embraced cloud computing. And if you are looking for some very good work in the cloud computing domain, this again is a very good company. If you talk about their future investments and the projects they're going to take up, it has a great forecast when you talk about cloud computing. It is highly flexible and gives you great work-life balance. And that is why 91% of the employees recommend this company to their peers. And how good is the CEO approved? 96% says Glassdoor. Next, Microsoft. Yes, it is one of the best companies in the world for software in general. And when you talk about their cloud platform, Microsoft Azure, it is one of the best in the market and it has grown tremendously in last 5 years. So if you are wondering or wanting to have a career in this particular domain, definitely you are at a very good position because cloud computing is taken care of by Microsoft in a very good manner. They have Microsoft stack of products which are huge in number, and these projects or products easily kind of integrate with this product, that is Microsoft Azure. If you talk about blockchain and ML, they have done great amount of research in this domain. And if you are looking for some great work, definitely this is a place where you can start your career from. And if you talk about amenities, I mean, ask any employee who works at Microsoft and they would tell you how great a company it is. Would you recommend this company to your employees? 96% say yes, I would recommend this company to my peers, my friends, and other employees. Do they approve of their CEO? Definitely yes. 96% of the people believe that their CEO is great. And that is why Microsoft finds second position on this list. Now you might wonder why second? Because the number one position goes to a company called as Amazon. Now, if you take a look at some of its stats, I mean, recommendation is 85%, approval of CEO is 95%, which is not actually very great. But what makes this company stand out is the fact that it boasts of a cloud vendor called as AWS, that is Amazon Web Services, which has been leading the market for a very long time, meaning it has a lot of cloud services to boast of. and it has gathered the highest market share when you talk about cloud computing. And there are reasons for it. The amount of services and the kind of services Amazon provides when you talk about cloud computing is simply great. And that is why it has a very wide reach in the current market. If you talk about latest cutting edge technology like DevOps, blockchain, definitely it stands up right at the top. Work-life balance, if you talk about cloud computing, definitely it is one of the best companies because they have one of the best platforms to work for, and you would be getting to work on quite a few good things. Now, the numbers might not be that great, but the fact that Amazon is a huge company and a part of it works for cloud computing suggests that these numbers are not true in complete sense. But still, looking at these numbers, these are not bad numbers, these are great numbers. And if you talk about cloud computing in general, it had to be Amazon because AWS is a fantastic service. And if you are planning to start a career in cloud domain, definitely starting with Amazon Web Services would definitely be a great choice.
Let us see the basic interview question. We'll start with the first question. Now the question is, describe the three major categories of cloud service and the AWS products that are based on them. So if we understand the question, they have asked the three major categories of the cloud and their products as well, right? Now here, as you know, we have three types of clouds, right? Public cloud, private cloud, and hybrid cloud. Now, public cloud is nothing but it is a cloud computing environment that is built using the end users, not owned IT infrastructures. Now, for example, Alibaba Cloud, Amazon Web Services, Google Cloud, IBM Cloud, and Microsoft Azure are the few of the biggest public cloud service providers. The cloud computing environments that is built using the end users, not owned IT infrastructure. These days, public cloud don't always have free structures because some providers let users utilize their services for free. Now we will look into the private clouds. Now, private clouds are also a cloud computing platform that are only used by one individual or a group of individuals. Currently, businesses are constructing private clouds on rented, off-site data centers controlled by vendors. Then comes the hybrid clouds. Hybrid clouds is a combination of public cloud and a private cloud. And it is an IT environment made up of the several environments that appear to be connected by LAN or a virtual private network. Depending on who you ask, the criteria of hybrid clouds might vary from their characteristics, and those can be complicated too. However, when apps can be moving in or out of many distinct yet connected environments, or every IT systems turn into a hybrid cloud. Now let us see the cloud services. Here we have the major services like infrastructure as a service, platform as a service, and finally we have software as a service. Now we will see each of it in a detailed form. Now we will come to infrastructure as a service. What does it mean? It means a cloud service provider that manages the infrastructure for you. The user has access through API or a dashboard and especially rents the infrastructure. The provider takes care of any hardware, networking, hard devices, and data storage and servers. Now, if we look at the platform as a service, it is a hardware and an application software platform. These are provided and managed by the outside cloud service providers. But the users can handle the apps running on the top of the platform and the data that app relies on. Primarily for developers and programmers, the platform as a service gives user a shared cloud platform for application development and management without having to build and maintain the infrastructure usually associated with the process. Now, if we look into the software as a service, software as a service is a service that delivers a software application, which the cloud service providers manages to its users. Typically, the software as a service apps are web applications or mobile applications that the user can access via a web browser. Software updates, bug fixes, and other general software maintenance are taken care of the users.
and they connect to the cloud applications via the dashboard or API. Software as a service also eliminates the need to have an app installed locally on each individual user's computer, which allowing the greater methods of group or team access to the software. So I hope you understood the answer. Here I have just given you the full explanation where you could answer just the public cloud, private cloud and hybrid cloud and their services to the interviewer. Now let's move on to the next question. How do the availability zone and the region related to one another? Here you need to understand the availability zone and the region's difference. So each region has multiple isolated location known as availability zone. The code for availability zone is its region code followed by the letter identifier. For example, US East 1A. So when you launch an instance, you select a region and a virtual private cloud. And then you can either select a subnet from one of the availability zone or let the AWS choose one for you. If you distribute your instance across the multiple availability zone, you can also use the elastic IP addresses to mask the failure of an instance in another availability zone by rapidly mapping the address to an instance in another availability zone. Now, when it comes to region, each region is designed to be isolated from one another region. This achieves the greatest possibility fault tolerance and stability. When you view your resources, you see only the resources that are tied to the region that you specified. This is because the region are isolated from one another and we don't automatically replicate the resources across the region. When you launch an instance, you might select an AMI that's in the same region. If the AMI is in the another region, you can copy the AMI to the other region you are using it. Now we will look into the next question, that is, what is auto-scaling? AWS auto-scaling monitors your applications and it automatically adjusts the capacity to maintain the steady, and it also predicts the performance at the lowest possible cost. The service provides a simple, powerful user interfaces that lets you build a scaling plan for resource including Amazon EC2 instance, Amazon ECS tasks and indexes. Let's move on to the next question. What is geo-targeting in CloudFront? Now, if we look at the explanation, in Amazon CloudFront, we can detect the country from where the end users are requesting our content. This information can be passed to our origin server by the Amazon CloudFront. It is sent to a new HTTP header. Based on the different countries, we can generate the different content from different versions of the same content. So these versions can be cached at different edge locations that are closer to the end user of that country. In this way, we are able to target our end users based on their geographic locations. With that, we'll move to the next question. What services can be used to create a centralized logging solution? The essential services that you can use are Amazon Cloud Watch Logs, which can store them in the Amazon S3. And then you can use the Amazon Elasticsearch to visualize them. And also you can use Amazon Kinesis Firehose to move the data from Amazon S3 to Amazon Elasticsearch. Now let's move on to the next question. What are the different types of virtualization in AWS and what are the difference between them? Now, if we take the virtualization, it is divided into three types. That is hardware virtual machine, para-virtualization on HVM. Now, what is hardware virtual machine? Hardware virtual machine, in short HVM, it is a fully virtualized hardware where all the virtual machine acts separate from each other. These virtual machine boot by executing a master boot record in the root block device of your image. Now let us see the para-virtualization. Para-virtualization is the bootloader that boots the para-virtualization AMIs. Now the paravirtualization chain loads the kernel specified in the menu. Now let us see what is paravirtualization on HVM. Now paravirtualization on HVM helps the operating system takes advantage of storage and network input-output that available through the host. Now the next question is explain what T2 instances are. T2 instances are burstable performance instances that provides base level of CPU performances with the ability to burst above the baseline. Now, the baseline performances and the ability to burst are governed by the CPU credits. Here, the T2 instance accumulate the CPU credits when they are idle, and they can consume the CPU credits when they are active. Now that we are done with the basic level of AWS interview questions, now let's jump into some of the AWS EC2 questions. In that, we will see what is Amazon EC2. Here, Amazon EC2 is a short form of Elastic Compute Cloud, and it provides the scalable computing capacity. Using Amazon EC2, which eliminates the need to invest in hardware, and also it leads to the faster development and the deployment of the applications also. You can use Amazon EC2 to launch as many or as few virtual servers as you need. And you can also configure the security and networking and also manage the storage. It can also scale up or scale down to handle the changes in requirements, and it can reduce the need to forecast traffic. EC2 provides the virtual computing environments called instances. With that, we will move on to the next question. What are Solaris and AIX operating system? Are they available with AWS? Now, let us see about the Solaris and AIX operating system. Solaris is an operating system that uses the Spark processor architecture, which is not supported by the public cloud currently, where AIX is an operating system that runs only on Power CPU and not on Intel, which means that you cannot create AIX instance in EC2. Since the both operating systems have their limitations, they are not currently available in AWS. Now let us see the next question, that is what are key pair in AWS? Now the key pair are password protected login credentials for the virtual machines that are used to prove our identity while connecting to the AWS EC2 instances. The key pair are made up of the private key and a public key, which lets us connect to the instances. Let's move on to the AWS S3 interview questions. Now let us see what is Amazon S3 is. Amazon S3 is a short form of Simple Storage Service. The Amazon S3 is the most supported storage platform available in the Amazon, where S3 is object storage that can store and retrieve any amount of data from anywhere. Despite that, it is versatility, and it is practically unlimited as well as a cost-effective because its storage is available on demand. In addition to its benefits, it offers unprecedented levels of durability and availability. Amazon S3 helps to manage data for cost optimization, access control, and compliances. Let's move on to the next question. How do you allow a user to gain access to a specific bucket? Here, you need to follow few steps. That is, you need to start, categorize your instances. After that, you need to define how authorized users can manage specific servers. Then, you can lock down your tags and you can attach your policies to IAM users. With that, you can be able to allow the users to gain access to a specific bucket. Let's move on to the next question. What are the storage classes available in Amazon S3? Here, the storage classes that are available in the Amazon S3 are Amazon S3 Glaciers Instant Retrieval Storage class, followed by Amazon S3 Glacier Flexible Retrieval Storage class,
Amazon S3 Glacier Deep Archive. Also, we have S3 Outpost Storage class, followed by Amazon S3 Standard Infrequent Access. Also, we have Amazon S3 One Zone Infrequent Access, Amazon S3 Standard, Amazon S3 Reduced Redundancy Storage. Finally, we have Amazon S3 Intelligent Tiering. Now we will move on to VPC AWS interview questions. Let's see what is Amazon Virtual Private Cloud, that is VPC, and why it is used. Virtual Private Cloud is the best way of connecting to your cloud resources from your own data center. Once you connect your data centers to the VPC, that is Virtual Private Cloud, in which your instances are present. Each instance is assigned to a private IP address that can be accessed from your data center. That way, you can access your public cloud resources as if they were on your private network. Now, let us see the next question. How do you connect multiple sites to a VPC, that is Virtual Private Cloud? The hub features of VPN gateway allows the large-scale enterprises to connect multiple offices to each other, and it connects the multiple offices to Virtual Private Cloud too. Now we will see how to connect multiple sites to a VPC. Now we have different steps over here. We'll start with the first step by creating a VPN gateway. Then, after you create a VPN gateway, you need to create a customer gateway for each offices. In the next step, we need to create an IP section for VPN connection for each office. Then in the fourth step, you need to configure the routes for the VPN gateway. And in the next step, we need to configure the on-premises gateway devices. And finally, you need to test the network connectivity. By following these steps, you can easily connect multiple sites to a VPN. Let's move on to the next question. Name and explain some security products and features available in VPC. Here is a selection of security products and features. Let's see each in details. We have security groups, network access control list, and flow logs. Here, the security groups acts like a firewall for EC2 instances by controlling inbound and outbound traffics at the instance level. Now we will see the network access control list. It acts like a firewall for the subnets, controlling the inbound and outbound traffics at the subnet level. Then finally, the flow logs. These capture the inbounds and outbound traffic from the network interfaces in your VPC. Let's move on to the next concept, that is cloud formation. Let's see the question. What are the steps involved in a cloud formation solution? So here are the few steps involved in cloud formation. Here in the first step in the cloud formation is to create or use an existing cloud formation template using JSON or YAML format. In the next step, you can save the code in an S3 bucket which serves as a repository for this code. And in the next step, you can use AWS Cloud Formation to call the bucket and create a stack on your template. And finally, this cloud formation reads the file and it understands the services that are called and their orders and the relationship between the services. And it provisions the services one after the other. Now let us see the next question. How is AWS Cloud Formation different from AWS Elastic Beanstalk? Now let us see the difference between these both AWS Cloud Formation and AWS Elastic Beanstalk. Here in AWS Cloud Formation, it helps you to provision and describe all the infrastructures, resources that are present in your cloud environment. On the other hand, AWS Elastic Beanstalk provides an environment that makes it easy to deploy and run the application in the cloud. AWS Cloud Formation supports the infrastructure needs of various types of applications like legacy applications and existing enterprise applications. On the other hand, AWS Elastic Beanstalk is combined with the developer tools to help you to manage the life cycle of your application. With that, we'll move into the next question. What are elements of AWS CloudFormation template? Here, the AWS CloudFormation templates are YAML or JSON formatted text files that are compressed of 5 essential elements. They are template parameters, output values, and data tables, resources, and finally file format versions. Now let us see the questions from Elastic Block Storage. The first question here in Elastic Block Storage is, how can you automate EC2 backup using EBS? Now, here are the following steps in order to automate EC2 backup using EBS. First, let's get the list of instances and let's connect to the AWS through API to list the Amazon EBS volumes that are attached locally to the instances. Now, list the snapshot of each volume and assign a retention period of the snapshot. Later on, create a snapshot of each volume. Now, make sure to remove the snapshot if it is older than the retention period. By doing this, you can automate EC2 backup using EBS. Now, let's move on to the next question. What is the difference between EBS and instant storage? Here, the EBS is a kind of permanent storage in which the data can be restored at a later point. When you save the data in the EBS, it stays even after the lifetime of the EC2 instance. On the other hand, instant storage is a temporary storage that it is physically attached to the host machine. With an instant storage, you cannot detach one instance and attach it to the another. Unlike in EBS, the data in an instant storage is lost if any instance is stopped or terminated. Let's see the next question. Can you take a backup of EFS like EBS? If yes, can you please state how? The answer for this is obviously yes. You can use the EFS to EFS backup solution to recover from unintended changes or deletion in Amazon EFS. Now, if you follow those steps given below, you can easily take the backup if you follow these steps. The step 1 is to sign into the AWS Management Console, and you need to click the Launch EFS to EFS Restore button. Then in the next step, you can use the region selector in the console navigation bar to select the region. After that, you need to verify if you have chosen the right template on the Select Template page. Then you need to assign a name to your solution stack. Finally, you need to review the parameters for the template and modify them if necessary. Let's move on to the next question on Elastic Load Balancing. What are the different types of load balancer in AWS? Here are the 3 types of load balancer that are supported by the Elastic Load Balancing. Those are Application Load Balancer, Network Load Balancer, and finally Classic Load Balancer. And the next question is, what are the different uses of the various load balancer in AWS load balancing? So, as I said in the previous question, we had 3 types of load balancer, that is Application Load Balancer, Network Load Balancer, and Classic Load Balancer. Now let us see each of it in a detail. Now, Application Load Balancer used if you need flexible application management and TLS termination. Now, Network Load Balancer are used if you require extreme performance and static IPs for your applications. Now, what does the Classic Load Balancer do? It is used if your application is built within the EC2 Classic network. Now, in the next question, we will see the difference between the cluster and load balancing. Here, the cluster is a method of turning the multiple computer servers into a cluster, which is a group of servers that act like a single system. And also, you can have an active-to-active cluster, but it will require multiple instances of SQL servers running on each node. Now, what is load balancing? Here, the load balancing is about the distribution of workloads across multiple computing resources, such as computers, server cluster, network links, etc. Now, let us see the questions from AWS security. Now, what is identity and access management and how does it work? Now, the identity and the access management, that is IAM, ensures that the right people and the job roles in your organizations can access the tools they need to do their jobs. Now, here the identity management and the access system enables your organization to manage the employees app without logging into each app as an administrator. Identity and the access management systems enables your organization to manage a range of identities including people, software, and hardware like robotics and IoT devices. Let's see the next question here. What are the different AWS IAM categories that you can control? By using AWS IAM, you can create and manage the identity and access management users. You can also create and manage the IAM groups. You can manage the security credentials of the users too. Also, you can create and manage the policies to grant access to AWS services and resources. Now, let us see the difference between IAM role and IAM users. The two key differences between the IAM role and IAM users are: Identity Access Management role is an IAM entity that defines a set of permissions for making AWS services requests, while an IAM user has a permanent long-term credentials. It is used to interact with the AWS services directly. In terms of in the IAM role, it is trusted entity like IAM users, applications, or an AWS services assuming the role, whereas the IAM users has full access to all the AWS IAM functionalities. Let us see the question from AWS Route 53. Now let us see what is Amazon Route 53. Here the Amazon Route 53 is a highly available and scalable domain name systems web service. Here the Route 53 connects the user request to the internet application that are running on the AWS or on premises. The name refers to the TCP or the UDP port 53, where the DNS server requests are addressed. The name of our services, that is Route 53, comes from the fact that DNS servers respond to the queries on port 53, and it provides the answers that route end users to the applications on the internet. Let's move on to the next question. What is the difference between the latency-based routing and GeoDNS? Here the geo-based DNS routing takes the decisions based on the geographic location of the request, whereas the latency-based routing utilizes the latency measurements between the network and the AWS database centers. Here, the latency-based routing is used when you want to give your customers the lowest latency possible. On the other hand, geo-based routing is used when you want to direct the customer to different websites based on the country or the region they are browsing from. With that, I hope you understood. Let's move on to the next question. How does Amazon Route 53 provides high availability and low latency? Here we have around 3 resources, that is globally distributed servers, dependency, and optimal locations. Here about the global distributed server, the Amazon is a global service and consequently has the DNS services globally. Any customer creating a question from any part of the world gets to reach a DNS server local to them, and that provides the low latency. Now let us see the dependency. Route 53 provides a high level of dependability required by the critical applications. Now if we see the optimal locations, Here, the Route 53 uses a global Anycast network to answer those queries from the optimal position automatically. Let's see the next question from Configure AWS. How does AWS Config work with the AWS CloudTrail? Here, the AWS CloudTrail records the user API activity on your account and allows you to access information about the activity. By using the CloudTrail, you can get the full detail about the API actions, such as the identity of the caller, time of the call, request parameters, and response elements. On the other hand, AWS Config records point-in-time configuration details for your AWS resources on configuration items. You can use the configuration item to ascertain what your AWS resources looks like at the given point of time. Whereas, by using the CloudTrail, you can quickly answer who made an API call to modify the resources. Also, you can CloudTrail to detect if a security group was incorrectly configured. Let's move on to the next question. The question is like, can AWS Config aggregate data across the different AWS accounts? The answer is yes. You can set up the AWS Config to deliver the configuration updates from the different accounts to one S3 bucket. Once the appropriate IAM policies are applied to the S3 bucket. Now let us see the database AWS questions. How are reversed instance different from on-demand database instances? Here the reverse instance and on-demand instance are the same when it comes to the functions, but they only differ in how they are built. The reverse instance are purchased as 1 year or 3 year reservations, and in return you get very low hourly based pricing when compared to the on-demand cases that are built on the hourly basis. So these are the difference between the reserved instances and on-demand database instances. With that, we will move on to the next question here. Which type of scaling would you recommend for RDS and why? Here, there are two types of scaling. We have vertical scaling and horizontal scaling. Here in the vertical scaling, it lets you to vertically scale up your master database with the pressure of the button. A database can only be scaled vertically, and there are 18 different instances in which you can resize the RDS. On the other hand, horizontal scaling is good for replicas. So these are read-only replicas that can only be done through Amazon Aurora. We'll move on to the final question in the database. What is a maintenance window in Amazon RDS? And will your database instance be available during the maintenance events? Here in the database maintenance window, it lets you to decide when the database instance should be modified, and the database engine versions update and the software that patching have to occur. The automatic scheduling is done only for the patches that are related to security and the durability. By default, there is a 30 minutes value assigned as a maintenance window, and the database instance will still be available during the events, though you might not observe a minimal effects on the performances. Now let us see the advanced AWS interview questions. Here the first question in advanced level is define the snapshot in AWS Lightsail. Now the point in time backups of EC2 instance, it blocks the storage devices and the database are known as the snapshot, and they can be produced manually or automatically at any moment. Your resources can always be restored using these snapshots even after they have been created. These resources will also perform the same task as the original ones from which the snapshots were made. Let's move on to the next question. Explain Amazon EC2 root device volume. Here, the image that will be used to boot an EC2 instance is stored on the root device. Also, this occurs when an Amazon AMI runs a new EC2 instance. And this root device volume is supported by EBS or an instance store. In general, the root device data on AWS EBS is not affected by the lifespan of an EC2 instance. With this, we will see the next question. Mention the different types of instances in Amazon EC2 and explain its feature. Here we have general purpose instance, compute optimized instance, then we have memory optimized, then we have accelerated computing, then finally we have the storage optimized. So let us see these all in detail. Here the general purpose instance, these are used to compute a range of workloads and it is aid in the allocation of processing, memory and network resources. Now let's see the compute optimized instance. These are ideal for compute intensive applications. They can handle batch processing workloads, high performance web services, machine learning interference and various other tasks. Then comes the memory optimized. They process the workload that handle massive data set in memory and deliver them quickly. And the next one is accelerated computing. It aids in the execution of floating point number calculations, data pattern matching, and graphic processing. So these functions are carried out using the hardware accelerators. Then finally we have the storage optimized. They handle tasks that require sequential read and write access to the big data sets on local storage. Let's see the next question. What do you understand by changing in Amazon EC2? Here, to make limit administration easier for the customers, the Amazon EC2 now offers the option to switch from the current instance count-based limitations to the new CPU-based restrictions. As a result, when launching a combination of instance type based on the demand, utilizing it measured in terms of the number of CPUs. Now, let us understand the difference between a spot instance, an on-demand instance, and a reserved instance. Here, spot instances are unused EC2 instance that users can use at a reduced cost. When you use on-demand instances, you must pay for the computing resources without making a long-term obligations. When you use the reserved instances on the other hand allow you to specify the attributes such as the instant type, platform, dependencies, region and availability zone. Now let us see some of the scenario-based questions here. Now try answering this scenario-based question. I have some private servers on my premises. Also, I have distributed some of my workloads on the private cloud. What is this architecture called? I will give you some of the options here, such as the virtual private network, private cloud, the virtual private cloud, and the hybrid cloud. And if you know the answer, please pause the video and just go down below and comment there. The answer is the hybrid cloud. Now let us see the explanation here. So the answer for this is hybrid cloud because we are using both the private cloud and your on-premises services, that is the private cloud. To make this hybrid architecture easy to use, wouldn't it be better if your private and public cloud were all on the same network? This is established by including your public cloud servers in a virtual private cloud and connecting this virtual cloud with your on-premises services using a virtual private network. I hope you understood this question. Let's move on to the next scenario-based question. Assume your business prefers to use its email address and the domain to send and receive the compliances of emails. So what service do you recommend to implement it easily and budget friendly? Now, the answer for this would be the Amazon Simple Email Services, called Amazon SES. It is a cloud-based email sending services. So, this could easily solve the problem of sending the email and receiving the email at a instance. With this, let's move on to the next question. On an EC2 instance, an application of yours is active. Once the CPU usage on your instance hits 80%, then you must reduce the load on it. What strategy do you use to complete this task? If you have any idea on this question, please comment below. Now the answer for this would be, now it can be accomplished by setting up an auto-scaling group to deploy the additional instances. When an EC2 instance's CPU use suppresses 80% and by allocating the traffic across the instances via the creation of an application load balancer and the designation of the EC2 instances as target instances. Let's move on to the next question. Here we have another scenario-based question. Now, you need to configure an Amazon S3 bucket to the server static assets for your public-facing web application. Which method will ensure that all the objects uploaded to the bucket are set to public read? Here are the options. Set permissions on the object to public read during upload. The next option is configure the bucket policy to set all the objects to public read. The next option will be to use AWS identity and access management role to set the bucket to public read. Finally, the Amazon S3 objects default to public read, so no action is needed. Now, comment the answer below in the comment section. Here the option is configure the bucket policy to set all the objects to public read. Here I will give you the explanation for this option. Here, rather than making changes to every object, it is better to set the policy for the whole bucket. Here, the identity and access management is used to give more granular permissions since this is a website. All the objects would be public by default. Now, let us see the final question in the scenario based. In AWS, there are 3 different storage services are available, such as EFS, S3 and EBS. When should I use Amazon EFS versus Amazon S3 versus Amazon Elastic Block Store? Here, the Amazon Web Services, that is AWS, offers the cloud storage services to support a wide range of storage workloads. Amazon EFS is a file storage service for use with Amazon Compute, such as EC2, containers, and serverless, and on-premises servers too. And Amazon EFS provides a file system interfaces, file system access semantic, such as strong consistency and file locking, and concurrently accessible storage for up to 1,000 of Amazon EC2 instances. Here, the Amazon EBS is a block-level storage services for use with Amazon EC2. The Amazon EBS can deliver performance for workloads that require the low latency access to data from a single EC2 instances. Here comes the AWS S3. Here, this AWS S3 is an object store services. AWS S3 makes the data available through an internet. The Amazon S3 makes the data available through an internet API that can be accessed anywhere. With that, we have come to an end of this topic. Until then, happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!